Welcome to Backend Development with .NET. In this course, you'll gain the knowledge and tools to build robust, efficient backend systems using the .NET platform. Mastering these concepts is essential for developers aiming to create modern, scalable applications that meet the demands of today's technology landscape. We will begin by exploring the .NET platform, focusing on its features and functionalities, and comparing the .NET framework with .NET Core. You'll also learn how to set up the development environment, understand C# syntax, and work with common libraries and packages. Next, we'll cover building web APIs using ASP.NET Core, including creating a basic web API, implementing routing and attribute routing, and integrating dependency injection. We'll also address error handling and logging to ensure reliable API development. Then we'll examine serialization and deserialization in .NET, discussing how to handle these processes while efficiently considering performance and security best practices to safeguard your applications. Following that, we'll explore middleware and open API integration in ASP.NET Core, focusing on how middleware manages requests and responses, and how to use Swagger to generate API clients. We'll also cover best practices for designing effective middleware. Finally, we will focus on how Microsoft Copilot can assist with API development, from writing and debugging API code to implementing middleware and applying Copilot in a comprehensive API development project. By the end of this course, you'll have the skills and confidence to develop modern, scalable backend systems using the .NET platform. We look forward to guiding you through this crucial step towards mastering backend development. Welcome to Introduction to .NET and its Architecture. In this module, you'll explore the essentials of the .NET platform, including setting up your environment and understanding C# basics. These skills are vital in building efficient, modern applications that use .NET's powerful tools and libraries. We will begin by providing an overview of the .NET platform and discussing its key features and functionalities. This makes it essential for building modern applications. Next, we'll compare the .NET framework to the modern .NET platform. We'll highlight the differences and when to use each in development. Then we'll explore the basics of C# syntax and its core features. We'll learn how it integrates with the .NET ecosystem. Finally, we'll introduce NuGet and package management, focusing on identifying and using common libraries and packages to streamline your development process. By the end of this module, you'll have the foundational knowledge to work confidently with the .NET platform, from setting up your environment to mastering C# basics and managing packages. Let's begin.
Hi, my name is Avanindra Parichuri. I'm a Principal Engineering Manager here at Microsoft. I run the Microsoft Entra Gateway service. This is the gateway that takes in all the internet-facing traffic into the authentication stack. Previously, this was known as Azure Active Directory and currently Microsoft Entra. .NET is basically every service we run or my team owns, they're all .NET based services. So we specifically run on .NET 8, which is the latest LTS long-term support release. We run on top of the HTTP sys server. So when you run on .NET, you can basically run on 3 different servers: Kestrel, HTTP sys, and IIS. So we chose the HTTP sys server because it has really good TLS performance. And yeah, so that's basically our setup. So one of the main things I'd say is that do not write your own serializers and deserializers. That's really the answer. Unless you know really what you're doing, always use standard libraries and do not attempt to write your own. That's how we ensure security and efficiency while dealing with it, right? Again, things like input sanitization, sizing limits, making sure that we don't serialize and deserialize beyond a certain limit, not allowing unbounded recursion, We also have this tooling in Microsoft called component governance. It's a static analyzer. It'll actually flag things that have known vulnerabilities and says, hey, don't use this, don't use that tooling, and it will keep yelling at us till we go fix that or don't use that component at all. One of the examples is recently in .NET 6, binary formatter, which is used for serialization, was deprecated, and component governance told us, hey, don't use that because that has a known vulnerability. So yeah, those are the ways. And also the other one I would suggest is always, if you're a .NET dev, and I'm talking in the context of .NET development, always use the latest .NET patch, because the .NET team is really great in terms of patching up and fixing anything that is a known vulnerability. So if you don't want to be vulnerable and you want to be really secure, not just in the context of serialization and deserialization, but in general, always using the latest .NET patch, monthly patch, would go a long way in terms of ensuring security and robustness for your services. So one of the key things when really resolving a complex bug is the ability to reproduce that bug on demand, right? Not the customer reproducing, but are you able to reproduce the bug on demand, right? That helps with two things, right? You're really able to understand the internals of the bug, and two, when you fix it, you're able to verify that it was actually indeed fixed. Otherwise, how do you know you fixed? You think you fixed it, but you didn't, right? Oftentimes, I notice engineers assume that a bug is in a certain place because it looks like it, and we fix that, and lo and behold, the same issue again happens a few weeks later because we didn't really fix the actual bug. We didn't actually repro it, right? So we thought that was the bug, and we didn't really fix the actual bug. So I always tell folks to have an on-demand repro of the bug, however hard it may be. And sometimes I hear things such as, hey, it only happens in production. And that is true, right? But that's where the discipline comes in. You have to kind of create the same conditions, and it can take a lot of time to reproduce it, right? Sometimes it might take even weeks, and that's okay. But you got to keep plugging away till you get a really good repro of the situation, and that's really the key to a good root cause and resolving. So recently, we had this complex issue with a data download issue that is causing severe garbage collector issues on our service. That performance issues, which was causing request queuing, latency, and so on. Because of this data download issue, too many Gen 2 garbage collections, as we call them, were getting triggered too frequently due to the increase in the number of allocations. And allocations comes with if you're not handling the data download properly, right? And as a result, there was a lot of generational promotion that was going on, which leads to badness in the system, right? And the solution that we really came up with for this is always garbage collection issues. They always come up with allocation rates going up. So we had to really write allocation free code by pooling memory. Instead of creating memory each time, we would just pool existing memory, right? And that's kind of how we got rid of that problem completely at this point. And again, we did the same thing, right? We had to get a repro of the system, we had to get traces, and we had to get traces from production, and then we had to get traces from what we thought was a repro, and matching the traces to ensure that we're actually fixing the bug that we think there is. And yeah, so that's the, I guess, a life cycle of how bugs get fixed and root caused. Yeah. Engineering blogs, for example, the Netflix engineering blogs are a great resource. I just talked about garbage collection in the previous answer, and recently I was reading this garbage collector article that the Netflix engineering team wrote, and they were talking about the exact same things that we do with respect to pooling and lower allocations, and that's one of the things. And the other resources are .NET blogs. .NET puts out a lot of amazing blogs very often, which improve your understanding of the technology. And I also pretty religiously follow people such as David Fowler, Stephen Tobe, Maoni Stephens. They are again, top .NET engineers who write blogs pretty frequently, and bookmarking those. I bookmark their blogs and their articles, and when they write something, I go read that the same day. And yeah, that's some of the ways I keep in touch with what's the latest and greatest. Yeah. The collaboration is the same. It doesn't matter if they're front-end developer or DevOps team. We collaborate the same way with all teams, right? We make sure that we have a common aligned goal and and a vision, and we collaborate on that. A big role, actually. Like I said, one of the things that we use is forking, and that is basically feedback from clients, right? And even in our we pilot a lot of things in canary regions. We have a tight integration loop with customers and clients to make sure that things are working with respect to what our expectations are they actually matching and improving customer and clients lives as we expect them to be, or is it all in our minds in terms of, hey, this is a great thing, right? So that's a super valuable feedback for us. So our stage rollout also allows us for integrating feedback quickly into our processes. And actually even the .NET team does this. So they pilot various releases of theirs on large first party customers to ensure that the products that they've released or the improvements that they've released are actually resulting in improvements in production, and not just in paper. So yeah, it's super important.
The .NET platform has been a cornerstone of software development for over 2 decades, evolving significantly to meet the changing needs of developers and the industry. From its early days with the .NET framework to the modern unified .NET platform, .NET has continuously adapted to new technologies and development trends. We'll explore the history and evolution of the .NET platform, highlighting key milestones and providing an overview of the latest version, .NET 8. Understanding this evolution will give you a deeper appreciation of how .NET has shaped and continues to influence software development. In this video, we will explain the history and evolution of the .NET platform. The journey of .NET began in the late 1990s when Microsoft recognized the need for a unified platform to support the growing demand for web and desktop applications. The .NET framework was officially released in 2002 as a comprehensive development platform designed to support the creation of Windows applications. It included the Common Language Runtime, or CLR, which provided a managed execution environment, and the Base Class Library, or BCL, offering a wide range of reusable code. The CLR allowed code from different languages to run together, while the BCL provided a standard set of tools usable across multiple languages, improving consistency and efficiency. Together, these developments made programming faster and more reliable. As a part of this initial release, ASP.NET for Web was introduced, simplifying the development of dynamic web applications. ASP.NET provided a powerful and flexible environment for building server-side web applications, supporting web forms and, later, the Model View Controller, or MVC architecture. The goal of the .NET framework, including ASP.NET, was to simplify application development by providing a consistent object-oriented programming environment. This enabled developers to use multiple programming languages such as C#, VB.NET, and F#. The .NET framework also aimed to reduce the complexity of Windows development while providing robust support for web applications through ASP.NET. Recognizing the limitations of the Windows-only .NET framework, Microsoft released .NET Core in 2016 as a cross-platform open-source alternative. .NET Core was designed to run on Windows, Mac OS, and Linux, offering improved performance, modularity, and flexibility. This release marked a significant shift towards cross-platform development and paved the way for the future of .NET. In addition to being cross-platform, .NET Core introduced a more modular architecture, allowing developers to include only the libraries they needed. This reduced application size and complexity. Furthermore, .NET Core supported the development of microservices and modern cloud-based applications. This became increasingly important as cloud computing gained prominence. With the release of .NET Core 3.0 in 2019, Blazor Server was introduced as a new framework for building interactive web user interfaces, or UIs, using C#. Blazor WebAssembly followed in 2020 with .NET Core 3.1, allowing C# code to run directly in the browser. These innovations, along with improved tooling and support for containerization and DevOps practices, solidified .NET Core as a forward-looking platform that addressed the evolving needs of modern software development. In 2020, Microsoft introduced .NET 5, marking the beginning of a unified platform that brought together .NET Core, Xamarin, a platform for building cross-platform mobile apps, and parts from the .NET framework into a single framework known simply as .NET. This unification aimed to simplify development by providing a consistent environment for building all types of applications, whether web apps, mobile apps, desktop applications, or cloud services. .NET 5 retained the cross-platform capabilities of .NET Core while enhancing performance, flexibility, and tooling across multiple operating systems. This unification under .NET 5 allowed developers to share code more easily across different application types, such as web applications built with ASP.NET Core, mobile apps built with Xamarin, and later .NET MAUI, all within a single cohesive ecosystem. However, it's important to note that the original .NET framework, primarily used for legacy Windows applications, was not merged into .NET 5 and continues to exist as a separate platform. The latest version, .NET 8, released in 2023, continues to build on the foundation laid by its predecessors, introducing new features and significant improvements. One of the standout features is native AOT, which stands for Ahead of Time Compilation. This allows applications to be compiled directly to native code, eliminating the need for JIT, or just-in-time compilation at runtime. This leads to faster startup times, reduced memory usage, and smaller application size. This makes it ideal for microservices and containerized applications. Another significant addition is the improvement of .NET's front-end framework, Blazor. The improvements include the ability to combine server-side and client-side rendering. This flexibility helps optimize performance and interactivity based on specific use cases. Additionally, .NET 8 further enhances its cloud-native capabilities, offering deeper integration with cloud services like Azure and improved support for containerized applications. These advancements, along with continued performance optimizations and new features like improved WebAssembly debugging, make .NET 8 a powerful and versatile platform for modern software development across a wide range of environments. In this video, you learned about the history and evolution of the .NET platform, from its origins with the .NET framework to the modern unified .NET platform we use today. Key milestones were described, like the introduction of .NET Core and the transition to the unified .NET platform with .NET 5. We also provided an overview of the latest version, .NET 8. Understanding this evolution helps you appreciate the power and flexibility of the .NET platform and prepares you to leverage its full potential in your future projects. Imagine you're a developer in the early 2000s, tasked with building an application that needs to run on Windows, Mac OS, and Linux. You need to create separate versions of your codebase for each platform, a process that's not only time-consuming but prone to errors. This often led to inconsistent user experiences and delayed releases. These are frustrations that many developers still remember today. But as the demand for cross-platform applications grew, so did the need for a more efficient solution. Enter modern cross-platform development tools like .NET. These have revolutionized the way we build applications by allowing developers to write once and deploy anywhere. In this video, we will describe the cross-platform capabilities of the modern .NET platform. Let's begin by discussing some benefits of cross-platform development. Cross-platform development addresses challenges by allowing developers to write code in a familiar language that can be used across different platforms. This approach streamlines the development process and enables developers to share code between different applications regardless of the platform. For instance, the same codebase can be used for a desktop application on Windows and a mobile app on iOS or Android. This significantly reduces the amount of redundant work that's required. Now let's explore some of the different platforms that you can target with .NET. One key area where .NET has made a significant impact is web development. With ASP.NET, developers can create dynamic web applications using models like MVC, which stands for Model View Controller, Razor Pages, and Blazor. These technologies allow for the creation of scalable and maintainable web applications, whether they are running on Windows servers or Linux-based environments. Stack Overflow, a leading Q&A platform for engineers, utilizes .NET Core to power its applications, which significantly improves development time by increasing performance, flexibility, and scalability. By porting its entire application to .NET Core, Stack Overflow has been able to build faster and more responsive applications, delivering information to users more efficiently and in less time. The cross-platform capabilities of .NET Core allow Stack Overflow to develop and run their applications seamlessly on Windows, macOS, and Linux environments, as well as in the cloud using Azure. Additionally, the modularity offered by .NET Core has allowed Stack Overflow to break down its larger applications into smaller, more manageable modules. This reduces complexity and lowers support costs. The open source nature of .NET Core also empowers the developer community to contribute to its environment, further enhancing the platform's capabilities. Mobile development is another domain where .NET has proven to be highly effective. With tools like Xamarin and .NET MAUI, developers can create native mobile applications for iOS and Android using a single codebase. This approach not only speeds up the development process, but also ensures that the app delivers a consistent user experience across devices. UPS utilizes .NET for mobile development to streamline its customer-facing applications, significantly improving efficiency and reducing complexity. By writing its platform-specific UPS mobile app using Visual Studio tools for Xamarin, UPS consolidated multiple codebases into a single C# codebase that works across both Android and iOS. This consolidation reduced the amount of code needed by half and enabled faster time to market for new features. Additionally, it allows UPS to deliver consistent, high-quality native mobile experiences to customers across different devices. This enhances their ability to track shipments and manage deliveries. This approach not only reduced the workload for developers, but also ensured that all users, regardless of their platform, had access to the latest app updates simultaneously. In addition to web and mobile development, .NET has also made significant strides in the field of artificial intelligence. With ML.NET, developers can integrate machine learning capabilities into their applications using the .NET ecosystem. This allows for the creation of intelligent applications that can analyze data, make predictions, and improve decision-making processes. Aveva, a global leader in industrial software, utilizes ML.NET to power its AI-driven solutions. This optimizes operations and performance across various industries. By integrating ML.NET into their .NET-based infrastructure, Aveva enables rapid development and deployment of custom machine learning models, allowing both their developers and customers to address real-time performance issues and enhance operational efficiency. This integration supports Aveva's commitment to innovation and sustainability, providing flexible, scalable AI solutions that drive industrial success and adaptability. In this video, you learned about the cross-platform capabilities of the modern .NET platform. The examples used illustrate just a few of the most popular uses of .NET, but the framework's capabilities extend far beyond these areas. Developers can also use .NET to build video games in conjunction with platforms like Unity, develop Internet of Things, IoT applications, and much more. The flexibility and power of .NET make it an indispensable tool for modern developers who need to create applications that work across multiple platforms without sacrificing quality or performance. The .NET ecosystem is rich with tools and components that empower developers to build robust, scalable applications. Whether you're a seasoned developer or just starting, understanding the essential .NET tools and resources is crucial for success. In this video, we will identify key tools and components in the .NET ecosystem. Now that we've provided the necessary background, let's explore the essential tools for .NET development, starting with one of the most popular, Visual Studio Code. Visual Studio Code, or VS Code for short, is an open source, highly configurable, cross-platform tool. It's easier to learn than most extensive development tools like Visual Studio. While Visual Studio is a fully integrated IDE built for development in the Microsoft world, VS Code strikes a balance between power and simplicity, making it ideal for getting started. There are other editors like Sublime Text and JetBrains Writer, but to explore .NET development, you need to look no further than VS Code. One of the best things about VS Code is its large library of extensions. C# Dev Kit is among the most popular for .NET developers, bringing essential features like code scaffolding, code completion, debugging, and deployment tools into your workflow. While Visual Studio Code's clickable interfaces and menus cover most tasks, the .NET CLI offers distinct advantages that make it worth knowing. A command line interface, or CLI, is a way to interact with your computer by typing text commands instead of clicking buttons. It lets you tell the computer exactly what to do, and while it might seem old-fashioned, it's incredibly powerful. The CLI is accessed through a text-based interface where you input commands. This is known as a terminal. The .NET CLI allows you to manage .NET projects with speed and precision. In fact, the CLI can be more efficient for repetitive tasks than clicking through menus. It's also essential for automating workflows and easily integrating into scripts for building, testing, and deploying applications. Additionally, the CLI provides more flexibility and control, making it a powerful tool for developers who need to fine-tune their projects. Lastly, learning the CLI gives you deeper insight into how .NET works, which can be invaluable for troubleshooting and understanding the underlying processes. Now that we understand what the .NET CLI is, let's discuss package management in .NET projects. Packages are collections of reusable code that you can include in your projects to add functionality without building everything from scratch. As you work with the .NET CLI, managing dependencies becomes crucial, and that's where NuGet packages play a vital role. Let's explore how NuGet simplifies this process and integrates seamlessly with both Visual Studio and the CLI. NuGet is deeply integrated into both Visual Studio Code and the .NET CLI, making it easy to manage the libraries and tools your projects depend on. Once you've mastered using NuGet packages, it's important to remember that you're not alone. The .NET community offers many resources and support, helping you to continue to grow as a developer. You'll often use NuGet to add official .NET packages, but it's also invaluable for integrating community-driven packages created by open-source collaborators. Many of these packages are developed and maintained on GitHub, where developers worldwide contribute their expertise. GitHub hosts these packages and supports collaboration, allowing you to create your own packages and invite others to contribute. In this video, you learned about key tools and components in the .NET ecosystem, like Visual Studio, Visual Studio Code, the .NET CLI, and the NuGet Package Manager. We also discussed the vibrant .NET community and its valuable resources. Mastering these tools and engaging with the community will boost your productivity and keep you at the forefront of .NET development. The .NET framework has been at the core of Windows-based software development for nearly 2 decades. But as technology advances, so do the tools we rely on. In this video, we will describe the features and limitations of the legacy .NET framework. Let's start by exploring key components of the .NET framework. The .NET framework's ability to support cross-language development is largely enabled by 2 key components: the Common Language Runtime, or CLR, and the Base Class Library, or BCL. The CLR allows code written in multiple programming languages to run as a single program by compiling that code into a common intermediary language, or CIL, which the CLR can execute. This means that developers can write different parts of an application in the languages best suited to each task, and then seamlessly integrate them into one cohesive program. Meanwhile, the BCL provides a standardized collection of classes, interface, and value types for .NET development. The BCL offers essential functionality such as file I/O, data manipulation, and collections. Because the BCL is consistent across all .NET languages, it ensures that developers have access to the same tools and resources regardless of the language they choose. This facilitates smooth collaboration and integration across the application. Now that we've explored the core components that make the .NET framework powerful, it's important to understand its limitations. Limitations that have become more apparent as technology has evolved. One limitation is that the framework is tightly coupled to the Windows operating system, which restricts its ability to run on other platforms like macOS and Linux. As a legacy framework, it doesn't benefit from the performance optimizations found in the more modern .NET ecosystem, leading to potential inefficiencies. Additionally, the .NET framework is monolithic, meaning that applications built on it tend to include more components than necessary. This results in larger deployment sizes and longer startup times. These limitations have led to the gradual decline in the use of the .NET framework, with Microsoft no longer recommending it for new projects. Instead, the focus has shifted to .NET, which offers better performance, flexibility, and cross-platform capabilities. Despite these limitations, the .NET framework continues to play a crucial role in maintaining and supporting legacy applications. First, many existing enterprise applications are built on the .NET framework, and these applications require ongoing maintenance and support to ensure they continue to operate effectively. Next, Microsoft provides long-term support for the .NET framework, ensuring that critical updates and security patches are available for organizations that rely on it. Furthermore, the .NET framework remains a reliable choice for applications that are deeply integrated with Windows-specific features, like those that use Windows Forms or Windows Presentation Foundation. For instance, a financial institution may rely on a complex Windows Forms application built on the .NET framework. Migrating to a newer platform could be costly and disruptive, so ongoing support for the .NET framework remains crucial. In this video, you learned about the features and limitations of the legacy .NET framework, including its architecture, language support, and extensive libraries. While platform dependency and performance issues have driven the adoption of modern platforms like .NET Core and .NET 8, the .NET framework remains vital for maintaining legacy applications, especially those tied to the Windows-specific features. Understanding these aspects explains its enduring relevance in the shift towards newer development platforms. .NET has evolved significantly from its early days as the .NET framework. Now with versions starting from .NET 5 up to .NET 8 and .NET 9 coming soon, it has unified all platforms into a single, powerful system. When the .NET framework first launched, the iPhone hadn't been invented yet, and there were still debates about whether the World Wide Web was just a passing trend. It's clear that a lot has changed since then. In this video, we will explain the key features and advantages of the modern .NET platform. If you're new to .NET, it's essential to know that older versions like .NET Core, .NET Framework, and Xamarin have been combined into one unified platform now called .NET. Modern .NET is a powerful and flexible framework that has dramatically evolved over time. It now provides a single platform for building different types of applications, ranging from mobile apps to cloud services. One of the biggest advantages of .NET is its cross-platform capability. Unlike the older .NET framework, which was limited to Windows, the current .NET also runs on macOS, Linux, iOS, Android, and even directly in web browsers. This means you can write an application once and have it run on multiple operating systems without needing significant changes. The skills you learn in this course can take you in many different directions. In addition to supporting applications that run on multiple platforms, .NET has also embraced the idea of letting developers work from any environment. The tools for building with .NET work on every major operating system, allowing developers to use the same tools, languages, and APIs, regardless of where they're developing. This consistency helps reduce the learning curve and improves productivity as developers don't need to switch between different tools and frameworks. When the .NET framework was initially released, it was closed-sourced and proprietary, meaning Microsoft controlled the code that ran .NET and had full authority to decide the platform's future. Microsoft is still a major champion of the platform, but it is now fully open source and community-driven, which means developers from all over the world contribute to its development. This community-driven approach has led to faster innovation and a more vibrant ecosystem. As a developer, you can benefit from the large amount of third-party libraries, tools, and resources available, and even contribute to the platform's evolution yourself. This is just one part of how .NET makes cross-platform development seamless. Now let's explore the key features of how .NET tools support these platforms across different environments. .NET is built to work well with modern ways of creating software, especially when it comes to working with cloud services. Cloud services are platforms that allow you to store data, run applications, and manage resources over the internet. Additionally, .NET includes tools and features that make it easy to create, deploy, and manage applications in the cloud, particularly with services like Microsoft Azure. The unified .NET also makes it easier for developers to create applications that can reliably support large amounts of users and data. It is also regularly updated to keep up with the latest tools and practices in software development. For example, .NET supports methods that help automate testing and deployment, ensuring that your applications work correctly and can be easily updated. Additionally, .NET supports various programming languages, including F#, which allows you to write code in different styles than C#, depending on what you find most effective for your project. In this video, you learned about the key features and advantages of the modern .NET platform. As you learn more about .NET, you'll discover that the framework is powerful and flexible enough to adapt to all your development needs. Whether you're building a small app for personal use or a large-scale enterprise solution, .NET provides the tools and frameworks necessary to succeed. The programming language C# enables developers to create a wide range of applications, from mobile apps to enterprise systems. In this video, we will explain the basic syntax of C# programming language. We will explore three main areas related to C# syntax basics: data types and variables, operators and expressions, and language structure. In C#, data types define the kind of data a variable can hold, like integers, strings, and floating point number data types, like double and float. To store a data value, we use a variable. In this example, we declare an integer variable named age and assign it the value of 25. The data type comes first, followed by the variable name and the assigned value. Next, let's discuss operators. Operators in C# are symbols used to perform operations on variables and values. There are several different types of operators. First, arithmetic operators include plus, minus, an asterisk for multiplication, and a / for division. These operators handle basic math like finding the sum of two numbers. Another type of operator is a logical operator. We use two ampersands together to mean and. It's used when you want to check if two conditions are both true. For example, if you want to check if a user is logged in and has admin rights, you would use two ampersands. If both conditions are true, and the overall expression evaluates as true. The other logical operator is used to mean or, and it uses two vertical lines together, or two pipes. This operator checks if at least one of the two conditions is true. If either condition is true, the whole expression evaluates as true. It only evaluates as false if both conditions are false. For example, let's say you're building a program that checks if a user is eligible for a discount. The user gets a discount if they are a member or they have a coupon. You could use the double pipe operator to check if either of these conditions is true. If the user is a member or has a valid coupon, the program will apply the discount. If neither condition is met, no discount is applied. This allows flexibility in offering promotions to users. Finally, there are assignment operators like the equal sign that assign variable values. For example, when we write int age equals 25, the equal sign assigns the value 25 to the variable age. Now let's explore how expressions are used in C#. Expressions combine variables, operators, and values that can be evaluated to produce a result. For example, int sum equals 5 plus 3. This expression adds two numbers, 5 and 3 together, and the result is stored in the variable sum. Now that we've discussed how to work with data, we must consider how all these elements come together in a complete program. That's where language structure comes in, helping you organize your code efficiently and flexibly. In a typical C# program, you have namespaces to organize code, classes as blueprints for objects, and methods to perform specific tasks. First, you can wrap your code in a namespace to provide encapsulation from other code. You can create a namespace by using the keyword namespace, followed by the name of the namespace. In the example, we have a namespace named myFirstApp. Next, you want to create a class that contains your code. Classes start with the class keyword, followed by the name of the class, and in this case, it's called program. Finally, you need to create a method inside your class named main. The code for the method starts with the word static to indicate that it doesn't need to be called on in a specific instance of your program class. Next, it has the word void, which is the return type, followed by the name of the method, in this case, main. The name is followed by an open and closed parentheses with a comma-separated list of parameters inside. Each parameter starts with the type, followed by the name of the parameter. The name can be followed by an equal sign and a default value. In this case, the main method takes in one parameter, an array of strings and named args, without a default value. This allows you to call this program from the terminal while passing along arguments. Starting with .NET 5, you can write your C# code without using a namespace, wrapper class, or main method, just like we demonstrated. This is known as using top-level statements. This has some limitations, but it's convenient for simple situations, and it's commonly used when creating .code. Now that we have the structure in our code, let's talk about control structures. One common control structure is the if-else statement. In this example, the code checks if the user's input matches the correct password. If it does, setting access to true grants access. If not, setting access to false denies access. Another common control structure is a switch statement that simplifies complex conditional logic. In this example, the program checks a variable called menu option and displays the correct page depending on the value. If none of the cases match, the default page is shown. In this video, you learned about the basic syntax of the C# programming language. Understanding these core elements enables developers to build well-organized, maintainable code. In C#, understanding object-oriented programming, or OOP, is crucial for writing well-structured and maintainable code. Object-oriented programming in C# is like building a house with bricks. Each class is a unique brick, and when combined they create complex structures. Let's explore how these pieces fit together to form the foundation of robust C# applications. In this video, we will describe the essential features of C# that are commonly used in .NET development. At the core of object-oriented programming in C# are classes, which serve as blueprints for creating objects. A class defines the attributes and behaviors that the objects created from it will have. These attributes and behaviors are referred to as members of the class, and they come in several forms. Fields and properties are key class members in C#. Fields store data directly and are often private to ensure encapsulation. Fields are best suited for internal data storage, while properties allow safe external access. Properties represent a class's data or attributes, often wrapping fields for controlled access. For instance, a car class might have a color, model, and year of manufacture properties. Properties manage how values are accessed and changed. This allows for extra logic like validation when getting or setting field values. Properties can also compute values without directly using a field. Using properties helps protect data and makes it easier for other parts of the program to work with the object's information. Methods are another essential class member type. Methods define the actions or behaviors that objects and classes can perform. Methods allow you to group a series of instructions that can be called upon when needed, making your code more modular and easy to maintain. Methods in C# can be categorized as either static or instance methods. Static methods belong to the class itself and can be called without creating an object of the class. They're useful for utility functions that don't require access to instance-specific data. Instance methods, on the other hand, are associated with specific instances of a class and can access and manipulate the object's data. For example, a car class might have a static method like getAvailableColors and instance methods like startEngine or accelerate. A static method, getAvailableColors, is a utility function that doesn't depend on any specific car state, making it an ideal candidate for a static method, while startEngine and accelerate are actions performed by individual car instances. If you want to reuse or extend methods across different classes, you can use inheritance to share functionality and polymorphism to customize or override behavior. Inheritance allows a class to inherit characteristics from another class, meaning that a derived class can use the properties and methods of a base class, extending or modifying them as needed. This helps reduce redundancy by allowing common functionality to be shared across multiple classes and promotes a hierarchical relationship between classes. For instance, imagine a base class called Vehicle with common properties like speed and methods like startEngine. A derived class such as Car would inherit these properties and methods, but also introduce new features specific to cars, like wheel count property and open window method. This hierarchical relationship ensures that shared functionality is written once in the base class and can be reused in any derived classes, making your code more organized and easier to maintain. Polymorphism is another essential concept in C#, closely related to inheritance. Polymorphism allows methods to take on many forms, meaning that a method can behave differently depending on the object that invokes it. Polymorphism enables objects of different types to be treated as objects of a common base type, typically through the use of base classes or interfaces. This allows for more dynamic and flexible code, where the exact method that gets called is determined at runtime, depending on the actual object type. Building on these concepts, C# introduces abstract methods and virtual methods as tools to achieve polymorphism. Abstract methods are defined in an abstract class, which serves as a template for other classes. An abstract method does not have a body and must be overridden in any derived class, ensuring that each subclass provides its specific implementation. Virtual methods, alternatively, are methods in a base class that a derived class can override, but they also have a default implementation in the base class. While a derived class can choose to override a virtual method, it is not required to do so. This flexibility allows for dynamic method behavior depending on the object type that is invoking the method. When defining members in a class, it's also important to understand member access modifiers. These keywords determine the visibility and accessibility of class members. The most common access modifiers are public, private, and protected, but there are other modifiers that are used in specialized scenarios. Public members are accessible from any other code in the application. Private members are only accessible within the class in which they are defined. Protected members can be accessed within the class and by derived classes. Picking the right access modifier is key. It helps control how parts of your program work together and keep important information hidden when needed. Let's re-examine the example where we have a car class that is derived from a vehicle base class. Let's say our vehicle class has three members: a private speed property, a public set speed method that can modify this private speed, and a protected startEngine method. Don't read too much into why each member has their specific access modifier. It's a matter of how we implement this functionality in our code, rather than a hard truth about vehicles. Some of these members can be accessed in the vehicle class, some can be accessed in our car class, and some can be accessed in code outside of our class hierarchy. The vehicle set speed method can be called from within a vehicle class, a car class, or any of the code in our program. Because our startEngine method is protected, it can be called from within our vehicle class or car class, but not anywhere else in our code. Finally, our private speed property can only be called from within the vehicle class definition. If we try to set it or get it from within our car class or the rest of our code, it won't work. In summary, mastering object-oriented programming in C# involves understanding how to define and use classes, members, and interfaces effectively. By grasping these concepts along with member access modifiers, you can create robust and scalable applications that are well organized and maintainable.
Mastering the basics of C# opens the door to building efficient, scalable programs. Every line of code has a purpose, and understanding the syntax is key to writing clean, effective applications. In this video, we will write basic C# programs to practice syntax and understand its features. And so rather than writing code here, I have some pre-made code, and I think it'll actually be best to walk through some of this. The goal from this video is just to show you what the different syntax looks like in the language. And so I've put together a bunch of examples that show off some of the different features of C#. Let's begin by reviewing the top of the file. The first thing we notice is the C# basics namespace. So this is the namespace that all of this code lives under. This is what provides encapsulation, so all of our code will live under that namespace. It prevents conflicts with other code. Then immediately after, there's an interface called iDiscountable. So this interface has a single member. It is a decimal, so this is sort of like a float or an int. A decimal is just a more precise data type for working with things like money, which this is working with. And so we use a decimal type here. And so we have this method apply discount, and it takes in a percentage as a parameter. Notice also that the interface starts with the capital letter I. This is a common naming convention, not at all required, but it's sort of like I am discountable, I discountable. It's sort of a way that people think about these. It also quickly lets you know that it's an interface and not a class. Continuing down, we reach the core of the product class, which is sort of the main class in this file. It provides a private field here. This is underscore price. Now, underscores are typically used. Again, this is just sort of a standard naming convention for private fields in C#. It's not at all necessary. This is just something that people do. Then here we've got a public property name. Then we also have a public property here with an additional setter so that if we try to set the value less than 0, it will go ahead and not do that. So only if the price is greater than equal to 0 will the price actually be set to the value. So if you tried to call this price and set it equal to -12, that's not going to work. So this shows the difference between using a private price here with a public setter and getter. You'll also notice here, there's only one word, but Pascal case is typically used for these types of properties, whereas it's common to see camel case used for private fields, and again with the underscore. Next up, we have the constructor here. So the constructor takes in two parameters, a string name and a decimal price, and then goes ahead and sets those properties to match those arguments that are passed in. Here in the class, we will also find a virtual method called display products, which simply logs the product name and price. Virtual methods are defined in a parent class and can be overwritten in the child class, which we will see here later. Following this is the static method, calculate discount. And again, we know that's static because it says static here. And we knew this one was virtual because it says virtual here. This will return a decimal and takes in two arguments, a price and a discount percentage. Now, a static method exists on the class itself, not on the instant member. So you could call product.calculateDiscount, but you can create an instance and then call calculateDiscount on that product. So this would be a function that sort of we want to have available that doesn't necessarily need to depend on any individual instance's price. And again, notice that the price and discount percentage come in through the arguments. These aren't actually looking at the price that you saw up there, that underscore price. This is not the same. These are arguments that will be passed into this method, not that are taken from members within this class. Moving down here, we'll see we have a subclass. So this is a derived class of product, and it also implements iDiscountable. So it will have everything that product does, and it will also need to implement that iDiscountable interface, which we saw up above, that had an applied discount method. And so you can see here it has this one public member. It adds int size, so it'll have everything that a product does, except it also has size. So this is the idea that maybe you have books, but books don't have sizes, whereas clothing does. So this is extending the functionality of a product with this new property. It takes in a constructor. You can see here we have string name, decimal price, int size, and so it takes in this additional size. And the way that the name and price get set is it's actually calling this base name price. So this is actually calling the constructor of the parent with those two arguments to set these values, and then overriding size with size because that's the new behavior here that can't be copied over from the constructor of the parent. Moving along, we have this method to convert the size from an int to a size name. Now, this is a common convention. It's much more efficient to store an integer than it is to store a string. And so this would be the type of method where you can store the sizes of 1, 2, 3, 4, and we'll translate those to SM for small, MD for medium, LG for large. Then we have this sort of catch-all down here for unknown size. You can see here that we also have a switch case. This looks at the variable size, and then based on what the value of that size is, if it's 1, again, it'll return the string. If it's 2, it'll return that string. If it's 3, it'll return that string, and underscore that string. So this catches all of your different cases in that switch. Next up, you'll see this override method that will display the product details. Now, this overrides base class's implementation of display product details. And you can see here again, we're calling base.display product details. So this will call the previous parent's implementation of display product details. And additionally, it will also do a write line with size and get size. So if we look back at the parent, you'll see we have this virtual class for display product details. So that base.display product details is calling this right here. So it will write this line and then additionally write that size detail. This is again showing off that you can use the base implementation while also adding additional functionality to that. You could get rid of this, comment it out, and it will be completely valid code still. It just wouldn't call that base implementation. Then if we go down further, we see this implementation of the iDiscountable interface. So again, if we scroll up, these iDiscountables had to have an applied discount that returns a decimal and takes in a decimal. You can see here that this does exactly that. It also takes advantage of this calculate discount method that was made available from the parent class. That was that static method. And now we're pricing in the price and percentage are coming from this instance. Now coming down here to our program class, now this is the main class that will actually hold our program's logic. And then you can see here the entry point is this main method. So when we hit .NET run, this is what it's running, is this main method. We're going to create a list of clothing objects and call this catalog, and that'll just be set to a new list of clothing objects. This angle bracket notation here, this is what is known as a generic type. So list takes in the type of object it will hold. That's what clothing is saying. This is a list of clothing items. And then we're going to add 3 clothing items here. Then we're going to loop over them using a standard for loop. You see we set our iterator at 0. We're going to use an integer for the iterator. We're going to iterate that by 1 each time it runs through the loop. So that will just go up by 1. That's this I++. And then we will stop that loop once that loop will continue to run as long as I is less than catalog.count. And then each loop we will go ahead and grab the item at that index of the catalog and we will display product details. I also wanted to showcase that you can do the exact same thing using a for each loop. Now this is something you may not have been shown yet, but is very useful. So a for each loop does exactly what this does. Anytime you're looping over all of the items in some kind of a list, this is what's known as an enumerable. So this can be the index 1, index 2, index 3, index 4. That means this is enumerable. So you can list over each item in the catalog using a for each loop. It's really handy because you don't accidentally screw these up sometimes. These are pretty error prone. Sometimes you accidentally put less than or equal to. Sometimes you accidentally only put a plus instead of a plus plus. Sometimes you accidentally set this to 1. There's lots of things that can go wrong. Using a for each loop prevents you from doing that. It's much cleaner, much easier to read, much easier to understand. And finally, we apply a discount to the clothing product. So we're going to call this discounted price is going to be catalog 0. So this can be the first item in the catalog. And we'll apply a discount of 10. Then we're going to go ahead and console write line that discount price. And then we will go ahead and console.write line the calculated discount using that static method on the product class that we showed earlier. So now let's go ahead and run this code. So I'm going to go ahead and open up a terminal. So I will hit Control tilde, which will open up a new terminal. Tilde is the key just below the escape in the top left of your keyboard. Really handy hotkey. You can also use the somewhere up here is terminal. You can open a terminal from there, or again, you can right click, open an integrated terminal from over here. So let's go ahead and run this. So I'm going to say .NET run. And again, you could run it from up here. You could run it from over here. You got lots of different ways to run. My preferred way is using the terminal. So we hit .NET run and we should see our output. So again, we are supposed to loop over this twice, display product details, come down here, do some discount stuff. And so here's our items, 1, 2, 3, and again, the exact same 1, 2, 3. And then our price after discount you see right here. And then the price here, again, showing the calculate discount function right there. Now that you know how product and clothing work together, you can try extending this further. For example, you could create another class like electronics with different properties, like a warranty period maybe. This would help you get more comfortable with inheritance and class design. You can also experiment by adding static methods or building a class to manage a catalog of items sorted by name or price. So instead of using this list here, you could add something in more complicated. So this overview covers most of the essential concepts you'll encounter when working with C# and .NET code.
Efficiency is key in modern software development. How you manage external libraries and dependencies can save you time or create unnecessary complexity. Understanding and utilizing tools like NuGet can help you manage your code and create efficiencies that will streamline your projects and avoid common pitfalls. In this video, we will explain how NuGet is used for managing libraries and packages in .NET. Let's start by first exploring what we mean by packages and how they contribute to development. A package is a bundle of software components, including libraries, configuration files, and metadata that simplifies code sharing and reuse by providing a standard way to distribute, install, and manage dependencies in a project. For instance, you might use a package to manage logging and error tracking in your application. This package includes the necessary libraries and configuration files, saving you time to build those components yourself. Let's further explore the benefits of using packages. Not having to build these packages can save a developer time, which can be used to work on other features. Many packages follow industry best practices and are optimized for performance and security. Therefore, installing packages helps developers integrate high-quality, reliable code into their projects. Another benefit of using packages is that they're typically maintained by a community or organization that provides updates and patches. Developers can easily update to the latest version, ensuring their project benefits from improvements and bug fixes. Now that we've explored why developers rely on packages to streamline development and enhance productivity, the next step is to understand how to incorporate these packages into your project. Let's now examine how NuGet helps manage libraries and packages in .NET. NuGet is the package manager built for the .NET ecosystem. It simplifies the process of adding external libraries to projects by providing a large repository of pre-built packages. The .NET community shares these packages, which developers can use to enhance their applications. For example, you can quickly find and install a library for data serialization, allowing you to avoid building that feature yourself. Managing packages involves installing, updating, removing, and configuring them within your projects. It also ensures that external libraries or tools are properly integrated into your codebase and handles dependencies between different packages. To install NuGet packages in Visual Studio Code, follow these steps. First, open VS Code and load your project. Then open the command palette and search for the Add NuGet Package command. In the search bar, type the name of the package you want to add, in this case, newtonsoft.json. Once you've found it, select your project. Finally, select the package version you want. Typically, this will be the latest version. In this case, 13.0.3. If you prefer using the command line, let's move on to how you can install packages with the .NET CLI. First, open your terminal or command prompt. Navigate to your project folder using the cd command followed by the full path to your folder. Then type in the command .NET add package followed by the name of the package you want to install. Again, in this case, newtonsoft.json. After the installation, the package will be a part of your project as it will be listed in the dependencies in your solution manager. Whether you're using VS Code or the .NET CLI, there are times when you need to update or remove packages. Let's start with updating a package. Once again, open the command palette in VS Code and select the Update NuGet Package command. Select the package you want to update. In this case, I have an outdated version of newtonsoft.json, so I will select that. Next, it prompts for the version you want to update to. In this case, let's update newtonsoft.json from 12.0.1 to 13.0.3. If you're using the CLI, you can update a package by running .NET add package, followed by the package name, followed by -- version, and then a space in the version number of the package you want to upgrade or downgrade to. To remove a package, open the command palette in VS Code and select the NuGet Package Manager Remove Package command. Select the package you want to remove. In this case, I want to remove newtonsoft.json. VS Code displays a confirmation message to indicate that the package has been removed. If you're using the CLI, you can remove a package by running .NET remove package and then the package name. Now let's explore how package management works using NuGet, focusing on how NuGet handles dependencies and versioning. A dependency is an external object or service that a class or function relies on to perform its tasks. When you install a package using NuGet, that package becomes a dependency of your code, and it may rely on other packages. NuGet automatically resolves all these dependencies by downloading and installing the correct versions behind the scenes. All you have to worry about is the packages that your code directly relies on. As code evolves, it often needs to be rewritten, which can cause problems for other code that depends on it. To manage this, developers came up with the idea of versioning. Versioning assigns a specific identifier to a particular snapshot of a program's evolution. You've probably noticed versions like v1, v2, and v3 in other contexts. The higher number typically means a newer version. However, a limitation of the simple versioning schema is that it doesn't indicate the type of change, whether it's a minor update or a major overhaul that could break compatibility. We call versions that break compatibility major versions. To indicate a non-breaking change, we add a second number to represent minor updates that add features without breaking existing functionality. We call this the minor version. Finally, we add a third number for patches or bug fixes that don't change how the code works, but improve its stability. This is called a patch or fix version. This versioning scheme is called semantic versioning, or semver, and it's why all the versions we see in NuGet follow the number.number.number format. We have three numbers separated by periods. The first is the major version, the second is the minor version, and the third is the patch version. This helps ensure we use updated code without breaking our projects. With this knowledge of versioning, you can control how NuGet handles package versions in your projects. For example, if you want to ensure your code stays compatible without unexpected changes, you can lock in a specific version of a package, like 10.4.31. This guarantees that only the exact version will be used, preventing any updates from affecting your project. NuGet will never try to use 10.4.32 or any other version, no matter how minor the change is, unless you explicitly tell it to do so. In contrast, if you're comfortable with minor updates or bug fixes but want to avoid breaking changes, you can specify a version range. For instance, setting the range 1.0, 2.0 allows updates to update version from 1.0.0 up to but not including 2.0.0. NuGet can use the 1.0.0 or 1.9.31, but not 0.9.1 or 2.1.14. This lets you receive new features and patches without risking major breaking changes. If multiple libraries depend on different versions of the same package, NuGet will attempt to resolve conflicts by selecting the most compatible version. This ensures that your project remains stable and functions as intended. In this video, you learned how NuGet simplifies package management in .NET, making it easier to work with external libraries and dependencies. By understanding these processes, you can now efficiently manage libraries and packages in your .NET projects, allowing you to focus on building unique features without worrying about dependency conflicts or versioning issues. Using the right libraries can greatly improve your development process when working with .NET. These libraries provide ready-made solutions for common tasks, saving time and making your code more efficient. In this video, we will describe the functionality of popular .NET libraries. Let's begin by discussing Newtonsoft.json, one of the most commonly used libraries in .NET. Newtonsoft.json is a .NET library used for working with JSON data in web applications and APIs. Using Newtonsoft.json makes it easy to convert between JSON and .NET objects, handle complex data structures, and customize JSON formatting. Now that we understand what Newtonsoft.json is, let's explore how it's used in .NET development. First, Newtonsoft.json handles JSON parsing, which converts JSON data into C# objects, a process essential for working with data received from web APIs. For instance, in an e-commerce API, when a customer views their order history, you need to parse the JSON data such as order dates, items purchased, and total cost to C# objects to display the details in your app. Second, Newtonsoft.json serializes C# objects into JSON strings, a process essential for sending data through web APIs, which often use JSON for communicating between systems. For example, in an e-commerce API, when a customer completes a purchase, you must convert the order details like the customer's name, shipping address, and purchased items into a JSON string and send it to a shipping service. Finally, Newtonsoft.json deserializes JSON strings into C# objects, a process essential for receiving data from web APIs, which often send responses in JSON format. In the same e-commerce API, when a shipping service sends order tracking details, you need to convert the JSON response, such as tracking number, shipping status, and estimated delivery date, into a C# object that your app can use. Now that we've examined how the Newtonsoft.json library works in web applications, let's explore Dapper, a library that streamlines database interactions. Dapper is a lightweight, fast, micro-object relational mapper, or ORM, library for .NET that maps SQL query results to C# objects, simplifying database interactions. As an ORM, Dapper automates the process of converting data between a relational database and object-oriented code. This allows developers to interact with databases more easily by treating records as objects. Dapper is also much faster than full-featured ORMs, making it ideal for performance-critical applications where you need quick access to database data. Here's how you can apply Dapper in your projects. First, Dapper simplifies querying data by allowing you to map the results directly to C# objects, making database access straightforward and fast. For example, in our e-commerce API, when retrieving customer orders, you must fetch or retrieve order details such as the order IDs, item lists, and total cost from a database and convert them into C# objects to display them in your app. Next, Dapper is ideal for high-performance applications, especially when quick database access is essential to avoid slowdowns. For instance, in our e-commerce platform during heavy traffic periods, like sales events, you must efficiently query product databases to ensure that users can quickly access product details without delays. Finally, Dapper is great for simple projects where only basic data access is needed, avoiding the complexity of larger ORMs. In a simple web app where you only need to access a few records, Dapper provides just enough functionality without adding unnecessary overhead, like needing additional processing power or memory. Now that we've discussed Dapper and its role in database management, let's move on to Serilog, which is essential for logging and monitoring application performance. Serilog is a flexible and structured logging library for recording and tracking application logs. It gives you clear access to what's happening inside your app, especially during errors or unexpected behavior. Logging is important for tracking errors and user activity in real time, especially in production systems where issues might be fixed quickly. Let's examine how you can use Serilog to keep your application running smoothly. First, Serilog helps you capture detailed error logs, making it easier to troubleshoot and resolve issues when something goes wrong. For example, in an e-commerce API, if an order processing error occurs, Serilog logs the error message with details like the order ID and user actions, helping you identify and fix the issue quickly. Next, Serilog allows you to track user interactions with your app, providing valuable insights into improving the user experience. For instance, in an e-commerce platform, you can monitor user behavior like how often users visit certain product pages or abandon carts, helping you optimize your platform based on actual user activity. Finally, Serialog can route logs to multiple destinations like cloud storage or monitoring systems, making it easier to manage logs across different environments. For example, in a distributed e-commerce system, you can configure Serialog to send logs from various servers to a central location. This allows your team to analyze all logs in one place and maintain full oversight of system performance. Now that we have been introduced to some commonly used .NET libraries, let's explore where you can learn more about these tools. Here are 3 simple steps to find out what you need. Each library, like Newtonsoft.json and Serialog, has detailed online documentation explaining its use. Next, documentation often includes real-world examples to show how to implement the library in your code. Lastly, community forums like Stack Overflow or GitHub discussions have support from other developers who may have met similar issues to yours. In this video, we explored Newtonsoft.json, Dapper, and Serialog, 3 key libraries for .NET development. Understanding how to use these libraries will help you work more efficiently and build more reliable applications. In this lab, we're creating a very simple console application that we'll use to serialize and deserialize JSON data. In step 1, we set up a new console application using the template, using the command .NET new console. And that just creates a very basic console application using the template that's in .NET Core. In step 2, we run the console application. We're not going to do that here, but if you ran the console application using the templated information, you'll get a response that says hello world in the console. Down here in the terminal, you'd see hello world. And you can test that once you've installed and created the application. We've already got other code in our file, so we're not going to do that, but this is what would happen in step 2 if you ran the application using the template. In step 3, we're installing the Newtonsoft JSON library. In Visual Studio Code, there's various libraries that you can use to get work done, so you'd have to write the code yourself. And you can use the .NET add package command to install those libraries. The .NET add package uses internally maintained catalog that goes out to the internet, finds the package name that you specified, and will bring that back and install it for you. So this saves us from having to go out to the internet, find the package ourselves, run an installer, and then restarting Visual Studio Code. The .NET add package command just does that for us. So once we have the package installed, we can check our CS_proj file to make sure that it's referenced. And when we go there, we see under item group, package reference includes Newtonsoft.json. Now this just means that we have the library available to us. We can't quite use it yet, but we know that it's available. The application sees it as available, so now we've got an option to use that. In step 4, we're going to define some basic JSON data and then serialize and deserialize that JSON data. So what I've done here first is I've created a using Newtonsoft.json reference, which means that once we use that using statement, we can now use the features of that library. Again, the previous step, we just installed the library. This tells the application to actually use it and reference the various methods and properties of that library. The next step is to create a public class product. This is for step 4. This is step 3. In step 3, we create a product class, and we have 3 variables in that class: name, price, and tags. You can see that tags is a list of strings. Price is a decimal value, and name is a string value. And so this is just going to hold our JSON data that we can use to serialize and deserialize from. This creates our C# object that we can use when we're working with JSON data. The next item we create is a general program class. And inside that program class, we create a main method. The main method is what's run when the application's run. So when we start the application, it'll look for the main method and run any code that's inside that main method. So we create both of those. And then the first thing that we're going to do in terms of serializing and deserializing, this is step 4, substep 4. We're going to create a JSON string and deserialize that using the Newtonsoft library. So you see we have a string called JSON, and inside that string we're going to create well-defined JSON that has each of the properties that we defined in the class. So we have name, price, and tags. Each of those is a part of the JSON data that we're going to deserialize into the product object. We do that in the next step. We create a product variable. The variable name is called product, and it has the type of product. And then we use the JSON convert.deserialize object, which is a part of the Newtonsoft.json library, with the type product, and we pass in our JSON data. And what this will do is deconstruct that JSON and place it into the product object for us. So we use one line of code that will take the JSON information and put it into our product object. And then you can see in the next line, console.writeLine, we can reference each of those, the data in those items using the class and dot notation. So we have product.name, product.price, and then product.tags. We've taken that JSON data and we've put it into our product class, and now we can reference each of the pieces using dot notation. In step 5, we're going to go the other way around. In step 5, we're going to serialize an object to JSON. So I'm going to comment out this block of code and uncomment the next block of code, which is the one that we use in step 5. Here, we're going to declare a product variable called new product, and then we're going to define the properties of that object. So we've got now the new product object. We define the name as smartphone. We define the price as $699.99, and then we add tags like electronics and mobile. So now we've got our object, and just like we did in the previous step, we could reference the aspects of that object using dot notation. So we can say new product.name, and it would return smartphone. But if we want to transport that data into a universal format like JSON, we're going to have to convert it to JSON first. So that's what we do in the next line. We create a new JSON string, because JSON is just plain text. It's just a string value. And then we use JSON convert.serialize object, pass in our object, our new product object, and we give it some formatting information that will return an indented JSON. And now we have a JSON object called new JSON, and we can write that out to the console in the next line. Console.writeLine serialized JSON is our JSON information. So that's how we use Newtonsoft.json in a simple console app to deserialize and serialize to and from JSON. As you've learned, mastering the .NET platform, C# syntax, and NuGet package management is essential for building efficient, modern applications. These skills will streamline your workflow and help you make smart development choices. We began by introducing the .NET platform, covering its core features and functionalities, which make it a crucial tool for developing modern applications. Next, we examine the differences between the .NET framework and modern .NET platform, emphasizing when each is most suitable for development projects. Then we explored the fundamentals of C# syntax and its key features, understanding how it integrates smoothly into the .NET ecosystem. Finally, we introduced NuGet and package management, focusing on how to find and utilize common libraries to simplify and enhance your development workflow. Mastering the .NET platform, C# syntax, and NuGet package management is key to building efficient, modern applications. These tools and techniques will greatly improve your development process and enable you to make informed decisions for scalable, maintainable projects. Welcome to Building Web APIs with ASP.NET Core. In this module, you'll learn how to create scalable web APIs, manage routing, handle dependency injection, and implement effective error handling. By the end, you'll be equipped to build reliable APIs that support modern applications. We will begin by introducing ASP.NET Core, exploring its features and benefits for web API development, and understanding why it's a popular choice for modern backend solutions. Next, we will explore the process of creating a simple web API, providing practical steps to help you get hands-on experience with ASP.NET Core development. Then we will examine routing and attribute routing, learning how to structure and manage API endpoints effectively for seamless navigation. Next, we'll explore dependency injection, an essential practice in ASP.NET Core that simplifies application architecture and enhances maintainability. Finally, we will identify best practices for error handling and logging, ensuring your APIs are reliable and easy to troubleshoot. By the end of this module, you'll have the skills and knowledge to create scalable web APIs, manage routing, and handle dependency injection with confidence. Let's get started with building web APIs with ASP.NET Core. APIs are essential for modern apps, allowing them to communicate with other services. For example, when you check the weather on your phone, an API fetches that data. APIs are a key part of backend development, helping to manage what happens in an app's background. ASP.NET Core is a tool that developers use to build APIs quickly and efficiently. In this video, we'll describe the features of ASP.NET Core for web API development. Let's start with a description of what ASP.NET is. ASP.NET Core is a cross-platform, high-performance framework for building web APIs. It's open source, works on multiple platforms such as Windows and Linux, and is designed for modern scalable applications. ASP.NET Core is popular because it manages everything from simple apps to large systems. It gives developers the flexibility to build fast and scalable APIs. Now let's explore the features that make ASP.NET Core a great choice for API development. ASP.NET Core lets you develop and run your APIs on any platform like Windows, Linux, or macOS. For example, you can build your API on Windows and later run it on Linux if you need. ASP.NET Core is also lightweight and can therefore support high-performance needs like managing large numbers of requests. For example, if you run an online store, it can support thousands of customer orders during a big sale without slowing down. ASP.NET Core has a modular architecture, allowing you to add only the parts you need. Another feature of ASP.NET Core is dependency injection. Dependency injection keeps your app flexible. Routing and middleware are also features of ASP.NET Core. Routing in ASP.NET Core determines how HTTP requests are mapped to specific endpoints in your API. It enables the framework to direct a request like API/products/1 to the correct action method that fetches the product with an ID 1. This makes your API flexible and intuitive to use. Middleware works like checkpoints for each request in your app. Each checkpoint can process, log, or check the request before it moves forward. Security is another feature. ASP.NET Core has built-in authentication and authorization, so it's easy to control who can access your API. This helps protect critical data like user profiles and financial data. The final feature we're going to discuss is flexible deployment. ASP.NET Core is flexible. You can deploy and host your API on the cloud, on your own servers, or even in containers like Docker. Start small and scale up as needed. Now that we've covered the main features, let's examine the benefits that ASP.NET Core provides to developers and businesses. One benefit is that ASP.NET Core is cost-effective because you can run your API on any operating system that fits your budget. Another is that ASP.NET Core's high performance allows your API to support heavy traffic without slowing down. ASP.NET Core's modular design is also a benefit. It lets you start small and add features as your app grows, making scaling easy. Another benefit of ASP.NET Core is its maintainability. The feature of dependency injection lets you update parts of your app without affecting the rest, keeping things easy to maintain. ASP.NET Core also helps protect your API with built-in authentication and authorization, ensuring only the right users can access sensitive data. Imagine a small online store that uses ASP.NET Core to build its API. At first, they only need simple features like showing product listings and processing orders, so they start with just the basics. As their business grows, they add new features like customer accounts and secure payment processing, ensuring that customer data is handled safely. This is crucial for building trust and meeting industry standards without rebuilding the whole API. They also move from hosting on small local servers to a cloud platform, which allows them to support more customers during busy shopping seasons. Thanks to ASP.NET Core, they scale easily, keeping their API fast and reliable as the business expands. In this video, you learned about the features of ASP.NET Core for web API development. You now understand how ASP.NET Core can simplify the development process and grow with the needs of both small and large-scale applications. In today's fast-paced digital world, delivering a reliable and efficient web API is more important than ever. With so many options available, it can be tough to choose the right framework. Understanding the tools that provide performance, scalability, and flexibility will make all the difference in meeting your development needs. In this video, we'll explain the benefits of using ASP.NET Core for web API development. Let's explore the benefits of ASP.NET Core for API development. To start, performance is critical when your API receives a high volume of requests. ASP.NET Core is lightweight, which means it can manage large amounts of traffic without slowing down. It's also scalable, meaning your API can support more requests as your application's popularity increases. For example, imagine your online store is running a major sale and you suddenly get thousands of customer orders simultaneously. With ASP.NET Core, your API can efficiently process each order without delays, ensuring a smooth customer experience even during peak times. Next, ASP.NET Core includes built-in dependency injection, which helps keep your code organized and easier to update. Dependency injection allows you to manage and replace parts of your application, like adding new features, without changing unrelated sections. For example, suppose you're developing a web API for an e-commerce platform and you want to update the payment processing service. You can replace the existing payment service with a new one without modifying the rest of the API. Dependency injection ensures that only the specific service changes, keeping the rest of your code intact. Another benefit of ASP.NET Core is that it offers a unified programming model. This means developers can use a single set of tools, libraries, and techniques to build web applications and web APIs. This approach streamlines development, making it easier to manage and maintain code, since the same structure and principles are applied across different types of web-based services. For example, if you're developing both a customer-facing website and a backend API for an e-commerce store, you can use ASP.NET Core to build both. This way you're using the same tools and structure, reducing complexity and speeding up development. Another benefit of ASP.NET Core is that it supports cross-platform development. ASP.NET Core runs on Windows, Linux, and Mac OS, so your development team can use different operating systems, but still work on the same API. Whether someone is on a PC or a Mac, everyone can collaborate seamlessly without worrying about compatibility issues. For example, suppose part of your team uses Windows PCs and others prefer Macs. In that case, they can all contribute to developing and maintaining the API without switching tools or platforms. This makes collaboration easy and more efficient. ASP.NET Core is also cost-effective. ASP.NET Core is free and runs on any platform, giving you flexibility in hosting options. Using less expensive hosting environments like Linux can significantly reduce costs while delivering robust performance. For example, a startup wanting to minimize expenses could choose to host its API on a budget-friendly Linux server. By leveraging ASP.NET Core's cross-platform capabilities, the startup can save money on hosting without sacrificing the quality or performance of their API. The last benefit of ASP.NET Core that we're going to explore is its modularity and flexibility. ASP.NET Core is modular and flexible, meaning you can include only the needed parts, keeping your API streamlined and efficient. For example, if you're starting with a basic API for a small app, you can include only the essential components like routing and data handling. As your app grows, you can easily add new features like authentication or caching without overcomplicating the existing code, allowing you to scale smoothly over time. In this video, you learned some of the benefits of using ASP.NET Core for web API development. With ASP.NET Core, you're not just building an API, you're creating a scalable, flexible solution that can support the demands of the future. APIs play a crucial role in keeping apps functional and connected. Mastering the tools to build efficient APIs is the key to developing responsive, scalable software. In this video, we'll explain the process of creating a simple web API with ASP.NET Core. When setting up a web API project, you need to understand two key files, program.cs and startup.cs. Program.cs is a file that serves as the entry point where the app's configuration, services, and host are set up to manage its lifecycle. Essentially, it creates the foundation for the app, including setting up the necessary services, middleware, and the host. The host manages the application's lifecycle, including server startup and shutdown, dependency injection, and configuration loading. The next file is startup.cs. This file is the app's manager, configuring middleware and services. It defines how requests are handled, sets up routing to direct incoming requests, and ensures the application's smooth operation by managing middleware components, security, and more. Every middleware component in the pipeline that processes step-by-step requests is configured here. This makes startup.cs the central hub for request handling and application startup. Now that we understand the programs.cs and startup.cs files, let's explore how to set up and develop a web API project, starting with controllers. In ASP.NET Core, controllers are stored in the controllers folder, and it's where we'll define the logic that handles HTTP requests. Consider controllers as the bridge between incoming requests and the data or actions they request. To start building our API, we need to add a controller, which is important because it defines how your API will respond to incoming requests. An API controller is a class that handles HTTP requests and sends back responses. It's the main entry point for interacting with your application's data or functionality. Each controller is responsible for handling specific requests and returning the appropriate response. For instance, in an e-commerce API, a controller might handle product-related requests. This includes listing all the products, fetching details of a specific product, and performing actions such as adding, update, or removing products from the inventory. With the controller set up, the next step is to define the API endpoints. This determines how the API handles incoming requests. This is done by creating methods inside the controller that specify what action to take when a specific route is accessed. Each method you define will be linked to a unique API endpoint, allowing your API to respond appropriately when that URL is called. An API endpoint is a specific URL that acts as an address for clients to interact with your server. The API endpoint defines the location where requests are sent. It allows clients to retrieve data, submit information, or perform actions on the server through your API. So how does ASP.NET Core know which method to call when a request comes in? This is where configuring routing comes in. Routing in ASP.NET Core maps the HTTP request to the appropriate endpoint in your API. By default, ASP.NET Core uses convention-based routing. This means it automatically maps requests to controller actions based on their names. For example, a request to the endpoint /API/products is routed to the appropriate controller where a method matching the HTTP request type, like getProducts for a GET request, is executed. This routing is configured in the startup.cs file, ensuring that the correct controller and action are triggered based on the request. While convention-based routing works well, sometimes you need more control over routing requests. ASP.NET Core allows you to customize routes using attribute routing directly in the controller. This lets you define exactly how the URL should look and which method it should map to. For example, suppose you wanted to create a route that retrieves a product by its ID. In that case, you can define it in your controller method using the attribute typing an open square bracket, and then HTTP GET. Then an open parenthesis and in quotes products / open curly bracket and the letters ID, a closed curly bracket, a closed quote, closed parentheses, and finally a closed square bracket. This maps the URL / the letters API / then products, another / and then an open curly bracket, the letters ID, and closed curly bracket directly to the method in the controller, allowing it to handle GET requests for a specific product. This approach results in a clean descriptive URL where the ID is replaced with the actual product ID passed in the request. Before creating an endpoint, it's important to understand HTTP methods. APIs use different HTTP methods to perform various actions. The most common HTTP methods are GET to retrieve data, POST to create new data, PUT to update data, and DELETE to remove data. With routing and endpoints set up, it's time to test the API. To do this, start the application using your development environment or terminal. Once the project runs, a browser will open where you can test simple GET requests by navigating to the endpoints you've created. For more complex requests, such as POST or PUT, you can use external tools to send different requests and view detailed responses. These tools are essential for thoroughly testing and debugging your API before going live to ensure it works as expected. In this video, you learned how to create a simple web API with ASP.NET Core. We covered the key files like program.cs and startup.cs and how they form the base of your API. You also learned how to add a controller, set up endpoints, and use routing to manage requests. With this, you're ready to build and test your own API using ASP.NET Core's features.
All right, this is the most exciting part of this course. We've been laying the groundwork for this moment when you will finally write your first .NET web application code using ASP.NET Core. So in this video, we will implement basic API endpoints in ASP.NET Core. So we're going to start by creating a basic web application. One of the easiest ways to do this is we can start with a brand new window of Visual Studio Code with nothing open. And if you do that, you will see create .NET project. We're going to create a project. You could also do this through the command palette like we've shown before. You can also do this through the terminal. So we're going to go to ASP.NET Core empty. You'll notice here that there's a bunch of different types of web projects. You don't want to choose one of these because they're just much more complicated versions of this. This is a really simple, sort of bare bones web API or web application. And these are actually all built on top of that. So you're going to get a bunch of different things like APIs, gRPC, MVC, Razor Pages, even Blazor. If you choose one of these, you want this empty web. And so let's go ahead and give this a folder to live in. So I'm going to create a new folder that I will call Basic API Endpoints. I'm going to go ahead and make that, select that folder, select folder. It wants a name. I like to use the same name as I did for the folder, but you don't have to. And then I'll go ahead and hit enter, and then you don't need to change any of the template options. So we'll just create the project. Give it a second here. You're going to see that flash, and boom, our project has been populated. Here you will see our program.cs. This is a web application. Now, the first thing you're probably going to notice here is that there isn't much code. It's just 4 lines. And that's thanks to working with .NET. There are tens of thousands of lines of code that will be run on our behalf when we start our code. But you only need to worry about these 4. These are the specific ones that are specific to our application. You're going to have a bunch of code that runs all the way down to the very hardware on your computer. You don't need to worry about that. All you need to worry about is this. You don't need to worry about setting up the server, any of this fancy stuff. You're just setting up your API and your API routes. So the core of our application starts here. We're going to have this package called web application. This class we'll call the create builder method. And that will create a builder. Well, what does the builder build? Well, the builder builds web applications. So we take our builder and we call build, and that will return app. Now this seems a little verbose. Why do you need all of this? Well, that's because the builder, we'll see later on, will allow us to change some things about the application before we build it. It allows us to change some settings and configuration. We're not doing any of that here. We're just going with something really simple and straightforward. So we've now built our app. Now what the heck is an app? What is a web app actually? A web app is simply a special piece of software that lives on a server, listens for requests from other computers, and then processes them, usually resulting in sending a response. What you are doing when you code a web app is defining what should happen when requests are sent to your server. That's it. It really is that simple. So messages can be sent to your web application using an address known as a Universal Resource Locator, or URL. Now, like your street address identifies the location of your home, a URL identifies where to send messages over a network to your application. So this is how the client knows how to find your computer on this giant web of computers that is the internet. And now in that URL can be an additional piece of information called a path. Now you can think of a path as, imagine that you have a web domain that is like an apartment building. And each of those apartments is a path. They're a different sort of mini address inside the larger address that is the apartment building. The apartment building is the domain, and each apartment is a path. And now there is a sort of front office in that apartment building, and that is what is known as the root path. And the root path is just a forward slash. So that's what we see here. This is just a forward slash. This is defining a path that a client could make a request to, a specific address at our domain. So that is the first argument of this app.mapGet method. So this is us defining the behavior that will happen when someone sends a request. So we'll get a little bit more into this, but for now, just know that we make this mapGet method. We call that, we pass in a path, and we give a function. This function just returns a string hello world. Doesn't take in any arguments. One of the simplest functions you can imagine. So what this code says is when a client makes a request to the root domain of our application, send them back the string hello world. And then finally, you come down here to the bottom and you run the run method on our application, and that will start our application running. That will actually start the server that will start listening for client requests, and then as it receives them, send something back. So let's go ahead and start our application. I can come over here and do the run and debug, choose C#, do the C# basic endpoints. That was just the default configuration there. We're going to go ahead, and this will take a second to build and load. And then you'll see some information get kicked out here in the debug console, and then you'll see it flash over to our web browser. Now let's get those both open at once. Now our server has started. You can see the text here, and I just swapped back over, made it open up a web browser, but I went ahead and came back to the terminal. So you can see we're now listening on http://localhost 5137. This is where our server's address is now located, and what happened was it opened up a web browser, and web browsers are just used to make requests to servers. You can pop that open, and you can see here it made a request to our server, and what did it get back? Hello world. Localhost 5137. Again, this is the address of our page. Now if we swap back over to our page and we change this text to just say the root path and go ahead and save that. And because we made a change here, we're not going to see anything different unless we hit this restart button, because our server is still serving that old information. And just to show you that that's the case, I will refresh this. Nothing has changed, even though we saved our file. And the thing we did not do is we have to hit restart. So you'll see it go through the same process again, yada, 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 bunch of output here. Then eventually we'll open this back up, and boom, now it says root path. Here's the old one we'd opened up. If I refresh it, root path. Awesome. So we've talked a little bit about clients and servers. And in this case, our client and server are on the same computer. One computer can work as both. And when that computer is your local machine that you're using as a server, it is known as what is called a development server. This isn't where you're actually going to serve it from. When it goes live, this is just sort of you having somewhere to test things as you develop the code. And again, the address here is localhost, and you'll also notice this :5137. Now, this is what's known as a port. So this is the domain of our URL, and this is the port. Now, the port is sort of just allowing the server to have multiple servers running on it, and it can assign each of those a port. That's all the port is doing. And when you create a new project with .NET, .NET will assign you a port. If you want to find out what port it is, one way is to just look at the browser it opened up. But if we go back to our code, you'll be able to see here, if we go to the debug output, the debug console, you can see the port here as well. If you accidentally closed your browser and you're trying to get access again, you can control click this. You can also copy and paste it and just put it into the address bar of your browser. You can also find your port by coming over to the File Explorer, going to Properties, Launch Settings, then looking for the port. Now you're going to see this port here. That is the wrong port. This one under IIS settings, that's not what you're looking for. You're looking for the one under Profiles. This is the port you need to worry about. This is the one where you can access your application. So now we've made a request. So we now have this one address, the root address, that we can make requests to. But what happens if we try a different path? So let's try /downloads. So the information following our domain and port, this is what's known as a path. So we've got this /downloads is our /downloads path. If I try to access that, I'm going to get what is known as a 404 error. And a 404 is the server telling the client that I didn't know what to send you. I don't have anything at that address. It's like trying to send a letter to a house that doesn't exist. And the postman sending you a letter back that says, didn't know where to go from this. Here's your letter back. And another thing you might notice here is we just see localhost 5137. But if we look back over here, you'll see this HTTP : //. Now this is what's known as a protocol. And a protocol is basically just a way of explaining how servers communicate. It's a definition of the way that you're expecting to communicate between client and server. In this case, it's HTTP. In this case, it's just HTTP, which is Hypertext Transfer Protocol. Now, transfer protocol, again, just is a definition for how to transfer something. Now, hypertext is a little bit weird. Basically, hypertext is just text that has links in it. This is how web pages work. They are made of what is known as hypertext. You don't need to worry too much about this. Just know that most of the communications that happen over the internet happen by HTTP. Another thing we could do is we can go back over here. And so we saw that we didn't get that when we went to /downloads. So let's come back and type this and let's change the path here with this copy. So now we have downloads. And let's change this text to downloads. Again, this function could do anything. In this case, it's just going to return some text to demonstrate this. But let's save that again and restart our server, or we're not going to see anything new and exciting. And then it's going to go ahead and open this file. And nothing has changed. Well, why did nothing change? Because we're still going to the root path. This is the same as typing in a / there and hitting enter. Again, that's that root path. Oops. Remove the whole thing. But if I type /downloads, boom, now we get downloads back. And again, if I go back to just being the URL, we will get that. So this is just saying when someone comes to the root, send them back this. When someone goes to the downloads path, send them this. Now, one of the neat things about HTTP is it defines what are known as request methods. So there are different ways to make requests between a client and a server. And they're sort of like verbs that describe what the client is trying to do. And so you might have been wondering, what does map get mean? Well, get here is referring to the get method of the HTTP transfer protocol. A get method simply says, I want to retrieve some information, like a string of text. This is a really great use of the get method. And you might be wondering what map means. Well, in this case, map just means creating a link between this path and a function. You're mapping those two things together. That's what map means. So we have a route like slash maps to a root path, downloads maps to this function that returns downloads. It says when a client requests a path, send them back whatever this function returns. Now I mentioned that there are multiple HTTP methods. So get is one of them. We've shown a couple examples of using get, but there's also put, post, delete, and a bunch of others, but put, post, and delete are probably the most common. And so you could probably, as you guessed, type app.map, and then let's try put. And there is now put, and it's going to want a couple of things here. I can move that so we can actually see. So again, it's going to want a path, and we'll call this, again, just slash. Let's do the root route, and let's take a function, and let's return this is a put. Put in a semicolon there. So now notice that these are both the same path. We have now mapped what will happen when someone makes a GET request to this address and what happens when someone makes a PUT request to this address. And so our browser is always sending a GET request when we type something in the address bar. So to make a request using a different method like PUT, we're going to need another tool. And one of my favorite tools for doing this is an extension called REST client. So you can go ahead and install this. You go to your extensions, you're going to do REST client, and you're going to install. Boom, you have it. Now all REST client is going to do is it's going to allow us to make special files that end in the HTTP extension. So I'm going to type requests.http. Now there's nothing magic about these, they're just text files, but because they have this extension, Visual Studio Code is going to treat them differently. So I'm going to type in get and then http://localhost. My port in this case was what, 5133. Let's check our debug console, 5137. And now if I go ahead and save that, so this is going to make a GET request to 5137. Boom, that returned a root path, just like we were seeing in the browser. I can do the same thing if I copy and paste this, and now we're going to put 3 pound signs to separate each different request, and I'll type in hello. Now what's really neat about this is you can run either one of these by hitting this send request button. So I'm going to hit send request here, and now we're going to get back nothing because there is no hello path. Remember, we made a downloads path. So there are now currently only 2 paths to find. So let's change this to downloads. I'll hit that, boom, and it returns this text, downloads. So take a second and think, how do you think you're going to do a put method instead of a get method? If we type in 3 pound signs here, we'll put in put http://localhost, same shebang, 5137, and we want the root route. If I just put that there, then we send this request. What's it going to show us? Is it going to show us a root route? Or is it going to show us this is a put? So we'll hit this, and I'm going to get a 405, method not allowed. And that is because, again, we did not restart our server. Our server is currently running and does not know that it has a put method. I need to restart it. So one of the first things to check when you make a change to your API, make sure that you restart your server. Now let's go back to our requests. We're going to send this request one more time, and boom, this is a put. Now that actually works. So anytime you're changing the function that's happening inside, or you are adding a new route, or you're adding new middleware, or some of the things we'll get to later, you want to restart your server. Another important thing to note here is the only reason we have this send request thing here is because we installed that REST client extension that you saw earlier. So make sure to install that. Otherwise, you're not going to see this. You're not going to be able to run this. You'll have to use another tool. And yes, there are other tools out there. If you're familiar with something like Postman or curl, totally feel free to use those. If you don't know what those words mean, don't worry about them. This is a really slick tool that I absolutely love. Now, another thing to notice here is we have this 200 OK here. There's all this information that's sent back. So this is the payload that we put in our function, but this is a bunch of things that is being put together by .NET behind the scenes. So this is showing what the protocol was when it got sent, and this is 200 OK. This is what is known is a response status. So when our client gets information back, it is being told, what was the status of that? Did things go okay? Did something go bad on my end? Did something go bad on your end? Was it good? Was something created? Was something deleted? Yada, yada, yada. Was nothing returned? So a 200 means, okay, 200 is great. And again, if I send something to /hello, you'll see 404. 404 means not found. Anytime you see a 404, it means your server couldn't find whatever was requested. Now let's do a couple more things here. We said there were a few more methods, so we should also be able to have a delete and a post. Go ahead and save that. And if I try to make other of these, I'll get a 405, method not allowed. And again, that's not because we didn't restart our server. That's because we haven't defined what to do when someone sends a method like this. Again, that is the job of building a web application, of building an API, is defining what happens when someone sends us a request. So let's go back to our application. And I'm going to copy this down 2 more times. And I'm going to make this one map delete. Super easy to understand conventions here. We already did put, so let's do post. So basically, gets are for getting information, deletes are for removing information, posts are for sending information, and puts are for updating information. They don't always have to be used like that, but that is sort of the intention of these different methods. They're letting the server know, hey, I want to add something, delete something, update something, or give you some information. And let's go ahead and change these to say something different. We'll just say delete, a bunch of exclamation points. And this one will say post me. And then we'll save that. And what do we need to do? Remember, one of the most important things, we just made a change. We added new routes. That's right, we need to restart our server. So we'll go ahead and wait for that for a second. This will just take a moment to load. We can go ahead and come back here. And it just opened up our browser again. So let's go ahead and navigate back. And then we can send a request to delete and delete, a bunch of exclamation points, and post. And we see post me. So these both now work. Now I should say that again, these are supposed to work in ways that they're not right now. They're just returning information. These should all be GET requests. But this is just to sort of illustrate how the client would make different requests and handle these. Really, the put should like update a piece of information, and the delete should delete a piece of information. The post should probably take in some data that we do something with. This is just to sort of show the basics of how you'd scaffold this all together. Now, after all this, you might be wondering, well, we've been building a web application. So what is an API? Well, this is an API. An API is just a part of our web application. It's the part of our web application that defines these different paths and what to do when something happens with them. That is what an API is. The API is sort of defining what this interface is, what the different places that a client can make requests to those addresses and then have something happen. It provides an interface that other applications can use to communicate with your web application programmatically. That's all an API is. Congratulations! In this video, you learned how to implement basic API endpoints. You now have the basic building blocks to start building your own web applications. We are now going to demonstrate one of the most important and common API concepts in all of computer science, the CRUD API. The principles of CRUD power every type of content API on the planet, from blogs and social media to medical records and satellite tracking. CRUD APIs are all about manipulating data, and we sometimes call that data records. So in this video, we will implement the CRUD API pattern. CRUD is an acronym that stands for Create, Read, Update, and Delete. These are the basic operations we perform on data. Create is just what it sounds like, making a new record. A record is just data, so it is making a new piece of data. Reading simply means retrieving data, often as a single item or sometimes as a collection of items, maybe all of the items of a particular type. Maybe they're filtered items, or again, just a single item. Updating data involves making changes to it. And as you guessed, deleting is just removing data. So we can create data, we can read data, we can update it, and we can delete it. So we're going to go through those steps, and we're going to do this making a simple API to work with blog posts. So I have my blog object here. This class has two properties. It has them both required, and they are the title, and they are the body, and they are both strings. Nothing fancy here. And then I also am storing my data in a list of blogs. And I just create two blogs here. The first one is my first post. The second one is my second post. Again, nothing really creative or interesting here. The thing I really want to emphasize here, though, is this isn't how you would normally store data in an API like this. This is awesome for demonstration purposes here because what you're going to learn here abstracts really well to doing this with a database or with files or storing these somewhere else. Fundamentally, all you're doing is in a full-fledged API, rather than creating a new entry in a list, you're creating a new entry in a database. So just know that if you really wanted to create a durable API using this type of methodology, you're going to want to use a different data structure, but it's a bit complicated to implement here while we show you the basic concepts. So we have our blog posts. The first thing I'm going to do is I'm going to go ahead and start up my application. So I will hit Control tilde once again, and I will say .NET watch run. And again, that watch flag before run will make sure that it updates when we make changes, and it makes it really easy to use Control R to reset our server, which I will be doing a lot here. So here you see we have our root route returning the string that we expect it to. It says I am root. Excellent. I also want to pop over to my request file. I have the same thing over here, and I will hit that. Awesome. That is working. So we are going to go ahead and get all of our blogs. Stop for a second and think, how would you do that? So we're going to do a GET request. That makes sense. And it's going to need a path. Typically in an API like this, we might use something like /blogs to get all of our blogs. It sort of has a name that just makes sense. And then what do we want to do in this function? If we wanted to return all of our blogs, what do? Well, we do just that. We return blogs. So I can go ahead and save that. And if we go back to our HTTP file, I can copy this particular get, and I can add in /blogs. And again, make sure if you're following along to change this port to the port that your app is actually running on. You can see here I'm running on 5127. And I need to add the 3 £signs there to split that up. And we run that, and I get a 404 not found. Why is that? It's because I didn't restart my server likely, or I got the name wrong. So let's try that. That did it. Awesome. Here's my 2 blog posts. This is exactly what I expected. I just hadn't restarted my server. This happens a lot. Know that the watch will watch for simple changes like a string, but if you're adding routes, you're adding services, you're adding middleware, it's not going to catch them. You're going to have to manually restart. So that gets all of the blogs. But what if we wanted to just get a single blog? So let's type app.map get. And then, so what would we need to know to get one blog? Well, we need to know what blog they wanted. So we probably need a function that takes in a parameter. And in this case, it will be an int, and we will call it ID. And so then think a little bit. We have a list, and we want to get a blog from it. How are we going to do that? Well, we're just going to return blogs at that ID. And this totally works. I hope. Let's see. It's always fun. So we will come down here. And now one of the things we've done here is added this route parameter. And so I actually screwed that up. I need to add ID there. And once again, I will restart my server just in case. And so now it is passing an ID as a parameter. It is taking in an ID, and then it should give us the blog at that ID. Let me send that request, except that needs to be blogs1. Hey, that totally worked. Let me try blog 0, and that should be my first post. Awesome, that totally works. Now here's a problem with this. I'm gonna type in 3. There's 2 blogs in there. What do you think is gonna happen? It's gonna throw an error. So we need to add some protections around this. And this is just because of the way we're storing the data here. If you're using a database or something, you'd handle this type of situation differently. What are you going to do if the item they want isn't there? So we'll say if they try to access an index that's below 0, or the index is greater than equal to blogs.count. And if they try to do that, we will return results.notfound. Now, this is a way of easily sending a 404 error. And then we want an else here. And then we will put our else in there because that means it is a valid blog and we can indeed return it. Now, I am getting an error here. Let me pop through real quick and see what I have done. What's the warning? I'm probably missing a character. Parameter 1 is declared type int, but should be an HTTP context because I need results.ok. There we go. That clears that up. It's not expecting context. It is just expecting an ID. Again, these are really nice helper methods. You can take into context, return that, return just an object. It's much nicer to use the OK because this automatically sets the status OK. It sets the content type without you needing to worry about doing any of that serialization. So now we have a blog that returns a single ID. Let's go back. Let's test this one more time after I restart my server. And we type send request, and now I get a 404. But if we go back and we try 2 again, we also get a 404 not found, and that is because 2 is also invalid because we have 0 and 1 are our only valid values. There we go. That works perfect. All right, so now we have our get methods. So this is getting them all, getting 1. You could also do something crazy like adding in a filter route. So those are the R in CRUD. Those are our read routes. So the next thing, let's look at the C of CRUD, the create. And for this, the first thing you should think about is which of the HTTP methods do you think we're going to want to use? Remember, we have map get for getting. We can also do puts that are typically for things like updatings. We have delete that are typically for things like deleting. We have posts when we're typically sending in information. And so that's what we want for when we're creating. So if we send a post route to /blogs, and again, notice that these all have the same path largely. This isn't required. This is just sort of by convention. It's common to use that same path when you're working with data of the same type. It makes it really clear for the end user, sort of, this is how I manipulate blogs. I can get them, I can add them, I can update them by using that same path. And so for this method, what are we going to need to do to let them update a blog? Well, we're going to need to have them send us a blog. So we'll take in a blog and we will call this blog. Really original name there. And so what are we going to want to do there? So we have a list. So we just want to add to that list. So let's do blogs.add and we will add in the blog. And then let's go ahead and return results. I believe there is a created route. Yes, there is totally created. So that gives us the correct response to show that something has been created. And this expects a string and also what we're going to return. And so the string should just be a handy message. It's nice to do something like, let's send back the blogs / and then let's throw in that blogs.count -1, which will be the index that blog was created at. So that will be the first parameter. And then we also want to send back the blog. So again, all I'm doing here is sending back a string. This could be any string, would be valid. There are technically specifications for what you should or shouldn't based on the HTTP standard. Those are loosely followed at best. The world kind of does what's convenient. When someone's creating a blog, it's useful to send back a blog or somehow let them know that they've created a blog. So we will go ahead and try that. Now, coming over here, we need to, this time rather than get, we need to make a post. And we'll do http // localhost and 5217. And this will again be to blogs. But now we have a request that we're making. So the first thing we're going to do is we're going to want to set the content type. And it is smart enough there because we're using an HTTP file and application /JSON. Oh, the IntelliSense on REST client is excellent. Really do love this extension. So then this will have a title, and the title we will make it, oops, I'll put that in quotes. And the title will be my third blog. Super creative there. And then we're going to say body. And this will have, this is my third blog. Wow, a real nail biter. So let's see if we can go ahead and restart this. Yes, I want to restart my app. And let's try to give this a send. 415 unsupported media type. What am I doing here? I missed a P. Try again. Excellent. 201 created. That's exactly what we were looking for. Another thing we might want to test here is we can come up and we can do our get all once again. And you can see we did indeed add a third blog to our list. Awesome. Love it. The next thing I'm going to do is go ahead and create a delete route. And now for delete, we are going to delete something from this list. And again, you can think a little bit about how is that going to work. Well, we're going to need the ID they want to delete at or some other search criteria. We're going to do ID for now. And then because we're going to be deleting something from a list at a particular ID, we're once again going to need these checks. So I will go ahead and just copy this route down for our delete route. But again, I don't want a map get, I want a map delete. That is the semantically correct method to use here. You can use the other routes. Technically not going to break anything, but sort of confuses people. It goes against the conventions of the way people typically write these APIs. So now if someone sends a delete request to blog/ID, it's going to delete it. If they send a get request, it will get it. And so now think a little bit about what we want to do. So this is the same sort of logic here. Once again, if it's not a valid ID, we'll return not found. But if it is valid, we want to do, let's see here. Let's do blogs.remove. Yeah, remove at. That's what I wanted. Remove at. We will give that an index and we will give that an ID. It's also useful often to grab a copy of that equals ID, and then you can do something with that here. You could do something like remove it or send it back to the user sometimes is useful. In this case, we're going to go ahead and just send a results.no content, which means there's nothing to return. And so I will go ahead and comment this out. I just wanted you to know that often you'll want to grab that before you delete it in a situation like this. So let's come back. We will restart our application. And again, we reset our application. You see we have 3 items here. We don't actually have 3 items anymore. We're back to our original 2. So this has been reset. Let's go ahead and see that. There's our 2 items. So now what we want to try is running a delete. So again, it's much like getting a single item. We'll come down here and we will, instead of get, we will do a delete. Send request. 204, no content. It looks blank, looks scary for a second, but we didn't get back a 404, which means it wasn't a no content found. A 204 means it was successful. There was just no content to send back. If we saw a 500 here, it would mean a server error. Some kind of a 400 error means it's an error on the request. So we can go ahead and get our blogs again. And what do you think we're going to see? We had 2 blogs. We deleted 1. What should we see? Boom, a single blog. If we try to send a blog request to blogs 1, it's going to give us a 404 not found because the only blog that exists now is at index 0. If we change that to 0, send that request, totally works now. So our delete route now works. We are 3/4 of the way done with CRUD. We have created, we have read, and we have deleted. So what does that leave us? That leaves us with update. Now, update's a little bit of a weird one. This one is absolutely valid, comes about all the time, but that is a map put. So put is the method used for typically sending information. You absolutely do this with a post. Some applications actually do. It's more semantically correct, meaning that the method does what it says it's going to do if you use a put method. And so for this is actually going to work a lot like our post, really. So let's do that. It's a bit like a hybrid. So let's actually take the delete, because what are we going to need to do? We are going to need to identify the blog that we want to update. Then we are going to need to send in the updates. So it will probably take in an ID, and it will probably take in a blog object. So this gets us the closest because all of that checking takes a bit of work. We'll do that again. We'll make this map put. And this time it will take in both an ID and it will take in a blog. Sweet. That's valid code now. This will run. But what's the problem here? It's going to do this remove at. We don't actually want that. So let's get rid of all of this logic. What we actually want to do is we want to say blogs. So the blog at the given ID equals the blog they sent in. So blogs ID equals blog. And then we will return something. Let's return results.ok with the new blog. And now remember here, you don't have to use a results OK, results not found. You could do the exact same thing by just returning the value and then correctly setting the application type or the content type and setting the status code. Would get you that too. This is just way cleaner. Highly recommend doing this whenever you can. And so finally, we can go back, we can restart our blogs, and I want to show you the proof here that this is actually working. So the first thing I'm going to do is I'm going to go up, I'm going to get our blogs. You'll see that we have 2 blogs. So I want to say this is a put request, and we will put this change to our first blog, and we're going to lie and say that that is now our 3rd blog. So let's go ahead and send this. And there we got that blog post back. Now if I go back up, I get my 3 blogs, or 2 blogs, sorry, because I didn't add one. I updated it. So now you can see my first blog turned into my 3rd blog. So there you have it. We have created a fully functional CRUD API. We can create, read, update, and delete. This allows us to manipulate data, and it could be data of any kind. These could be blog posts. These could be medical records. These could be flights. These could be anything. When you start thinking about the internet, this is how it works. Like, this is one of the most underlying fundamental concepts of how things are built. If you get this, you add a user system to this, you add in some permissions, you add in some images, and you can build pretty much anything on the internet. There's no limit to what we can do using CRUD.
Routing ensures that every request, whether retrieving data, submitting forms, or updating information, reaches the correct function. With routing, your application knows exactly how to handle each request, ensuring that data retrieval, form submissions, or updates are processed efficiently. This keeps the user experience smooth and ensures that every action is executed properly. In this video, we will describe routing in ASP.NET Core. Let's begin by exploring how routing operates in an application. Routing is how an application determines which specific function or action to execute based on incoming input or a particular path in the application. When a user makes a request, like navigating to a page or submitting a form, the router decides which function or controller will handle that request based on the URL pattern, HTTP method, and additional parameters. Routing is like an address on a piece of mail, ensuring it reaches the right place. It ensures user requests like fetching or sending data are directed to the correct function. Now that we understand what routing is, let's explore how to define basic routes in ASP.NET Core. In ASP.NET Core, routing relies on defined patterns to match incoming requests with the appropriate functions or controllers. These patterns enable flexible handling of various requests, ensuring the right action is triggered based on the URL structure. Typically, routes are defined in the program.cs file, allowing developers to control how requests are processed and directed within the application. The basic structure of an API route starts by calling a map method on our app. These are methods like map_get, map_post, map_put, and map_delete, corresponding to the get, post, put, and delete HTTP methods. Let's review an example of an API route handling a get method. We call app.mapget and pass in 2 arguments, a string and a function. Let's discuss the arguments of the map function. The first argument is the route pattern or template. This specifies a pattern that must be matched in the request URL. In this case, we use the pattern /users. This is sometimes called an address, path, or slug. When a request matches that route, it will call a function and pass it the request. Now let's take a moment to discuss URLs in more detail. A URL is made up of different parts. When we make a request to our application running on our computer, the URL we send our request to will appear as something like https localhost:5124/hello. HTTPS is the protocol, localhost is the domain, 5124 is the port, and hello is the path. Our pattern seeks to match this path portion. If a user made a GET request to our application with the path /users, the function we define would be called. The last argument is the handler function that is executed when the route is matched. This is an example of a route handler function, and it can return a simple value like a string, a JSON object, or any other response type. Route handler functions are a type of request delegate. A request delegate is a fancy way of saying a function that can process a request. And route handlers are request delegates that handle requests that match specific path patterns. Other types of request delegates aren't limited to specific routes, and we'll discuss these when we discuss middleware. In this case, we define a function that doesn't take in any parameters, even though it could access the request as an argument if necessary. Our function returns the string return users. You can use either anonymous functions or predefined methods as the handler. An anonymous function, also known as a lambda expression, is a short, inline function that doesn't need a separate name. This is what we've been using up until now. Anonymous functions can be useful when the response logic is simple and doesn't require its own method definition. With an anonymous function, the handler function is defined directly in the route. In contrast with predefined methods, you just need to type the name of the handler function. Instead of using an anonymous function, you can use a predefined method. In this case, we extract our lambda function into a method named getUsers and replace our lambda function with that method. Now that we've discussed how to define route handlers, let's talk about route templates, starting with static routes. So far, we've been using a single route that will trigger when a request is made that exactly matches a single string. In this case, the string is users. We could also create handlers for other specific routes like admin and hello by making additional calls of the map-get method and passing in the strings admin and hello. These handlers each manage one route. Routes that require an exact path match are known as static routes. Sometimes it's useful to define handlers that can match multiple routes. One way to do this is by using route parameters. Route parameters are dynamic parts of a URL used to pass data like IDs to a specific route in a web application. Let's modify our /users route to take in a route parameter. Route parameters are named and enclosed in curly braces. In this case, we append a /, then ID in curly braces to our users route. ID is the name of our parameter and it will be passed on to our request delegate so we can use it in our function. It will then be passed as an argument. In this case, we'll call it ID and give it an int type. Then we'll log out of that ID. If a request is made to the /user/5 route, it responds user ID :5. If a request is made to the /user/3, it responds with user ID 3. The ID parameter allows this one route definition to handle many different URLs. This is also known as a dynamic route. When data isn't always required, optional parameters can be helpful. They allow routes to handle requests whether or not data is provided. To make a parameter optional, you append a question mark to the name in the route. A request delegate must also add a question mark after the argument type because it's now optional. We can modify our request delegate by giving the ID argument a default value of 1. Now if a client requests /users, we will return user ID 1. Route constraints are another useful feature of parameters. Route constraints are rules that can restrict what a data route can accept, ensuring that only valid data is passed. Constraints can be used to validate parameters to ensure they meet specific standards. We've been enforcing the type of the parameter by making the argument that our route handler takes as an int, but we can do it more explicitly by following our ID parameter with a :int. The constraint in this route uses an anonymous function that ensures that the ordered parameter is an integer. If someone tries /user/abc, it will reject the request. The characters ABC can't be parsed to an integer, but they will be passed to the route handler that expects them to be an integer. Constraints can do way more than check for the correct parameter type. A few common examples are making sure numbers fall in a particular range, strings have specific lengths, and you can even perform complex pattern matching using special templates called regular expressions. In this video, you learned how routing in ASP.NET Core maps requests to specific functions. Now you can configure flexible and valid routes to handle requests efficiently in your ASP.NET Core applications.
Let's explore building an ASP.NET Core app step by step and review different ways to use route templates to make your app flexible and dynamic. As we progress, we'll discuss key features like route parameters, query parameters, and constraints, and explain why these elements are important when creating a robust web API. In this video, we will explore advanced routing techniques in ASP.NET Core, including the use of route constraints and route templates, and provide examples to illustrate these techniques. Let's start by reviewing what a route template is. A route template, also known as a route pattern, is a string used to determine when a request path should be routed to a specific route handler. Routes can be static, where they must match a specific string, but an important use of route templates exists in creating dynamic templates that can be used across multiple paths. So you can see here a great example of a really simple route template. We just have this slash. We could also make this /users. These are all static routes. So let's show an example here of using a route parameter. So the first thing I'm going to do here is I'm going to add app.mapGet, and we will add in a dynamic instead of a static route here. We'll make a users route, and let's say we want to get a particular user ID, and we do that by putting the parameter in curly braces here in the string. So this is a value that will get passed in as a string, but it will get parsed out and handed over to our function, our request handler, our request delegate. And so let's say maybe we want their post, because we can actually take multiple parameters, and that post will have a slug. A slug is normally just a piece of text. And so that will work there. We'll say int user ID. So now we will tell this function that it needs to take in those parameters that we just created. These will be user ID, and we will also have a string of slug. And now we have those two values, and we can do whatever we want with them. They're just being passed in like any other value. So in this case, let's go ahead and just use a string template here and say user ID, and then we'll return that user ID. And then I also want to do that by putting that in parentheses. Now these have nothing to do with these up here. This is just how you can pass this data into a string using what is called a string literal or string template. So we'll say post ID and then slug. And so now that should return these two values. So let me go ahead and save that, open up my terminal, .NET, watch run, and then let's go ahead and make a new requests.hdp file, and I will copy that slug to make my life easy. Our app has started, and we will go to our requests. So I will say get local host, except I need http://localhost, and then this will be that /users/user ID, and we will actually replace this with a number, and the slug will be some text. Okay, that is now valid. So let's go ahead and send this and see what we get back. I'm getting a connection rejected, and that's because I did not put in my port. And again, port right down there. Hey, there we go. And that returned user ID and post ID. This might not seem like a big deal, but functionally what this is allowing us to do is here on our client, sending a request, we can send data to our API just through the URL. We're not sending this as the body of a post request or something. We're just sending it along for a particular route path. Really handy. Gets used all the time. And so we could change this and say, okay, I want user 10, and this will be Buffalo. And send that again. And now we've passed in different data. So you can imagine that if you wanted someone to maybe update a database based on what you're sending, or they wanted to get some different resource, they could use this get with these parameters. So you can do stuff like that. This has now made this route dynamic. And you can notice here that by using the int user ID as well as the string slug, we have defined what those should be. If I tried to send in a user ID of Buffalo and a post of 10, the 10 is likely going to work because that can be parsed as a string, but Buffalo cannot be parsed as an integer, and we're going to get a bad request. Failed to bind parameter int user ID from string Buffalo. Perfect, that's what we would expect. Go ahead and change those back to something that makes a bit more sense. So that is a route parameter. And again, I want to reiterate here that we are using a slug, which is simply a user-friendly string used to identify content, often for readability. Moving forward, I'm going to illustrate a route that has a route constraint. So this will be a parameter, just like we had before, but we are going to add some constraints to it, which, like the name sounds, it will constrain the types of values that can be passed in. So this time I'm going to say this is the products route, and the product will have an ID parameter. So we will pass in that ID in these curly brackets again. And to add constraints, we add a colon followed by the parameter we want to add to it. And you can see here we get a whole list through IntelliSense. The one I want to add here is this will be an int. And I also want to add a min to say this has to be greater than 0. I don't want a product ID of -1. It just doesn't really make sense. Typically, an ID is a positive integer if it is using a number. And so again, I will need a route handler that can take that value in. So that will be an int ID. And once again, let's return a string template and say product ID, and let's pass in that ID. So if we go over to our request, I will add a new request, and we will go ahead and make this products. And we should be able to type in like products 10 and get that back. And I need to restart my server because we added a new route. That I can send my request and I get back product 10. But now if I try to do Buffalo again, it's going to not be happy with me. And so you see here that we have an int constraint. Now, because our other route was expecting an int, that also provides sort of a soft constraint. This type of logic can be really useful as I could have a copy of this route that looked exactly the same, except it said string. So maybe I hand an int off to this route, but if a product comes in with something that can be parsed to an int, it'll be handed to this one, and now I could do the ID as a string. Not terribly commonly done, but there are reasons you might want to do this. I'm sure there are some edge cases. So going back to our routes, the other thing I want to test here is let's try -1. This is a much more versatile constraint. We should be able to send our quest and we get a not found. Then the last thing I want to do here is you can see that it didn't work for Buffalo. We will also see that, again, we can put in 10. 10 works, but if I put in -10, -10 doesn't work because there is not a route that meets that constraint. It has to have a min of 0, so that is a route constraint. Another thing that's useful here is let's look at a route that has an optional parameter. So let's say app.mapGet, and let's make this one a report, and the report will take in a year parameter, and that year will be an integer, but we want to make it optional so we can follow it with a question mark like so many other places in the language. We'll also say that will be an int of year, and it will have a default value of 2016. And because it is optional, we also want to mark it as optional here. Go ahead and complete out that function. And so now we can see here, let's say return report for year, and then we will add in our year value there. So now if we go over to our routes, we can copy this once again, and we will say report. And this time we can send it with, let's say 2024. Send. We're going to get a 404 because I did not restart. And now we're going to get report for year 2024. But what happens when we remove that, because it's optional now, you'll get report for 2016 because we set that as the default year. If we get rid of it, you will see over here, we can send. I need to restart my server because that change didn't propagate. You can see that we get nothing. It's just blank. So you do want to handle, or at least think about, the behavior that will be the default if that parameter isn't there. Another thing I can show is a catch-all route. So let's say app.mapGet, and let's make this a catch-all route. So we'll say files, because this is commonly used with working with file systems, and we'll say this attribute will be called file path. And now to make this a catch-all route, we will precede it. So right before that, put in an asterisk. And now everything that comes after files will show up as this. It won't just take the one value here. And this will expect a string that we will call file path. And let's just return that file path. Except I don't want a string there. I just want to return the file path itself. So now if I come back, copy that, let's say localhost and files / just a bunch of characters there. Can't have the space. 404 not found, restarting server. If I click here, there we go. It returns that. And so this can be really handy. Say you have a server where you're serving a bunch of files from and you want to browse it like a file structure. So let's say /images /cat _1.jpg. And then you want to do something with that data, maybe go to your file system and actually get that back. So you can see here, that whole string is coming through. So that whole complex file path can come through using a wildcard. Another really common requirement is wanting to add in a query parameter. Now, query parameters are a little bit more interesting here. So we can do a map get once again, and let's get / maybe we have a search route. This would be making a site maybe like Google or something. And you can see here, we have no parameters. We're still going to make this dynamic, but we don't need to use parameters to do it. So we're going to take a function here, and we are going to define a couple of arguments in our function that aren't defined as parameters in our path. So I'm going to say I have an optional string, and that will be named Q, and an int, and that will be page equals 1. So that will be our default page. So this is a really common pattern. So if you're searching on, say, a web search of some kind like Bing, it's going to probably have a Q parameter that's going to be the query string is what that stands for. So that is the search term you're looking for. And then it's probably going to have pages and pages and pages of results. So this would say, give me the first page. So let's just say here, we will return, let's say searching for Q on page. I like that. And so now, because we don't have an argument, you might be wondering, how do we pass that along? So the first thing I'm going to do here is I am going to once again copy this route, and we will go ahead and change this to be search. Now you're probably wondering, how do you pass through one of these query parameters? Well, the first thing you're going to do is put in a question mark. So the client is going to put this question mark here to say, this is the URL. Everything on this other side is going to be query parameters. And now query parameters are defined by a name or an identifier, and that's what we already did. So we will say Q is our search term. So let's say we are searching for .NET page equals 2. Now, the way you separate these key value pairs is an AND symbol. So you add that between them. So we have the key Q is .NET, the key page is 2. We're mapping this to this value and this to this value. Now that I've restarted my server, I can make this request. And you'll see here searching for .NET on page 2. So these two values got passed through. And now things get really crazy when you combine them. So we could do something down here, like we could say app.map.get, and this path is going to show us a little bit of everything. So let's say we want our store, and our store can have a category that people look up. So there's one parameter. And then we also want a product ID, and that product ID needs to be an optional int. Maybe they don't have to add that. And then I need that, and then maybe let's say we will also do a wildcard here, and we'll take in the extra path there. So now we have this route that is using a bunch of these different terminologies. We have these route parameters, route arguments, and then we have an optional parameter here, and we also have our wildcard, and now we need to handle those in our function. So let's say here we have a string for category, and then we have an optional int for product ID, and an optional string for extra path, and we can also just, for giggles, throw in stock equals true as a query parameter. That's what this sort of undefined parameter there will be used at. So now we have a route that's sort of using all of these things combined, and we could access all of those values in here. We have category, we have product ID. So now you can see that we can combine all of this information. Now, I'm not going to take the time to implement the function here because it would take a while, but now we could make a request to that route by saying something like, let's go ahead and just do that, and we could get /store, and we'll make the category electronics, and then we'll put 1, 2, 3 here, and then we will say that we want it to be on sale. Now, if I copy this route down here, and then we change this to a route that we could use on that new path. So let's say /store /electronics electronics /store. So this gives us a category of electronics, a product ID of 1, 2, 3, and an extra path of sale. But if the user just wanted to visit, or sorry, this would be sale. And then if the user just wanted to visit this without sale, totally valid because we have that optional sale there on the end. We could also do this, and we could take in that query parameter that was a bool. So we can say, what was the name of our query parameter? It was in stock. And we'll say that equals true. And again, because they're optional, we could get rid of that. This is also a valid path as well. So as always, I highly recommend you work through this code on your own. You sort of play around with these. Try to add different parameters. Try to add different constraints. Get a feeling for how these work because this is one of the big ways that clients will be passing information to your API, and you will be defining where they can send that information. By combining all of these routing techniques, route parameters, constraints, query parameters, optional values, and catch-all routes, you can create powerful, flexible APIs that respond dynamically to user input. And this routing flexibility makes ASP.NET Core a great choice for building robust, scalable web applications, ensuring that your API can handle a wide range of requests with ease and precision. Route handlers are essential in controlling what happens at each endpoint of your application. They allow you to define specific actions for each route. However, there are many situations where you need code to run across all routes or just a selection of them. And this is where middleware comes into play. In this video, we'll explain how to configure middleware in ASP.NET Core applications. We'll begin by revisiting our basic empty web app setup. This is just the create empty web app in .NET. And this includes a single route handler that maps a GET request to the root route and returns hello world. A route handler like this determines the behavior for each API route. However, adding code that goes beyond just the route handler is often necessary. Middleware enables you to add additional request processing beyond just our route handlers. One key benefit is the ability to run additional logic across different parts of our app instead of in just a single route. What you might not realize yet is that you're already using middleware. It's just happening behind the scenes. ASP.NET Core wraps your application in middleware. It's actually what happens things like routing. We'll explore that a little bit later, but for now, let's focus on adding our own middleware. The first type of middleware we will explore is built-in middleware. And so a commonly used piece of middleware is the HTTP logging middleware. And we can add that by saying app.use HTTP logging, and then we'll let IntelliSense autocomplete that for us. And so we now have installed middleware. What we're going to go ahead and add here is two things. One, we need to add a service, and we'll talk about services a little bit later. For now, you can just sort of follow along. Then we also need to change some configuration for our project to set the logging level. Essentially, at a high level, the logging level just means that logs can happen at different levels. So you have logs like, this is really important, it always needs to show up. Then you have some logs that are like, this is just for information I'm going to use as I'm developing. And essentially you can set the log level to say how important a log you want to show. It's sort of a threshold. So we're going to be setting that. Again, don't worry much about that. You really don't need to worry about this very often. But you do need to set it up to use the logging middleware. So the next thing we're going to do here is we need to add a service. And we talked earlier about this builder allows us to change the configuration of our application. And this is one of those times. So we're going to say builder.services.add HTTP logging. And now this needs a function that just does nothing. And this is going to feel a little bit weird, but this is just sort of the convention we need. You can change this function if you need to change the behavior of your logging. This just sort of uses the default configuration, which is good enough to demonstrate what we're trying to right now. The second piece we need to set up here is we need to set up some configuration. So we need to go to our app-settings.json file, and we need to go to our log level. And then we need to add in the key Microsoft dot ASP.NET Core dot HTTP logging dot HTTP logging middleware. Now that is a mouthful, and I'm going to double check that to make sure that is correct. It's Microsoft.ASP.NET Core.HTTP logging middleware. We'll add a colon and then add the value there, and we'll set that to information. This basically says show us pretty much all logs we could produce. That way we always get that output. And then go ahead and save that. And you saw me just put the comma there. Some languages support what is known as trailing commas, so that would be a comma here at the end of this dictionary. In this case, it does not. It's just sort of a habit from programming in other languages, so please don't add that extra comma. And if you are used to working in a language, know that. So now our app settings is done. Our program is done. We should be able to pop open our terminal. So I'll just hit Command tilde or Control tilde. And now I am going to say .NET run. And it will take a second to build here, and we should see our web browser open up as long as everything compiles. Hey, there we go. And it does not look like it automatically opened. So a key here is I can hit Control, click that link, and boom, there we go. So now we get this hello world. And now this is where our logging middleware came in. So if we didn't have this logging middleware, we wouldn't see all this output. So this is a bunch of information that is sort of diagnostic about the request that was made. You can see the middleware, what the response status code was, the content type, the date it happened on, all of this information. So we can go ahead and even see here, let's see what the route was. It went and got our favicon, which is the little icon up here. Then the next piece I'm going to add in here is another route. So let's go ahead and copy and paste this. And let's call this route hello. And it's warning us there that we don't want a duplicate route. And I will say this is the hello route. And then we will go ahead and save that. And remember, what do we need to do now? We need to restart our server. So what I can do here is I can hit Control C a couple of times, and that will close me out, and then I can say .NET run. The other thing I can do here is run .NET watch run. So .NET watch run will actually watch for changes in my file and then restart the server. Now it doesn't always work, but it will also allow me to use Control R to restart the server. This is really handy. It's almost always how I want to run my web apps. You can see here again, we get our output, and you can see the path here. The path is root. And now if we go over to our local host, we can do hello, and we should see our terminal output reflect that. So now if we scroll down, we should see this output, and that was our hello route. Now the thing that's neat about this is now code that is running on every route we've called. So these getters only run at this particular path. But let's imagine you wanted to authenticate a user at every route they go to. That's where middleware would come in. You can run it on multiple routes, whereas our handlers are set to just run on a route or a small series of routes, like we'll talk about later. So this is built-in middleware. This is sort of middleware that someone has already created functionality for us. In this case, it's logging. Now we can build our own middleware, and often you will want to when you're developing. Now, the way you'll do this is you'll say app.use. And now app.use is going to take in one parameter, and that is a request delegate. And this request delegate, again, is just a function that processes a request. And in this case, it's a function that's going to be one, asynchronous, and two, it's going to take in two parameters. And these parameters we're going to call context and next, and we'll get to those in just a second because they are absolutely critically important. So now we have app.use, and this does absolutely nothing. It's just a function that would run in the middle of our application and do absolutely nothing. And so we want it to do something. And let's talk about these parameters. So the most basic type of middleware you can possibly make is something like this. And this is what is known as terminal middleware. A terminal middleware will just stop the running of our code. And that's because it doesn't call the next middleware a route. So this parameter right here is actually a function that we can call. So what we're going to do is say await next dot invoke. And so this is saying, hey, I'm a function. I want to call the next function in this pipeline. And that next function will be the next route delegate, the next middleware, or the next route handler. So now this is absolutely valid middleware. It doesn't really do anything other than calls the next middleware, but it is middleware. And what we can do is we can start putting logic in. So we can have logic here. We can also add in logic down here. And we would want to add those in those two places for different reasons. And I will go ahead and talk about that now. So the reason you would want to add logic up here is this is logic that will run before this function is called. Again, this runs just like any other function. It will run top to bottom. So what you're getting is this is something that will happen before the next middleware happens. But you can also run code after the next middleware happens, and that code you put down here. So essentially you end up with this way to sort of daisy chain together different middlewares where one will call the next, then each will sort of give back control to the previous middleware to do anything it needs to clean up or to finalize what it has to do. And so this is how we build custom middleware. So let's go ahead and add in some logic here. So I'm going to say console.writeLine, and I will say logic before, and down here I will say console.writeLine, and I will say logic after. And I will go ahead and save those, and I will run this, and I'm going to go ahead and comment out our other logging so we can see this a little easier. Again, we want to come down here and restart our application, and because we used watch, I can now hit Control R, and it's going to build again. So that just reset our application without needing to close it and reopen it. Really handy there. And so if we come up now, we should see the output of both of these middlewares. So if I rerun this route, you'll see here that we have a whole bunch of logging that looks like our original use HTTP logging. And then you see our logic before and logic after. Then you see some more logging. And that's because the use HTTP logging middleware is actually doing something before and doing something after. So this does something before our middleware, and then it also logs after our middleware. Now, this is important to note here that this middleware comes before this middleware in the sequence in our file, and that means that this middleware runs before ours does. Essentially, it'll do the before logic here, then the before logic here, then finally go to wherever it terminates, probably in one of these route handlers, and then it will run this logic here. So the after logic, then it will run the after logic here. And we can demonstrate that. So you see, this is the before logic of the logging middleware. This is the before logic of our custom middleware. Then we have the after logic here of our custom middleware. Then we have the after logic here of our HTTP logging middleware. Now, if I cut this and add it before, we have now actually changed the sequence that we are going to run these in. So I'm going to save that again. I'm going to come down. I'm going to hit Control R to make sure we do a proper reload. I'm going to open up Edge, and I am going to go ahead and refresh that. And now you can see this order is different. So somewhere up here, here we see logic before. So now this logic runs first, and then it runs the initial logging over here, and then it runs to the terminal route, so it runs all the way through this, and then it will run the after logic down here, which is our final middleware, and then it will run the after logic in our first middleware. So they sort of, the before logic goes the first all the way to the last. Then the after logic goes the last all the way to the first. Let's comment this out, and maybe an easier way to understand that will be to show a couple different copies of this middleware. So let's give these some numbers here, because I really want to nail this one in, because this is a really important concept here. So now I'm going to restart again. So now we have three middlewares. We run the logic before, the logic after. These all have numbers. So stop real quick and think for a second. We talked about the order that these should show output in. What do you think we're going to see? You're going to see these 6 lines logged in the output. But which order do you think they're going to happen in? If I go over to Edge and restart, here you see we get the first line, the second line, the third line, and then they go in reverse order, the third, the second, the first. And again, if I mixed up these orders, you would see that order change. You end up with a sort of pyramid where it works from top to bottom, bottom to top. Now, this is a really important concept because I mentioned earlier that behind the scenes, .NET is actually adding in middleware. I'm going to go ahead and remove these because I just want to show some concepts here. So behind the scenes, what .NET is going to do is it's going to do a few things. It's going to use a middleware called routing. So it's going to call app.useRouting. That will start using the logic that you need to actually run these different routes. And after all of your logic, it's also going to call app.useEndpoints. And that is, again, the second part of what actually uses your route endpoints here. These map gets, map posts, map puts. This logic is handled by middleware. You just don't know it because, again, it happens behind the scenes. The other middleware it's going to add, there are 3 of them. So one, it's going to call conditionally app.useAuthentication, and it's going to call app.useAuthorization. And these are to provide you the ability to have users log in and check who they are. And I said these were conditional. So what this is going to do is check to see if you've added services that use authentication and use authorization. So this sort of automatically adds the middleware if you've included the services. It knows like, hey, you added a service to check authentication, you probably want to use the middleware. So it just does that. That's one of the great things about using a platform like this. And the other thing it's going to do, it's going to come down and it's also going to use exception handler, app.useException handler. And now what exception handler is going to do, again, this is going to run conditionally. This will only run when you're in development. And so this, when you have an error on the server, rather than just sort of not letting you know what happens, it will give you a really nice error page. You will see these a lot, and it will give you all the full stack trace and all the information you need to help diagnose that error. But again, it only does that in development because that's not something you want to expose to an end user. One, because it's confusing and sort of weird looking, so it provides a weird sort of user experience. but also because it provides a security vulnerability. That's information that someone could potentially use to do something malicious. It gives them insights into how your application is running, and you really don't want that. So again, I want to reiterate here, you don't need to add these middleware. They already exist in your code. They're added around all the code. I can go ahead and get rid of this one real quick because that's not one of them. That's one you had to add explicitly. But they happen in this order essentially. So it adds all of these middleware before your code, then it adds use endpoint after your code. Again, that order matters. You can also add these somewhere else if you want to. You typically don't need to, and that will overwrite the implementation that they have given you by default. That's again one of the things it's checking conditionally. But just know that behind the scenes, use routing, use authentication, use authorization, use exception handler, and use endpoints are being called on your behalf. All you need to worry about is what's happening here. The only time you would worry about these is if you need to change the default behaviors of .NET. So there you have it. Both custom and built-in middleware play a crucial role in how your ASP.NET Core application processes requests. They enable you to execute code across multiple routes and enhance your control over the request and response cycle. Properly configuring middleware is key to building robust APIs.
In this lab, we're creating a simple product catalog using an API in ASP.NET Core. We're going to set up CRUD operations. CRUD stands for create, read, update, and delete. And we're going to make API calls that will allow us to add, update, and remove products using those 4 different types of commands using ASP.NET Web Core. In the first step, we set up and define a basic application using the template. I've already got that application set up. The first step is just to use the template using .NET New Web API to create a basic Web API application. In step 2, we define the product model, and the product model is simply the class that we're going to use to store and update and retrieve data when we're using the product catalog. So the first thing I've done is I've created a models folder here in the root of the application. Then I created a product.cs file, and inside the product.cs file is a simple product class that we'll use as our object to store and retrieve data using the API. We have 4 properties: ID, name, description, and price, each with their own specific variable type. And this will just store data for when we need it. In step 3, we implement our CRUD endpoints into our API. And for that, I created a product controllers folder. I created a controllers folder in the root of the product catalog API project. And then I created a product controller.cs file, which is going to store each of the endpoints for our API. You'll notice here up at the top, I have some using statements that will allow us to use the various libraries that we're going to need for our API. And then you'll also notice the route. The route defines what the URL has to contain in order to hit the API. So our route will be the domain name. In our case, it'll be localhost. And then we have to put API/products in order to hit the API. Then we have our API controller, which has all of our CRUD methods in it. You'll see here at the top, we have 2 get methods. This is the read operation in CRUD, the R. And in these get methods, we just retrieve data. So in the first get method, that one gets all the products. Any product that's in the catalog, it'll retrieve every one. And you can see the get all method there will retrieve all the products and put it into a products object. The action result is just the keyword, the key method that ASP.NET uses to perform any kind of operation inside the API. The second get method, you'll see this ID in parentheses and curly brackets. And that tells the route that when we pass in a number, an ID number, it's going to retrieve a specific product. And you can see that there's a method called getById here. And we pass in the ID that was passed into the route, into the API call. And that method will look up the specific product by ID. And you can see inside the method that it's going to find the first or the default, which is the first one in the list, that matches that specific ID, and then it's going to return the product. We also have some error handling in there if it's not null, and then if it does find it, it returns okay with the product value. So those are our read operations. Our create operation, the C part of CRUD, is HTTP post. And in this one, we have another method, action result method, but this method is create. And we pass in a product object defined in the new product variable. And here we just take our product ID and we increase it by 1. So how many products are in our catalog, we're just going to add 1 to that number. Then we make the products.add call, which is a method call passing in the new product. And then we return the ID plus any of the product information when we create that product. So that's our create operation. Next, we have the HTTP put, which is the update operation, the U part of the CRUD operations. And again, here we're passing in an ID because when we update a product, we're going to update one product at a time. So the API needs to know which product we want to update. So we're going to pass in the ID number for updating that product. And then we make a public action result update method call, passing in the ID and any updated product information in the product object that we create. And then it just goes through, the rest of the code goes through and makes any updates that need to be made. The product name, if there's a updated product.name value, it will replace that product name with that value, and it'll do the same for the description and the price. Once those updates have been made, then it just returns okay with the new values returned to the calling code from the API. The delete is very similar. This is the D of the CRUD operations, obviously, and we use HTTP delete as the route, passing in again the ID because we're only going to delete one product at a time. In this method, the action result delete method, we're looking for the product that matches the ID. If it's not found, we return not found as an error handling. If it is found, we remove that product and then we return no content. We just return blank. This class defines all of our routes and what actions we want to take when the calling code calls that specific route against the API. So that's step 3. In step 4, we're just going to test each of these routes with Postman. So in order to test it, I'm going to run this application. You'll notice when the application runs, we're going to get a URL, the base URL, which is localhost 5107. So we'll go into Postman and we'll put in localhost and the port name. And then we have to put in our route that we defined in the API under the route heading. So now we're using our get operation. This is our read operation. And we're going to get all products because we're not passing in an ID. So when I click send, you can see it found the API just fine. We've got to return 200. But you'll notice that it's empty because we don't have any data that we've passed in. So in order to create an item in the catalog, we'll use our post. This is our create operation. And we have to pass in some JSON data. When we pass in JSON data, we're going to define each of the properties in our class that we defined in our API. So we'll give an ID of 1, name of product 1, a description. This is a product description and a price of $9.99. Now we're using the post call, so that's the route we're using. And when we click send, it will pass in that data in the body and return the information for the product. We can test this. I'm going to switch over here so it's less confusing. We're going to call our get method again and get all products back. And now when we click send, it should return our product. And it does. So now we have our product, ID of 1, our name, description, and price. Now let's suppose we want to update this product. We use our put statement. We also have to pass in a body. You'll remember that it takes the data that we pass into the API to do the update. So I'm going to say this is an updated product description. We're going to actually have to pass in what product we want to update because we have to pass in the ID. So we're going to update product 1. And when we click send, it updates the information in the API. You can see it returned the updated product. And now we'll go back again to our get call. And I'm just going to leave the /1 in there to let the get statement. We'll test the second get statement to retrieve product 1. And when we click send, we'll get back the individual information. This is now the product that we've updated. And you can see it has the updated information that we used from our put statement. And that's a very basic, lightweight product catalog using ASP.NET Core. Think of your code like a machine made up of different parts. Changing one part could affect the others. Dependency injection helps keep pieces of code separate so they can be exchanged for other parts or updated without breaking anything else in the code. In this video, we will explain the concept of dependency injection in ASP.NET Core. Before discussing dependency injections, let's discuss what dependencies and services are. In software, a dependency is an external object or service that a class or function relies on to perform its tasks. When the dependency is an object, that object is called a service. A service is simply an object that performs some utility for another class or function. For example, one of our API routes might need access to a service that handles authentication and authorization when requests are made. That service is a dependency of our API route, and that service is just an object that can handle authentication and authorization. The simplest way to create a service is to manually create an instance of that object within our API route, but that causes a problem called tight coupling, where making changes to our service can break other parts of our code. If we have 100 routes that need this service, it also means that if we want to change the code in one route, we have to change it in 99 other places. Also, imagine each route is called thousands of times per hour. This means that each time any of our API routes is called, it creates a new instance of this object, which has serious performance implications. Now that we understand the issues with manually instantiating services, let's talk a little more about how we can solve these issues by using loose coupling. Loose coupling is a design principle in which components have minimal dependencies, allowing changes in one part to have little impact on others. This improves flexibility and maintainability and makes the system more resilient to modifications. Let's return to our authentication example. Imagine you're working on an application that needs to verify users when they log in. Instead of directly creating an instance of our authorization service, it uses an IAuth service interface. The key part here is that the application doesn't care how authentication happens. It only knows that it will use a service that implements the IAuth service interface. IAuth service is a general contract that says, I need to authenticate this user, without specifying the implementation details like checking a database. To help reduce tight coupling between components and make code more modular, testable, and maintainable, we use dependency injection. Dependency injection, or DI, is a design pattern in which objects receive their dependencies from an external source rather than creating them internally. Let's explore some benefits of dependency injection. With dependency injection, you provide the actual authentication logic from the outside in a way that is loosely coupled. DI is helpful in this injection because the application doesn't need to manage or know the authentication details. It simply relies on the service provided through the DI. Another benefit is increased performance. We can choose when and how a service instance is created through dependency injection. Maybe we only ever need a single object to handle our requests, or maybe we need a new instance every time it's used. But our API route doesn't have to concern itself with any of that. We get to decide when we set up the dependency injection, and reducing new instances increases performance. Finally, a benefit of dependency injection is that it's more maintainable. Again, if we had many different routes that depended on the single dependency, we would only have to change it in one place, which makes our code more maintainable. We can also use DI to swap the authentication method. Say you decide to move from database-based authentication to an API-based authentication. Since the application only depends on the IAuth service interface, the general contract, you can inject a new API-based authentication service without changing the core application logic. The flexibility provided by DI ensures that changes to one part, for example authentication logic, doesn't affect the rest of the system. This is that loose coupling we discussed earlier. Loose coupling improves maintainability and adaptability, making updates, like switching from a database to an API, smooth and efficient. In this video, you learned about dependency injection, loose coupling, and how it improves maintainability. With dependency injection, you can update services like authentication without rewriting your core application logic. This keeps your code flexible and easier to manage in the long run.
Imagine you're building an app that needs to perform tasks like logging information, accessing a database, or handling user input. In a large application, these tasks are often handled by something called services. We'll explore how to create services in ASP.NET Core, how to use and control their behavior, and how to use a powerful feature called dependency injection to make your app more organized and scalable. In this video, we will implement dependency injection in ASP.NET Core. We will build a simple service that logs a unique ID whenever it's created, so we can explore how often and when each service is used. There are all kinds of middleware in .NET. If we come over to our builder and we go to services, you'll see here we have add anti-forgery, add certificate forwarding, add connectors, controllers. All of these are examples of services. And so we could add any one of these, and often we will need to, say for authorization or authentication. But we're not going to add one of those right now because I want to show you how to actually build a service. So to create a custom service, we need to define an interface. So we will say public interface, my interface. And then we're going to say this will return a void, and it will have one method called log creation and string message. Next, we need to create a class that implements this interface. So let's say public class my service, and this needs to implement that my service. And so this will have a single private read only int, and we'll call this service ID because this will be a unique ID that it'll hold. Then let's make the constructor, and this will set that service ID to a unique ID that will make pseudo unique just with a random number. So it's possible there's a 1 in a million chance this will clash with another one. There is 6 there. I like that. And 1, 2, 3, 4, 5, 6. So this will be a random 6-digit number that is assigned again at the beginning of the constructor. So this will be assigned when it is created, not when we call this method a log service, which we need to implement. So we'll do public void log creation, do string message. Now this is saying didn't finish, and now we did, and so we'll do a console.writeLine because this is just a void return here, so we don't need to actually return anything. So we will return a string that is message, and we'll say service ID. So now we have an interface and a class that implements that interface, and that's all you need to do dependency injection. There's nothing special here. Services are just objects. Typically, they're an object that does something useful for the rest of your app. All right, so now we can move on to registering our service with our application. We will say, again, builder.services like we saw before, but this time I'm going to do add singleton. So this is a way of adding a custom service, and we want this one that takes in a type, and it wants two things actually. It wants my service, and it wants my service. So it wants the interface, and it wants the class of the service you are going to use, and that is a method that we need to call. And now looking here, it looks like I goofed up and I did not actually type this correctly. I called it my interface, and I am actually going to call that my service. I think that's a little more explicit. Okay, now if we go back up, this should be correct now. So now we have this builder.services.add singleton my service, my service. So this will, when we want it to, create an instance of this object. And now the reason it needs this interface here is this now means that I can replace this, the my service, with any object that implements that interface. And what's so handy about that with a service is it means that you can have one particular implementation of that service. Say it's providing access to your database and you move to a new database, you can just flop that in. As long as it implements the same interface for accessing data, you're good to go. You don't have to make big breaking changes to your code. Now, I mentioned earlier that we created this log at the beginning of the construction of the service. Now, the big thing here is with a singleton, you only ever create one instance of that object. No matter how many times I call this, only one will exist. There are absolutely other ways to do this, and we will show those here in a second. But this is one of the most popular because often if you have something like a database connection, you don't need to keep recreating that. You need one connection to your database that everything else can use. And now if I come down here to my request, I can actually get access to that. I can say I expect an my service, and this will be my service. And now we can get access to my service in this handler. So let's go ahead and expand this out. My service dot log creation root will be our unique message. And then we'll return results.ok. Check the console for service creation log. Excellent. So now we can go ahead and start up our application. And I am going to make a requests.http file, .NET watch run. Now looking at this output, it looks like I got an error, and the service collection cannot be modified because it is read only. Poking back here at the service, it's because this is after app. So now it's before app, because once you use builder.build, it is now read-only because you have already built your application. Built-in safety mechanism there. So if I save and restart, this should be good to go. Excellent, and it is running. So let's go 5124. So get http://localhost 5124. Let's make that request. And there we get root service ID 208.310 both times, which is what we were expecting to see, that same ID over and over and over again. Now note that this ID will change because, again, it is stored in memory anytime you reset the application, but for the lifetime of that application, it will stay consistent. Just to demonstrate that real quick, I will go ahead and restart our application again. And when it pops up, you should see it open up and access the root, and that will give us a new service ID. So we've got 700.619, and before we had 208.310. If I get a few more times, same thing every time. Okay, so let's make this a little more interesting. And to do that, let's add a piece of middleware. And the reason is I want to call this multiple times on each request. So let's say app.use and async. And this will have a context and a next. And then we'll say var my service equals context dot request services dot get required service. And this will take in a type of my service. So that's telling us which service it's trying to grab. And that's a capital S. Excellent. So now it is getting a copy of the service. And then we'll say my service dot log creation, and then we will await next dot invoke. And log creation takes in a string, and we need to call it. So I will say first middleware. All right, so now we have a middleware that uses our service. Now notice here, it's a little bit different the way you get it. Down here, service was coming in directly as a parameter to the function when we use the get. In this instance, we're pulling it in using the context. So it's context.requestServices, and then we get that service in myService. Let's just add a second copy of this to better illustrate this, and we will call this second middleware. So now let's go ahead and restart because we added these extra middleware, and I don't think it'll pick that up on a hot reload. And now if we go to our request and make a request, how many times do you think you're going to see a log? We've got the two middleware and we've got the one request. If we send that, first middleware ID, second middleware ID, root ID. So all three of these got the same ID. No matter how many times we call this, we're going to get that same ID. So let's go ahead and make a slight change here. I'm going to change add singleton to add scoped, and go ahead and save that. And this will change the behavior. With scoped, a new service instance is created for each request. This means that all the middleware and the endpoint will share the same instance within a single request, but a different instance will be created for each new request. So let's go ahead and start this again and see what we get. So if I come up and I make a request, we see 573.320 on all three of these. But if I make another one, this is a new request. So you would use add scoped when you want a service that is scoped to each request. And there's one more I want to show, and that is add transient. Now, transient will create instances even more frequently. So when we register the service as transient, a new service is created every time the service is requested. So each middleware and each endpoint will get a fresh instance of the service. So when we call request service, this is creating a new instance of that. When we get my service down here, it's getting a new instance of the service. So once again, I'll hot reload this. Now if we come and run our request, we should see 3 numbers. I hit request again, 3 new numbers. So each time this is making a request, it is getting a new instance of that. And now I hope this really illustrates that a service is just an object. That's all it is. People use fancy language like services, but it's just an object that's meant to do something for your application. And in this case, it's just a simple thing that will log out its own unique ID. So there you have it. You now know how to create a service, make them available to your API through dependency injection, and change their scope to meet your needs.
How do you ensure your code works while depending on external systems like databases or services? Using dependency injection and mocking, you can test your components in isolation, making your code more flexible and easier to maintain. In this video, we will explain how to write unit tests for components that use dependency injection. Let's begin by exploring unit testing. Unit testing is a software testing method where individual units or components of a software package are tested in isolation from the rest of the application. This helps catch bugs early, ensuring each part of the software works correctly before integrating it with the rest of the system, and it improves overall code quality and reliability. Now that we've defined unit testing, let's explore how mocking can help us test code that relies on external services. Mocking involves creating simulated objects or services that replicate the behavior of real ones to isolate and test specific components. This helps ensure your tests are faster, more reliable, and focused solely on the unit's behavior under test conditions. It also makes it easier to find and fix issues without needing real services that may not always be available or practical. Let's examine the steps to complete a unit test. First, set up the test environment by configuring your component to use mock services instead of real ones. This allows the code to be tested in isolation. Next, you will configure a mocking framework to simulate the external servers. To create mock services, install the framework using a package manager. Then configure the mock service to return specific data needed for your tests. Now set up the mock to simulate the behavior of the external service, defining what data should return during the test. Inject the mock service into the component to replace the real external service. This ensures the test is isolated. Finally, the component will run with the mock service in place to simulate real-world conditions during testing. Now that the mock is in place, let's write the unit test to check that the component behaves as expected when the mock service returns specific data. To write the unit test, first define the input conditions for the test, specifying what the mock service will provide to the component. Then call the method in the component that processes the input and relies on the mock service. Last, use assertions to verify that the component's output matches the expected result based on the mock input. After writing the test, use a test runner to execute the unit test and verify whether the test passes or fails. If the test passes, the component behaves correctly based on the mock data. If the test fails, review the error messages to identify and fix issues in the code. Now let's examine an example to illustrate the steps of completing a unit test. Imagine you're working on an online shopping application and you want to write a unit test for the Add to Cart feature. The goal is to ensure that when a user adds an item to a cart, it behaves correctly under various conditions. You start by preparing everything you need for the test. In this case, you create a test cart and ensure any services or dependencies are configured. You might also ensure that your test framework is initialized. For example, you create an empty cart object and ensure that the environment is set up to allow you to add items to the cart. Next, you mock the external services the unit depends on, like a product database. This mock will simulate the behavior of the real database, allowing you to control what data it returns without actually accessing the live system. For example, you create a mock of the product database, which returns a predefined product, like product ID 101, and a product price of $20 when queried. This avoids connecting to the real database. Now you write the actual unit test. This test will use the mock objects and call the add to cart function to check if it behaves as expected. You'll verify that the correct product was added to the cart and now contains the correct product details. For example, you write a test that calls the add to cart method passing in a mock product ID. The test checks whether the cart now has one item with the correct product ID, price, and quantity. Finally, you run the test using a test runner. The test runner executes the unit test, reports whether it passed or failed, and provides feedback. If the test fails, you'll notice details about what went wrong so you can fix the issues. For example, you can use a test runner to run the tests, and it tells you whether the add to cart functionality is working correctly or if there are any bugs. Using unit tests with dependency injection and mocking frameworks ensures that your code works as expected, even when it depends on external services. This method helps you build more reliable and maintainable software. In this lab, we're creating a basic ASP.NET Core Web API, and we're going to use dependency injection to create some middleware that we can use within our API calls. So the first step in this lab is to essentially set up a templated project. We're calling it DI project, and we're just going to use the basic template for that using .NET New Web API as the command. In step 2, we set up the interface and a service class. To do that, in the root of the API project, I've created a file called imyservice.cs, and it just has a very simple method, log creation, and logs a message to the log file. That's just the interface. That's what defines what anybody that implements that interface will have to be able to make sure that they call. In step 2, substep 2 of step 2, create a myservice.cs file. And here's where we do a little bit more work. We create a public class called myService that implements the iMyService interface. I'm creating a private read-only variable called _service_ID that will create a random ID number. We have two methods. We have a public myService method that creates that service ID, and then we have implemented our interface, our iMyService interface here, the log creation, that writes out a message that we pass into the method with the service ID that we create. So it's a very simple class that does a couple of things to demonstrate how the API calls work using dependency injection. In step 3, now we're going to register the service in our main program. We have all of our important builder options here, and now we're going to add a singleton interface. We use builder services add singleton for that. And you can see we're referencing the iMyService interface along with the myService class, and we're going to create that as a singleton instance. By using a singleton instance, we're using a single interface instance across all calls that will be made using the middleware that we're injecting. So the ID number will never change because it's using a single ID number across each call. In step 4, we're adding middleware to log our service lifecycle. So this is where we're just showing how for each different type of call that you make using the services in the builder object for our web application, each call will either use the same ID number or will change based on what type of call you make. Now for the singleton, since we've only added the singleton so far, it will always use the same ID number because it doesn't change for each call. So the first thing that we add here is the use statements. We have the first use statement. This is the first middleware. What it does is creates myService variable that uses the get required service iMyService interface. The get required service is the service that this middleware must use. And then it logs to the log file that it's called the first middleware. The await next tells the application to wait a little bit till that completes before moving on to the next middleware. You'll notice that in the top here it says async context next, and that just tells the application that once you're done with this middleware, once you've made the calls and done the work that you need to do, Move on to the next middleware in the list, and that's the second app.use statement. It also calls getRequiredService, passing an IMyService interface as the type, and then it logs to the log file, the log interface. It logs that it's ran the second middleware, and then also awaits. Now for each of these, because we've created a singleton service, each call to getRequiredServices should maintain the same ID. We're not going to increase or change the ID. It will always use the same one, even though we're making two app.use calls to that service. In step 5, we're going to create a path, a route to be able to use the service. And for that, we use the app.mapGet command. That just tells the application when we're going to hit the root of our API to make a call using IMyService, and then the myService variable. We're going to log the item that we're at the root to the log file, and then we're going to return that the results are okay, or 200 in the web response. So this just tells our application that we're going to use a single route. It's going to be at the root of our API, and then it's going to call the middleware once the application hits that path. And that's a very simple way to illustrate how to use dependency injection and middleware in ASP.NET Core. Unexpected issues can crash your app without proper error handling and negatively impact user experience. Proper error handling ensures that issues are managed smoothly, providing informative messages, logging errors for developers, and maintaining a stable user experience, even when things go wrong. In this video, we will describe error handling best practices in ASP.NET Core. Now let's explore some common error handling techniques in ASP.NET Core, starting with try-catch blocks. A try-catch block is a programming construct used for error handling that tries code and catches exceptions to prevent crashes. It allows you to try a block of code. If an exception occurs during execution, the catch block will handle the error without crashing the program. The logic is simple. You place the code that might cause an error inside the try block. If an error occurs, the catch block will handle it. This way the program doesn't crash, and you can define what happens when the error is caught. For example, if a database update fails, a try-catch block can catch the error and show the user a helpful message. This allows the app to continue running without crashing. It's a good practice to catch specific exceptions, like database errors, rather than catching all errors with a generic exception handler. This makes it easier to pinpoint and fix issues when something goes wrong. The try-catch block has three main parts. First, the try block is where you place the code that might cause an error. For example, if we have two variables, the numerator being 10 and the denominator being 0, that we intend to use to complete a division operation, we must ensure that the denominator 0 doesn't crash the program. Second, the catch block handles any exceptions in the try block. For example, when the denominator is 0, we create an exception using a catch block and give the console an error using console.writeLine with the message, error cannot divide by 0. This can even be written to catch and define the responses to specific exceptions. In this example, we use the divide by 0 exception, a built-in arithmetic exception in .NET. You can also add a finally block. This lets you close a file or release memory regardless of whether an error occurred. Here, after attempting division, we add a finally block to complete the division. We will provide the user with a message using console.writeLine that reads, division attempt completed. This will let the user know the operation is finished. Try-catch blocks handle specific errors, but global exception handling is needed for errors outside these blocks. Global exception handling is a centralized mechanism to catch and handle all unhandled exceptions that occur during runtime. Instead of handling exceptions in individual blocks of code, global exception handling ensures that any error, no matter where it happens, is caught and managed in a single location. For example, if a third-party service your app relies on fails, global exception handling can catch the error, log it, and display a message like, there's an issue. Please try again later. In ASP.NET Core, you can use middleware to catch any exceptions during a request and provide a global place to handle and log them. This ensures users receive a proper error message. Let's explore how to configure the middleware step by step. First, you create a global exception handling using middleware directly in the program.cs file. The app.use method can be used to implement exception handling. This method is a part of the middleware pipeline setup in ASP.NET Core. It registers middleware to be executed during the request response pipeline. This is an asynchronous function that takes two parameters, context and next. The parameter context represents the current HTTP request response context, and next refers to the next middleware in the pipeline. The body of the middleware function is currently empty, meaning it doesn't do anything with the context or modify the request response. Then we'll include a try-catch block inside the app.use method. The try block allows the request to continue, while the catch block catches any exceptions. Next.invoke is an asynchronous method that calls the next middleware in the pipeline to process the request further. Using await ensures that this operation is awaited, meaning the execution will pause until the next middleware completes processing before continuing this block. If an exception is registered while processing the request somewhere else in the pipeline, the catch block will capture it. Finally, we use a console.write line to return a custom error message. In this example, the message will be global exception caught and then an appropriate message for the error. If you attempted to divide by 0, the message might read global exception caught, attempted to divide by 0. Last, log the error and return an error status code. In this example, if an exception occurs, we will log the exception's message to the console in the catch block with exception EX. The $EX message syntax is string interpolation, which dynamically inserts the exception message into the string. String interpolation involves using a $sign and X message enclosed in curly braces. It allows you to insert an external variable or response, like an exception message, into your message string. The exception message is specific to the exception that is caught. C# has several built-in exceptions like divide by 0 exception or null reference exception. In this case, when we receive an error, we instruct the program to display the status code 500, which indicates an internal server error. Next, we add an error message to the HTTP response body asynchronously. We use await and then context.response.writeAsync, passing in the message as the string, an unexpected error occurred, please try again later. By using await, we ensure that the call to write async is awaited, meaning it won't block other operations while writing the response. In this video, you learned how to handle errors in ASP.NET Core using best practices. We covered managing client and server errors with try-catch blocks and global exception handling to catch unhandled errors. Middleware helps manage exceptions centrally, providing meaningful error messages and improving app stability. When things go wrong in an application, it's not always obvious at first. Silent failures can disrupt performance without you even noticing. That's where logging comes in. In this video, we will describe logging best practices in ASP.NET Core. Logging is the process of recording messages or data about an application or system's behavior. Logging helps you monitor an application's health and catch issues before they become bigger problems. Logging allows the system to track user interactions and the outputs of various processes, providing valuable insights for multiple use cases. For instance, it helps developers diagnose issues like incorrect results by capturing errors or missing data in real time. Logging also aids in performance monitoring, where logs can identify inefficiencies by tracking system metrics over time. Logging is essential for security auditing as well. It can be used to record activities and system changes, helping detect suspicious behavior or unauthorized access. In error tracking, logs capture detailed information about crashes or failures, making it easier to pinpoint the root cause. Finally, logs can track user behavior patterns, allowing businesses to enhance user experiences by understanding preferences and actions. Understanding scenarios where logging can be used effectively is crucial. Using best practices during logging is also important. Let's explore some common logging best practices. First, consider the level of detail. Logging too much information can make it harder to find details. By setting up log level filters, you can decide what gets logged. In production, you may want to log only error and warning messages. In development, you could include information in debug logs for more insights. Once you've set up logging levels, it's time to ensure logs are formatted consistently. Consistent formatting makes logs easier to read and analyze. It ensures you can quickly find the information you need when an issue arises. A well-formatted log might include timestamps, log levels, and key details. For example, this text log records an error that occurred on September 25th, 2024 at 10 o'clock for user ID 1234. It indicates that a payment failed due to a payment timeout exception. Finally, you should consider log scopes. Log scopes are a way to organize and group related logs and allows you to include extra information. This helps you track related events, especially when dealing with complex processes like user requests or multiple operations at once. This makes it easier to examine the bigger picture and debug issues faster. For example, when handling an order, you can use a scope to track everything related to that order, like order ID, the user ID of the order, and actions performed and any errors encountered. With these best practices in mind, let's examine how to configure logging in your ASP.NET Core project. This often will be done by using built-in logging providers or third-party logging frameworks. Follow these steps to set up logging to create and store logs in a .NET application. First, decide where to send the logs, such as the console, files, or an external service like databases or cloud platforms. Second, set the minimum log levels, such as information, warning, and error, and they must be determined to define how much detail is logged. This includes both application-specific logs and logs from external libraries. Logging can be configured in the appsettings.json file where you define providers and log levels. This declarative approach allows you to easily adjust settings without changing the code. Alternatively, logging can be configured programmatically in program.cs, where you specify logging providers and log levels directly in the code using the logging builder. In both cases, you can control log output locations and levels and customize environment-specific behavior. If you're using a third-party framework like Serolog or nlog, install the necessary NuGet packages. Then configure the framework in the appsettings.json or the respective config files. Define output targets, log formatting, and rolling log files as needed. After you configure logging, you can start creating and saving logs. Logs are created by calling methods like log information, log warning, and log error. These methods generate log entries automatically saved to the specific output like the console or a file. Depending on your configuration, logs may be written to files and databases or sent to cloud services. Finally, the logging system will be tested by running the application and verifying that the logs are generated in the expected locations. Regularly monitor the logs to ensure that critical information is captured and fine-tune log levels or destinations as needed to avoid excessive logging or missing important details. In this video, you learned how logging helps monitor and maintain an ASP.NET Core app by tracking errors, performance, and security. With these practices, you're ready to monitor and optimize your app effectively. In this lab, we're going to create a basic web API project, and we're going to do some basic and global error handling. We'll use the basic ASP.NET logging to show how those errors are handled, and then we'll also use some third-party logging libraries that will make for robust logging. In step one, we basically set up the project. It's just going to be a basic web API project. We're going to call it error handling project using the .NET new web API command. and that will create a templated application. In step 2, we're going to add basic error handling in one of our endpoints in our application. And to do that, I've created a controllers folder at the root and an error handling controller.cs file, which holds the route that we're going to use for our application. You can see we have the route set up there. We have API /, and then in brackets we have controller, which means we can pass in any controller name that we want to for that route. But we have to include API /, and then we can pass in the controller name. One of the routes here is HTTP GET, which is a part of the CRUD operations. This is the read operation of CRUD. And we're going to get a route called division. So we'll do API /division for this. And then we have a method called getDivisionResults. And in our call, we're going to pass in a numerator and a denominator as a part of that method call on this route. And we're going to try to do some mathematics on the numerator and the denominator. Now notice here we do have an error handler in place. We have a try-catch block. The try block is going to try to divide the denominator by the numerator and pass back the result. If there's an issue, if we run into any issues with that division operation, the code will fall into the catch block. We'll write out to the console that division by 0 is not allowed, and then we'll return a bad request response so that the calling application knows that the response wasn't valid. That's all that this CS file contains for this specific route. It's a very simple operation to try to do some division on variables we pass into it. Now in step 3, we're going to implement global error handling. So the error handling that we did in the controller is very specific to this division operation. But we can also implement global error handling, and we're going to go back to our program.cs file for that. After we've implemented our builder, so we've got our web application create builder, which is all the infrastructure that we need for our application. So then we come down to builder services add controllers. This allows us to use the error handling controller.cs file that we added there. And then we'll go down to our app builder. We'll come back to that code and the other code in a moment, but we just need our builder code right now. So we're going to use app.use as our middleware. And in this, we're going to just have a global error handler. So this will run every time the application runs, and it will try to run any other operation that needs to be run. And if it doesn't run properly, it will fall into the catch block. So in the division route, we had a very specific error handler for that specific operation. Here, if we build other operations that don't have error handling, this will catch those errors and return a status code of 500, a message that says global exception caught, and then a response out to the user that something went wrong. And then we just, at the end, we tell our app to use routing and to map all the controllers that we've set up and then to launch the app. So that's global error handling as opposed to the specific error handling we did for the division operation. Now we want to implement logging. So up here you can see that I've added a couple of logging commands, builder.logging clear providers and builder.logging add console. These two methods create our logging infrastructure using basic ASP.NET logging. So by doing this, we're able to log to the console, and we can provide messages within a web browser right to a developer or to a person who wants to debug and see what's going on. We can log right to the console using our basic ASP.NET infrastructure. Step 5 is integrating third-party logging with Serolog. So Serolog is a very specific library that we use for logging. You can see I put at the top here using Serolog, which is the using statement that we need to let our application know we want to use that library. Prior to that, we've added the library to our application using .NET add package. We can verify that those packages are installed by going into our csproj file. And you can see we have a package reference includes serolog.asp.NET Core, serolog.syncs.console, and serolog.syncs.file. So these three include statements means we installed 3 different packages that allows us to use Serialog to log to the console, allows us to use Serialog to log to a file, and then just the basic infrastructure to use Serialog with ASP.NET Core. So now that we have that implemented, we can make calls to the logger using Serialog. So we've added our using statement at the top. And then we can use the Serialog library to create some new logs as we need them. So you can see the line log.logger equals new logger configuration. That's a Serialog logger configuration setup. And then in that configuration, we're telling Serialog we want to write to both the console and to a file, logs/myapp.txt, and how often we want to be able to write those logs out. And then the .create logger just creates that logger. So everything that happens in our API now, we're able to log to the console and to the file at a rolling interval of a day. And then we tell the builder.host to use the Serialog library to create logs. So now we're using a third-party option for our logging. We can use both ASP.NET's internal logging system and Serialog for more robust logging. Understanding ASP.NET Core equips you to build scalable, reliable web APIs. These skills are essential for developing and maintaining applications that meet modern industry demands. We began with an overview of ASP.NET Core, focusing on its main features and advantages for web API development. We examined why it has become popular for building modern backend systems. Next, we covered the steps for building a basic web API, providing clear practical guidance to help you gain hands-on experience with ASP.NET Core development. After that, we examined routing and attribute routing, exploring how to organize and manage API endpoints efficiently for seamless navigation. Then we explored dependency injection, a crucial practice in ASP.NET Core that simplifies application architecture and improves maintainability. Finally, we reviewed key strategies for handling errors and implementing logging. This ensures that your APIs maintain reliability and are straightforward to troubleshoot. Mastering ASP.NET Core is key to building efficient and scalable web APIs. Understanding routing, dependency injection, and error handling ensures you create robust, maintainable applications, essential for modern development. Logging providers help us capture and organize crucial information about how an application is running. By using different logging providers, we can tailor logs to the environment, ensuring we can effectively monitor, diagnose, and maintain the health of our application. In this video, we will describe ASP.NET Core built-in logging providers and third-party frameworks. ASP.NET Core provides several built-in logging providers, like Console, Debug, and Event Log, which allows you to capture logs easily without needing any extra setup. Each provider serves a specific purpose depending on your working environment. Let's explore these built-in logging providers, starting with Console. The Console provider can be specifically useful during development. It sends log messages directly to the console window, giving you immediate feedback on your application's behavior. This is helpful for quick debugging, as you can notice errors or warnings as soon as they happen without needing to research files or complex log systems. Similarly, the debug provider is great for development environments. The debug provider sends log messages to any active debugging output, allowing you to monitor logs while debugging your application. This is especially useful when stepping through code, as you can easily match log output with code execution to spot issues. You can also filter logs by severity, like error, warning, or information, to focus on the most relevant details. When logging requirements change during production, the event log provider becomes the most useful, as it writes logs directly to the window event log. This makes logs easier to manage and monitor in a structured and secure way. System administrators can then use built-in tools to search, filter, and analyze logs, helping to maintain system stability, monitor security, and troubleshoot issues in the live environment. However, the event log provider is only available for Windows. For cross-platform applications, you should opt for more robust logging frameworks for production environments. While built-in logging providers are helpful, sometimes your app needs more advanced features like structured data, persistent logging, or cloud support. This is where third-party frameworks like Serialog come in. Third-party frameworks like Serolog and Nlog offer more advanced features like structured logging and cloud integration. Serolog is a powerful logging library that excels when structured data, scalability, and integration with modern log management platforms are key. It's an excellent choice for applications that require detailed, context-rich logging to improve debugging, performance monitoring, and system analysis. For example, you can log information like user IDs and transaction times in a structured format, which makes it easier to search and analyze later. Another third-party framework is called Nlog. Nlog is a versatile and efficient logging library suited for a wide range of applications. Its simplicity in setup, high performance, and flexible target options make it a strong choice for developers wanting a reliable logging solution. Additionally, it allows you to take full advantage of centralized log management, and data analysis enables faster troubleshooting and more effective application monitoring. Unlike Serolog, which excels in structured logging for scenarios requiring detailed, property-based log queries, Nlog focuses on performance and ease of configuration, making it ideal for high-throughput environments where logging, speed, and flexibility are key. For instance, with Nlog, you can log error details such as error codes and stack traces in a structured format. This structured data can then be easily searched and analyzed in platforms like Elasticsearch or Logstash, allowing you to quickly identify recurring issues and gain insights into application stability over time. Logging providers are essential tools that enable us to monitor and maintain our applications effectively. Whether using built-in providers during development or leveraging advanced frameworks in production, having a solid logging strategy is crucial for maintaining the health and stability of your application, ensuring it runs smoothly and efficiently. Welcome to serialization and deserialization. This module introduces you to the critical processes of converting objects into formats for storage or transmission and restoring them in .NET. You'll learn how to apply these techniques effectively, ensuring optimal performance and security in your backend applications. We will begin by defining serialization and discussing its importance in .NET, emphasizing how it facilitates data storage and transmission. Next, we will explore how to serialize objects in .NET, providing practical steps to convert objects into a storable or transferable format. Then we will examine the deserialization process and learn how to restore serialized objects to their original form in .NET. After that, we'll consider performance factors, identifying key aspects that impact the efficiency of serialization and deserialization. Finally, we will cover security best practices, ensuring your serialization processes are safe and protected against vulnerabilities. By the end of this module, you'll have the skills to serialize and deserialize objects efficiently in .NET, ensuring high performance and strong security in your applications. Let's begin. Serialization is a fundamental concept in software development that allows objects to be converted into a format that can be easily stored or transmitted. In this video, we will define serialization and its importance in .NET. Let's start by defining what serialization is. Serialization is the process of converting an object into a format that can be easily stored or transmitted. It's important in .NET for the following reasons. 1, it makes saving and retrieving object data easier. 2, it enhances communication by allowing objects to be easily shared between different parts of a distributed system. 3, .NET supports various serialization formats like binary, XML, and JSON. Serialization serves several purposes. 1 is data storage. Serialization allows you to save complex objects into formats easily retrieved and used like files or databases. Second, serialization allows you to transmit and reconstruct objects over networks like between web servers when sending data. Third, serialization maintains the state of an object across different sessions or application runs. Fourth, serialization also facilitates communication between systems using different technologies. There are several serialization formats commonly used in .NET, and each is suited to different scenarios depending on factors like data size, readability, interoperability, and performance. Here's a guide on when to use each of these common serialization formats, starting with binary serialization. Binary serialization converts objects into a compact binary format, making it efficient for storage and transmission. Though it's not human readable, this format is ideal when you need high performance and minimal data size, especially in scenarios where human readability is optional. Next, let's explore XML serialization, which offers a more human readable format. XML serialization converts objects into a human readable XML format. Due to its strong structure and support for attributes and mixed content, XML is widely used for data interchange, especially in enterprise environments. XML serialization is ideal for scenarios like legacy systems and complex data structures, where a strict document-based format, even if it's a bit verbose, is essential. With this understanding of XML serialization, it's time to consider a more streamlined and lightweight format. Let's now explore how JSON efficiently works with data across different platforms. JSON serialization converts objects into a lightweight, human-readable format that is ideal for modern web applications, and it's widely supported across platforms. Use it for web APIs, cross-platform data exchange, and scenarios where readability and efficiency are key. It's easy to work with in most modern environments. In this video, you learned about serialization, its significance in software development, and its practical application in .NET. We explored how serialization converts objects into formats like JSON, XML, and binary, making them easy to store, transmit, and share between different systems. This helps you understand when and why to use each one in your projects. Serialization in software development is like saving documents as PDFs. You convert complex data into a format that can be easily stored, shared, and retrieved. This process ensures smooth data exchange. In this video, we will identify use cases for serialization in .NET. Before we discuss the specific use cases, let's briefly recap the concept of serialization. A solid understanding will equip you to apply it effectively in real-world scenarios. Serialization is the process of converting an object into a format that can be easily stored or transmitted. Now let's explore the specific cases where serialization is highly beneficial, starting with persistent data to files. Serialization enables objects to be saved to files in formats such as JSON, XML, or binary for later retrieval. For instance, in a game you can store and retrieve application configuration settings or a player's progress in a structured format like JSON or XML. This makes it easier to load and apply them the next time the game runs so the player can return to where they left off. Saving data as JSON or XML is great for human readability and compatibility, making sharing, maintaining, and debugging your data easier. Binary formats are better for internal systems and security, though mistakes when working with them can lead to potential risks. In our next use case of serialization, we'll discuss sending objects over a network. Serialization is crucial in network communications, particularly with web APIs. It involves converting complex objects into a format easily transmitted over the network. Once the serialized data reaches its destination, it can be deserialized back into an object, enabling different parts of a system or even different systems to communicate effectively. For example, when you place an order on an e-commerce website, your order details are serialized into JSON format and sent to the backend server. Once the serialized data reaches its destination, it can be deserialized back into an object, allowing the server to process your order. Our last use case involves caching objects. Serialization is useful for storing frequently accessed data in memory, a process known as caching. Caching is a technique for storing frequently accessed data in memory. This allows for faster retrieval and reduces the need to perform costly operations like database queries. This operation allows for storing objects in memory or disk, saving time and system resources. An example of caching at work would be a reporting tool that generates reports based on complex and resource-intensive database inquiries. You can serialize and cache portions of the report that don't change frequently to enhance performance and avoid repeatedly running the same expensive queries. This approach allows the tool to quickly retrieve and display cached data, significantly speeding up report generation for users who frequently request the same reports. In this video, you learn some common use cases for serialization in .NET. Understanding and utilizing serialization enables efficient storage, transmission, and management of data across various scenarios in software development. In modern software development, the ability to convert complex objects into a format that can be easily stored, transmitted, or reconstructed is crucial. This process, known as serialization, is a key feature of .NET that enables developers to maintain object integrity across different environments or sessions. In this video, we will explain how to serialize objects in .NET. Let's start by understanding what serialization is and why it's important. Serialization is the process of converting an object into a format that can be easily stored or transmitted. Now let's explore the different techniques, starting with a common one, JSON serialization. JSON serialization converts an object into JSON, a lightweight, human-readable format commonly used in web development for fast data exchange between the client and the server. It's perfect for scenarios like web APIs, where JSON simplicity and speed make it ideal for transmitting data quickly without overloading the system. For example, in a single-page application, which is called a SPA for short, JSON allows dynamic updates without requiring the entire page to reload. This efficiency makes it the go-to choice for modern web applications. Next, XML serialization transforms an object into XML, a text-based, human-readable format. It's often chosen when interoperability between systems is essential. For instance, when working with older systems with more rigid structures for data exchange, XML is often preferred because it's standardized, and it's easy to read and compatible with many platforms. In these cases, XML provides the structure and consistency to exchange data smoothly between disparate systems. Finally, binary serialization converts an object into binary format, saving everything about the object, including hidden information that isn't usually visible or accessible, like internal details that control how the object works. This technique excels in performance-critical applications where human readability isn't needed. For example, when you're saving a game state in a complex video game or caching data for a high-performance application, binary serialization provides the necessary speed and efficiency. It's ideal for managing large, complex data structures where size and performance are more important than readability. Now that we've examined the three key techniques, let's consider a real-world scenario to determine which method works best. Let's say you're building a web-based application that transmits data between a client and a server. The data must be lightweight, human-readable, and easily parsed by JavaScript in a web browser. In this case, JSON serialization would be the best choice. JSON simplicity and speed make it ideal for web-based applications. By comparison, binary serialization isn't suitable here because the data doesn't need to be optimized for high performance. XML serialization would add unnecessary complexity due to its lengthy structure, making the data transmission slower and bulkier. In this video, you learned how to serialize objects in .NET. Serialization techniques like binary, XML, and JSON are key to managing data efficiently across different applications. Understanding when to use each one ensures your .NET applications perform optimally for their intended purpose.
You've learned a lot about serialization, but it's time to explore some serialization in action. In this video, we'll implement serialization techniques in .NET. Let's begin by discussing our person class here. So a person, the way we've defined it, has a required username string and a user age int. You'll also see up here that we create a single sample person. In this case, it is a username of Alice and a user age of 30. Now, the whole goal of serialization is to take an object like this, transmit it over a network, and then have our client be able to access that data. So that means we need to take the data from the way that it is understood in memory by our computer, send it over the network in a different format, then they need to be able to take it on the client side and turn it back into something that they can use in computer memory. Now I'm going to walk you through a series of examples, sort of starting from the most manual way to the most automatic way of performing serialization. And that's largely to help you build up these concepts and understand what's happening under the hood. So you can see here that we have one route right now. It's called the root route. It just returns I am root. And if we go ahead and add in another root here, we will call this map get, and then it needs a name, so we'll call this manual JSON. And then it needs a second argument, and that will be a function. And now we have a perfectly valid route called manual JSON. All right, so the first thing we need to do here is serialize our object explicitly. So we're going to call this JSON string, and we will go ahead and use JSON serializer. Lots of JSON options there, and we will call the serialize method on that, and we will pass in our sample person. And so now this will turn this into a string of data that we can send over the network. The next thing we're going to do is we're going to return. We're going to use typed results here. You could just use results, but I prefer the typed results. It is recommended. And then we can just set the text value of that to our JSON string. And one last thing we need to do here is we need to add what the type of this data is so that the client understands that it's not just string, that it's actually going to be unpacked to something else. So we'll call application/JSON. Then we go ahead and add our semicolon. And now this is how you would just basically serialize data. You're going to call this JSON serializer, the serialize method on that. You're going to serialize this. So this is taking this from the way that is understood by your computer in its computer memory into something that can be transmitted over the network. You're again going to send that as text, and you're going to make sure to set that as application.json. So this is the first way to manually do this. Let's go ahead and copy and paste that. And we are going to call this next one, how about we call it custom serializer? And so now let's get rid of a bunch of this. So here, what I want to show is how to set some custom serializer settings. So right here, it performed the serialization for us, but it's using a bunch of defaults. We don't really know what's happening. So let's go ahead and create some options, and we will be new JSON serializer options. And now this takes in a bunch of different keys. So you can set different values here, but the ones I'm going to play around with for now, let's change the property naming policy. So this will change the way that your properties are named. So I'm going to say JSON naming policy dot snake case lower. And so this will actually transfer our naming conventions from Pascal case like they are here, where it's a capital in the first letter and a capital in every word following that. The first letter of every word is capitalized, including the first. So snake case is commonly used in languages like Python. So in this, a variable, all the values would be lowercase, separated by underscores. So let's say this API is meant to be consumed by Python services. So this would be the naming convention they expect. So this is something you might want to do when you're changing your policies, is think about how is this going to be consumed. So now I have these options. What can I do with those? Let's go ahead and custom serialize. So let's say var custom JSON string, and this will be serializing, not deserializing, using our new serializer options there. So we're going to do like we did before, where we have JSON serializer dot serialize, and then we can pass in that sample person again. And this time we're going to pass in a second argument, which is our options. So now we are using custom serializer options in our example. And so again, we can return typed results dot text, and we will pass in our custom JSON string. Yep, there it goes. IntelliSense catching up with me. And again, we want to make sure that our client knows what that is. So it will be our application/JSON. Finally, our semicolon. So this is how you would do the same thing as we did before with the addition of custom serializer options. So now let's try another method here, and we'll do app.map.get, and this time, what do I want to call this? I will just call this JSON. So here's another way of sending this data. So rather than using a custom serializer, we can use a special method on typed results itself, and that will send the data without having to do all of these sort of fuzzy steps if we just want to use the defaults that .NET hands us. So what we're going to do for this example, I am going to return typed results dot JSON, and then I'm going to pass sample person. And that's it. I just have to type this one line of code. Now what this is doing is this is manually serializing this as JSON. It knows we want to send the data as JSON, and it's setting the application/JSON header here, just like we were before, so our client knows. But we don't have to do all of these steps up here. We can just send it like this. Now, why would you do the previous steps? Well, you do it the previous way if you need to change those things like your property naming policy, or maybe you need to change the way it's serialized. If you want to use the defaults, you just have normal JSON that you want to send along, you can use this typed results.json way of doing things. It's really handy, but it gets even better. Let's go ahead and create one more route. I'll go ahead and copy this down, and this time we're going to call this auto. And now things are going to get real nutty here. I'm going to do return sample person. That's it. All you got to do. So by default, .NET serializes to JSON. It basically does this under the hood if you send this. And this was doing what these things are doing. So you can create a sample person object and just send it. In fact, any object you want to send over the network, you can just put it into a return statement and send it along. When you're creating routes, you can send strings, you can send objects, and you can send typed results and results. So you have a few different options here. And this is the one you're going to want to use most of the time here because it's just so stinking simple. There's not much to screw up. You don't have to write a lot of code. It's not a lot to read. It's not a lot to maintain. And it does what you normally want to do, and that is serialize the data you're sending to JSON. Now that might raise a question. What happens when you don't want to serialize to JSON and you want to serialize to something else? My first recommendation is use JSON whenever possible. It has become the sort of de facto data exchange format of the web. There are times when you don't want to use it. There are some limitations. I'm not going to go into that here. So I will talk briefly about how to send XML, and you will understand at the end of this why sending XML is a real pain. So let's create another route down here. And this time I'm going to call this XML. Now sending XML is a long one. So let's say here, so first thing I need is an XML serializer. So I have to create a serializer. I don't just have a JSON serializer available to me. So I have to create a new XML serializer. And then I need to make sure I import that. So I will click here and that will add our using statement up here where we pull in system.xml.serialization. So now I need a new serializer. And the serializer needs a particular type. So that's going to be the type of person because this needs to know what type it is going to serialize to and from, unlike our JSON serializer, which just figured that out on its own. The next thing I'm going to need to do here is var string writer. So we need to basically create a place where we can hold a string. Say var string writer equals new string writer. Next up, we will XML serializer dot serialize, and we will pass in that string writer, and we will pass in the sample person. And I have done something wrong here because I want to serialize, not serializer. And so now calling this will use our serializer and it will serialize and it will take in the person and it will write it to this string writer. So the string writer is sort of the thing that will hold that new serialized XML. Then the next thing we want to do is var XML output, we will call this. And so then I will say equals string writer dot to string. And so this will actually turn it to a string that we now have serialized. And now we will return, let's say typed results dot text XML output, which is that value we just created. And again, this time we will want to say it is application/XML instead of JSON. Wow, that's a lot of steps. That's a lot to understand. So let's look a little bit at what the difference is here. So if you compare to what we did before we just pulled a JSON serializer out, we serialized our data, and then we returned it using a method similar to this, except we used application.json instead of application.xml. So in this case, we have to sort of go to these complicated steps. We have to create an XML serializer explicitly, whereas up here, there's just a JSON serializer, and we can call that serialize method. And so we also have to create a string writer. Again, that is the thing that will write the string from this serializer. Then we actually write the string down here. Then we take the output. So that is what is happening here. And these are all different ways to serialize data. Again, look at the difference between this and this. Unless you have a very explicit reason to use XML, so a very special reason, use JSON. It's a really great data exchange format. The final thing I want to do is show you some of the requests that I put together in request.http. So these are requests to get the data out of these different routes. I am going to go ahead and .NET watch run, and that will start our server. And remember, you can always Control R to restart your server, and you're going to want to do that any time that you make significant changes. So now our server looks like it is running, and there we go. I am root. So I'm going to go ahead and go away from the browser real quick and back to request.http because it's going to be a little nicer to see what we want here. Now the first thing I'm going to notice is I have the wrong port here, so always check your port. Really handy key command is Control D. This multi-selects a word. So now watch. I have all of these selected at once, and I can type in 5227. That shortcut blew my mind the first time I saw it. So handy. Let's go ahead and save here, and then I will send this first request. And here you can see we have our response back. Username, user age, these look like the same way we would expect our naming convention to be in Pascal case. Now this next one, we will use JSON, and we should see the same thing, except now we see underscore username and underscore user age. And now remember, our JSON up here use these type results. So the type results by convention are going to convert this down into camel case. Now if we use our custom serializer, which I have right here, you'll see these actually come out as snake case, and that's what we defined here in our custom serializer. Finally, there was one more in here. We can try to get this as XML. And if we send that, you'll see now this is not JSON, it is indeed XML, like we would expect. The final thing I want to show you is sometimes it is really useful to not set serializers at the route level. Sometimes it's nice to set global policies. So to do that, we need to go up and intervene in our builder. Again, the builder up top is where we change some of the settings for our app before it is created. So I'm going to add in a couple of lines here, and I am going to say builder.services. Let's see, this is configure HTTP JSON options. And this will take a function that will take in those options. And then let's close that out. So now we have a working function. And now what we're going to do in here is we're going to say options.serializer options.property naming policy equals JSON naming policy dot kebab case upper. Now I know of no reason on the planet you would ever want to use kebab case upper. It's a really weird one. So all of the words are going to be uppercase, and then they will have a hyphen between different words. The reason I'm using this is because it is very easy to see. Normally, you would want to change this to something like Pascal case or snake case or camel case. They're much more common conventions. But I'm sure there are reasons where you would want to use kebab case upper. Now, I have made some changes here that are significant enough. I'm going to go ahead and restart my server to make sure that all propagated. And now I want to show a couple of things. Remember, the manual JSON, we used a serializer, we returned the data, custom serializer, we actually created custom serializer options, and over here we use typeresults.json without creating a new serializer to sort of let it use its default settings to send that data. So let's come over here and let's send some requests again and see what happens. So here we have Pascal case. This is what we saw before. Here on the JSON route, I send it. Here is that kebab case. So we see kebab case overriding our JSON. So this time, this was using the global default. So this has overwritten this route's setting. But now if we go to our custom serializer and run this, you'll see it's still snake case. And now that might seem strange to you, but the reason is we have set global settings over here, but down here we're using a new custom serializer with new custom options. So it completely overrides those global settings. And we can check here to see what happens when we do manual JSON. And again, that is Pascal case, because again, we're not using that global because we are using a custom serializer. We're just not setting custom options. You now know pretty much everything you'd need to know about serialization in JSON. And perhaps the most important takeaway from this is do this when you can. Just return an object. Let .NET give you sensible standards and know that you have these other options you can leverage when you need this specific level of control over your API. The great thing about modern.NET is you don't need to think about serialization at all most of the time, and your route handlers will just take care of it for you.
In this lab, we're creating a very simple console application that will allow us to practice serializing data to 3 different types of formats. In step 1, we're setting up the basic project. This is just using the .NET new console to create a basic console application called serialization demo. I've already created that and added some code here, but the original project has templated code that if you ran it, it would say hello world. In step 3 of step 1, we're adding a class to our console application. Inside the project class, we create a public class called person that has 2 properties, username and user age. Username is a string variable and user age is an int variable, and we're going to just use this object to hold data when we do our serialization operation. So we'll create the class, instance the class, and then we'll add data to that class and then serialize it using some different methods. In step 2, we're going to start by implementing binary serialization. This will allow us to write out to a binary file, a DAT file. In order to use binary serialization, we have to declare at the top of our file using system.io. This allows us to read and write from files on the file system. So we create that, we reference that library that allows us to do that work. Then in static void main, our main method for this application, we're going to create an instance of a person class called sample person, and we're going to assign username. The username is going to be Alice, and the user age is 30. That's that first line of our main method. Now we're going to use the system.io library. So we're going to create a new file stream object called fs, and we're going to call that file person.dat. So when we deserialize our sample person object to a file, we're going to write it out to this binary file called person.dat. The mode that we're going to be in for this statement is the create mode. Then we create a new instance of binary writer, which allows us to write binary files. And we're going to pass in our file stream object. So the file stream object is just the raw data that we want to be able to write out to. And the binary writer is actually the function that writes to that person.dat object. Now that we have the binary writer object that we've created using new binary writer, we're going to write out our sample person data. So we're going to write out sample person.username and sample person.userage, which we've defined in the first line of this code. Once the data has been written out, we're going to print to the console that the serialization is complete. That is all that's needed to write out to a binary file from an object in C#. In step 3, we're going to implement XML serialization, which allows us to write out to a text file, an XML file. At the top of our application, we have to reference the system.xml.serialization library, where we're telling our application to use that library. We've done that at the top of the file. And then when we come down here below our binary serialization, I've added another type of serialization using the XML serializer called XML serializer, using the XML serializer type. And we're going to create a new instance of that using the person class. Since we've already defined our sample person object above, it's already in the person class, we've defined sample person here. We can simply call XML serializer.serialize using the writer similar to what we've created above. We're going to call this object person.xml, and we're going to pass in our sample person data. And then the XML serializer.serializer takes care of the rest for us. It will take that object, convert it to XML, and then write it to the person.xml file. And then finally, in step 4, we're going to write out to a JSON file. So here we're going to reference at the top of our file system.text.json. This is the internal .NET version of a JSON serializer. We're going to just use this version for this application. And then similar to how we did the other serializations, we create a reference to the JSON serializer. So you'll see the first line here is string JSON data equals JSON serializer.serialize. And we're going to pass in our sample person data. So similar to the other serializers, this method will tear apart the object that we created and put it into JSON format. And then we use file.writeAllText, which is a part of the file library that's available to us. We write out all the text to a file called person.json, passing in our JSON string as the data. And then we just simply write to the console that the JSON serialization is complete. Now, for each of these, we can see the result of when we run this program, what the result looks like. So the person.xml is an XML file, and you can see username, Alice, user age 30, and it's formatted as an XML file. The same with JSON, person.json is formatted as a JSON file, and it has all the same data, username and user age. Person.dat we're not going to be able to look at because it's binary. So the Visual Studio Code tells us that it's not a file that's readable by the editor. So we know that that's a binary file. And that's how you serialize to different object types using the serialization functions in .NET. When you use an app, it often remembers things like your preferences or where you left off. This happens because the app can save and later reuse your data through a process called deserialization. It ensures that the saved data can be restored and used by the app. In this video, we will describe the process of deserializing objects in .NET. Recall that serialization is the process of converting an object into a format that can easily be stored and transmitted. Deserialization is the reverse process, converting serialized data back into objects. Deserialization allows an application to take saved or transmitted data and convert it into something usable. When an app saves data, it converts it into a format that can be stored or sent. When the app is reopened, deserialization converts that data to its original form, such as your profile or app settings. This is how apps reuse saved data. Now let's explore how deserialization works in the .NET framework and why it's important for working with saved or external data. In .NET, deserialization is essential for restoring objects saved earlier, like when a user logs back into an app and their profile is restored. It also helps convert external data like JSON from a web API, a service that allows apps to share information, into objects the application can work with. Deserialization converts data formats into something the app can use, like turning JSON data into a user profile. JSON, which stands for JavaScript Object Notation, is a simple text format that apps use to exchange data. JSON is used to exchange simple data like user details because it's quick and easy for apps to read. XML is another data format, and it's used for more detailed information like app settings because it can work with more structured data. XML, which stands for Extensible Markup Language, uses tags to organize more complex data like app settings. Lastly, binary deserialization is commonly used when efficiency is crucial, like when working with large datasets or complex objects that require fast performance. Deserialization is a constant process in real-world apps. For example, consider a web application that saves a user's preferences before closing. These preferences are serialized into a format like JSON, XML, or binary data, and then saved. When the user reopens the app, deserialization converts the saved data back into settings so that the app can be used again. This process reverses serialization, making stored data usable once more. In this video, you learned about the process of deserializing objects in .NET and why it's important for restoring data in applications. Whether the data is saved in JSON, XML, binary, or another format, deserialization ensures that data can be stored and used again.
Let's explore the process of deserializing data into objects step by step. The focus here is how incoming data like JSON or form data is automatically or manually converted into C# objects that we can use in our code. In this video, we will implement deserialization techniques in .NET. This API will be meant to deserialize this person object. And unlike the previous time we looked at a person object, this has a required string username and an optional int user age. So one of them is required and one of them is optional. And now you'll notice here we're not creating a new user, and then that is again because we are deserializing, not serializing. When we serialize, we are sending data. When we deserialize, it's what happens when we are sent data. We have a get method, but when we deserialize data, we will do that when we receive data on, say, a post method. So let's go ahead and show you the simplest way to deserialize data in .NET. So I am going to create a new route, and I will do app.map post, and we will make this route auto. So much like we saw when we were serializing data, there is a really simple, straightforward way to have your data deserialized using common sense defaults, and you can move on to more complicated methods if you want to. So all we have to do is this post route will assume it takes in an object of type person, and we will call that person from client, and then we will return results.ok with person from client. Now this person from client is the payload that we are being sent. And because we are passing it as the argument here, .NET automatically knows that this will expect the body of the data that we receive here to be a person. And it will try to deserialize it as such. And we'll see a little bit later what happens if that does not meet that contract. And we could do anything with that. I could do a console.writeLine, and I could say person from client. I could do whatever I want with that. I could say person.client, person from client dot username equals Tyler. It's just an object at this point. It has been deserialized. It has been sent across the network, and .NET has turned it into something that we can now use. There's nothing special about it here. Again, this is just an object now. So that is how you perform deserialization at its absolute most basic. And again, I would use typed results here because it's just better practice than using results. So this is the most simple way to deserialize. So let's move to the next sort of level of complexity if we want to more explicitly move away from some of the default behaviors. So let's go ahead and map post here again, and we're going to call this one just JSON. And now instead of taking in a person, we are going to take in, let's make this a sync, and that will take in an HTTP context. And we will call that context. Then we will go ahead and open up our function there to create our request delegate. Now the first thing we're going to want to do is pull the person out of our context. So we'll say person equals context dot request dot read from JSON async. And now this is a generic, so we'll expect a person, and we can call that method, and this will read that person from the request. So this will go ahead and read in the payload body of the request sent from the client and pull the body off, assuming it is a person. So it is deserializing it as a person. And then again, we can go ahead and return to typed results dot JSON, and this will take in that person. So now these two are doing almost exactly the same thing, except now we are explicitly reading this from the request rather than letting it just happen on its own. And notice here that we're using JSON. So if we tried to use these routes, because they are being handled as JSON, explicitly calling async. I'm getting a warning here. Let's pull that out, see if that fixes my error. Warning, not error actually. Okay, and that seemed to get it. I was using an async when I did not need to. But now that I look at this, I should be awaiting this because that is happening async, and it is now smart enough to change back. Excellent. Okay, so now we are doing this async await, and we have our requests here. So let's go look at what we can do with our JSON route. I've created a couple of requests here, so we can send this JSON object to it. That works great. Now let's go over and see what some of our requests can do with this JSON route. Now this is the same as our auto route, but I've created some requests here that we can run against JSON. So I want to check some things like, let's just send a basic JSON object, and boom, that works. But what happens if we send XML? Does not work. Now what happens if we change the content type to application.json, but still send XML? Also doesn't work. It thinks it's getting JSON. Our deserializer thinks it's getting JSON, but it is indeed getting XML. So we can try a couple other things here, like what happens if we try to send a person, but it has no user age. That totally works because user age is optional if we look over at our class. Totally fine. What happens if we send a missing name, however? Now that's going to send an error, and why is that? We could leave out user age, but we can't leave out username, and that is because username is required, but user age is not. User age is optional. And then we can also test what if we do an extra field. So this one has this extra field down here. Doesn't matter, it will ignore it. We can also try what happens if we send an age of the wrong type. Now this will throw an error, and that's because our deserializer is expecting an object of the type of this person, and it expects that user age to be an integer, not a string. In this case, we've made it buffalo. Does not work. So now you can see using these serializers, it's taking care of a lot of the edge cases that we'd run into just by defining a class and telling it we expect to deserialize as that. Using either of these two methods we've just shown, we're getting a lot of functionality out of the gates. One of the most important reasons that you would pull out the read from JSON async here rather than just doing things the automatic way is to actually create some custom options. So let's go ahead and create a new route, and we'll call this one custom options. And this time we are going to, like we did for our serializer, we are going to create some custom options. So I'll say var options equals new JSON. Missed the new there, equals new JSON serializer options. Now notice this isn't deserializer options. Most of the time when you are working with serializers and deserializers, you're just working with serializers. They're both handled under the same namespaces and methods typically in .NET. And so now let's give it a couple of options here. So I want to say unmapped member handling equals JSON.unmapped member handling dot disallow. And now this is throwing a bit of a fit because I need to add the using statement because that comes in with system.text.json.serialization. And now this is complete. So what this is going to do is it's going to say if I try to hand a member that does not exist on the class, like I was doing earlier, to disallow that. So that's a really good example. If you don't want users sending objects with extra fields for whatever reason, you can use an option like this. And now we're going to do the same thing like we did before, where we're read from JSON async, except this time we're going to pass in those options. So it's the exact same as previously, except we are now creating options, passing them in, and now we have explicitly sent along some options to our deserializer. And we can go back to our request, and we should have a request down here for custom options. Now we're going to try this with this extra field after I reset my server just in case to make sure everything loaded. Then I will hit the send request button. And you should see that is now rejecting it. So before, our JSON route accepts this, and our new custom options route does not. And they are the same in functionality, except one has this new unmapped member handling option set to disallow. So this is a really good example of where you would want to use custom options. So now we've shown a lot of JSON serialization once again because JSON is the dominant data exchange format for working with HTTP these days. It just is. And like working with serialization, XML is very complicated. So let's go ahead and run through that example. I can say app.map_post, and we will call this route XML. And again, I will create a function, and we are going to need to take in the HTTP context once again. So we will create a new argument of type HTTP context, and we will call it context. Then the first thing we want to do is we want to say var reader equals new stream reader. And we will pass that the context dot request dot body. Next, we will create a new variable and we will call this body. And we will go ahead and await reader dot read to and async. And we will close that. So we created this stream reader, and then we will go ahead and read it. Next, we will create an XML serializer. So we'll say var XML serializer equals new XML serializer. And that will almost certainly expect me to use a new using statement. Say type of person. And it looks like I actually do already have XML serialization in. I pulled that in at some point, and it might have just automatically done it there. So now we are pulling in the XML serializer. I will get that other request response out of my way. So now we have a serializer. We have a stream reader that has been read and pulled in our body. So now we will call var string reader equals new string reader and call that on the body. So now we have read that string, and then we will finally go var person, and we will deserialize this now by calling XML serializer, and we will call that on that variable string reader. Sorry, it's XML serializer dot deserialize. That's what I was doing wrong. And now I will call string reader. And so now I have my deserialized person. And so if I want to repeat the same behavior as before, I will return typed results dot OK, and I will return person. So that was a whole lot of steps. And I will change this one to OK too. So now this is the equivalent of this, except it's using XML instead of using JSON. And you can see here again, we have a lot more steps. Walking through them again, we create a new stream reader, we read that to the end, we create a new string reader, and then we pass in that read stream to the string reader. Then we have that we are going to pass to XML serializer.serializer. I know that's a lot. Again, I do not recommend working with XML unless you really need to. And yes, there are times to work with. But stick with JSON. It's kind of the happy path in .NET right now. The happy path is sort of a programmer term for the way that is easiest to do things powerfully without having to go through a lot of boilerplate and a bunch of extra steps. There are sort of really nice defaults for handling JSON that just don't exist for XML. Now the final thing we can do here is we can go ahead and save this. I will reset my server. I will go back to my request and I should have a couple of options down here. You can see now if I try to send in JSON, gonna get rejected. But if I try to send in XML, works like a charm. So that is how you do XML deserialization. And with that, you've now explored the basics of deserialization in ASP.NET Core. This can be one of the hardest API topics to understand, so don't be afraid if you need to rewatch parts of this video or come back to this later. If anything doesn't make sense, that's fine. I didn't get this on my first time, you might not either, but the important thing to remember here is this is the happy path. Put in the type of what you're expecting to get, take it in as an argument, and then you can do whatever you want with it. Don't worry about trying to do a bunch of complicated deserialization. You had to do a lot of this back in the day, and luckily .NET has moved away from that towards having really common sense standards.
In this lab, we're creating a very simple console application that will deserialize data from various file formats and put it in a C# object that we can then use and manipulate. So in step 1 of this lab, we're simply creating a new console application using .NET New Console, and we're going to call it Deserialization Demo. And then we're going to add a class that we're going to use to store the data that we deserialize. So in the program.cs file, within the program class, we're going to create a class called person that has two properties, username and user age. Username is string, user age is int. And when we deserialize the data from our various file formats, we're going to use this object to store that data. In step 2, we're going to start with deserializing a binary file. So within static void main, which is our main application, this is our main method. This is the method that runs when the application runs. We're going to take a file called person.dat, deserialize it, and then place it into our person object. In order to use binary deserialization, we have to use this. We have to reference the system.io library. So at the top of the file, we put using system.io, and that will allow us to read and write file data and binary data in our application. So here at the top, we're going to create a simple stopwatch that will run at the beginning of the application to show how quickly these operations take place. And when you run the application, you can see the different times that it takes to run a binary serialization over XML or JSON. In a small application like this, you won't see a big difference, but as files get big, you'll notice that the time it takes to run the operation is significant for binary operations and shorter for text-based operations like using JSON or XML. And this is just to illustrate that speed difference. So at the top, we're going to actually open our person.dat file. We have the using statement, new file stream, person.dat file mode open. So you'll notice in the root of the application, we have a file called person.dat. That's a binary file. And this is just telling the application to open a file stream of that file and get it ready for operations, get it ready to be used. The next line is using var reader equals new binary reader. So now we're creating a new binary file reader using the system.io library from that file stream object. So now that we have the file stream object created from the person.dat file, we're going to read that binary data in. We're going to place the results of that deserialization operation into a variable called deserializedPerson, which you can see we're declaring as a new person object. So as the binary reader does its work, it's going to deconstruct whatever's in that binary file and place the data into a person object that we can then reference, as you'll see in the next two lines. So we're going to place inside the person object, the person.username is going to be the result of reader read string. So right now we only have one string in there, and that's username. So whatever the string is, it's going to place it in username. And then we have reader.readInt32 that's going to place the age inside that binary file into user age. And now that we have the object created, we can reference the properties of the object. So first we'll stop the stopwatch, and then we'll write out to the console, deserialized person.username is the username, and deserialized person.userage is the user age. And we'll also write out how long it took to complete the operation. So using this deserializer, we can take a binary file and then place the contents of that binary file into a C# object that we can then reference. In step 3, we're going to do something very similar. We're going to deserialize an XML file and place it into our object. In order to use XML deserialization, we have to declare at the top of our file that we're using system.xml.serialization, letting our application know that we want access to the library. And then in our XML section, and for this demo, we're just going to create an XML file, and we're going to serialize it to a new variable. We could read from the XML file. I'm just showing you a different way to do this, because we can create XML data in one part of our application, serialize it, and then read it in other parts of the application. So here we're just going to create an XML file called XML data. We're going to serialize it using the XML serializer. And then we're going to create a new instance of our stopwatch, and then we're going to deserialize it using this reader. So in the next line, we see using var reader equals new string reader XML data. This just allows us to create an instance of the string reader class that will place the results of the XML data that we created above into that reader variable. Then we're going to deserialize it into a person object. So the next line is to create a variable called deserialized person, and that's set to a serialize deserialize method call, passing in the reader object data that we created above in that using statement, and we're setting that as a person object type that will deserialize the XML data that we defined above into that variable deserialized person. Next line, we stop the stopwatch, then we write out, as we did with the binary serialization, we write out to the console the properties that were in that XML file. So deserialized person.username and deserialized person.userage tells us what was in that XML. And again, we can do that with data we define here in the application or from an external file. And then the final thing that we do is just write out to the console how long that operation took. In step 4, we're going to do exactly the same thing, but we're going to use JSON data. In order to use the JSON serializer, I've added the using system.text.json declaration at the top that tells the application that we want to use the JSON library. And then in our JSON section of our code, we're doing something similar that we did with the XML serialization, and that is to declare the JSON data variable, which is just essentially a JSON file or a variable with JSON data in it. We declare our stopwatch and start that as a new instance. And then we deserialize our JSON data by declaring the var deserialized person using the JSON serializer.deserialize, passing in the JSON data, and using the person type for that operation. We then stop the stopwatch, and like we did with XML and binary serialization, we can reference now the data that was in that JSON file using dot notation in our C# objects. So we can use deserialized person.username and deserialized person.userage. And we write out to the console how long that took. So these are just 3 different ways that we can deserialize data from various file types or various types of data structures into a C# objects and then reference them using dot notation. If you ran each of these back to back, you would see the difference in times and how long it took to do each operation. And as your files grow, you will see different times, and you can choose which is the best for your purpose based on how fast and efficient each of the operations is. Serialization is a powerful technique for converting objects into a format that can be stored or transmitted. However, it comes with certain trade-offs, particularly in terms of performance. In this video, we will identify performance considerations for serialization. When it comes to performance, there are several ways serialization can affect your application. One is the impact on CPU usage. Serialization often requires significant CPU power, especially when working with complex or deeply nested objects. The more layers or attributes the object has, the more processing power it needs. Another impact is memory usage. Serializing data, particularly complex objects, can consume a lot of memory. Think of a deeply nested object like a user profile with multiple addresses and orders. This takes up more memory than a simple object with just a name and email. I/O or input-output operations can also impact performance. Writing serialized data to storage or sending it across a network can introduce latency, which is the delay before data transfer begins following instructions. It affects how quickly data is written, read, or transmitted, especially over networks when working with large files. For instance, when working with large serialized files or slow network speeds, you might experience delays when writing or reading that data due to the process's inherent latency. Understanding how serialization affects performance is essential for optimizing applications. However, the speed and efficiency of serialization can vary depending on several factors. First, the format you choose for serialization plays a big role as it impacts the efficiency, speed, compatibility, and ultimately the performance of your system, especially when working with large amounts of data or working in distributed environments. Let's explore some common data formats, starting with binary, to further illustrate how data format can affect serialization speed and efficiency. Binary serialization is fast and compact, but it's not easy for humans to read. It's efficient for performance, but not convenient for debugging or manual inspection. In comparison, XML is slower and results in larger files, but it's more readable and widely used for data exchange. It's easy for humans to read, but it's less efficient for performance. While JSON strikes a balance between speed and readability, making it a popular choice for web applications. It's faster than XML and easier to read than binary formats, offering a good compromise. Another factor that affects serialization speed and efficiency is the complexity of the object itself. More complex objects, especially those with multiple layers or nested attributes, take longer to serialize. For example, serializing a user object with just a name and email is quick, but a user profile with addresses, orders, and preferences takes more time. We also need to consider the overall size of the data being serialized. Larger data sets take longer to serialize and deserialize. For example, serializing a list of 10,000 users will take significantly more time than serializing a list of just 100 users, even if each user object is fairly simple. Another factor is your serialization settings. Options like ignoring null values or pretty printing, which adds indentation and line breaks for better readability, can impact performance. Using pretty printing with its use of spacing and indentation makes the output more human-friendly, but the added formatting also increases file size and slows down the serialization process. Finally, latency becomes a factor when sending serialized data over a network. A slow network will increase the time it takes to transmit serialized data. These factors are critical in determining how fast and efficient your serialization process will be. In this video, you learned about performance considerations for serialization. As you work with serialization, consider how small data complexity or settings changes can affect your application's performance, and how you can find the perfect balance between readability, speed, and efficiency in your next project. Serialization is a powerful tool for storing and transmitting data, but its efficiency can directly impact application performance. It's important to streamline this process to avoid unnecessary slowdowns. In this video, we will explain how to optimize serialization performance in .NET. Let's explore the key factors that can affect serialization performance. First, the data format you choose, whether it's binary, XML, or JSON, can impact both the speed and size of the serialized data. Next, the complexity of the data you're serializing can have a big impact on serialization performance. If you serialize very complex data with lots of nested details, it will take longer to process. Keeping objects simple will reduce serialization time. Third, the size of the data you're serializing also impacts serialization performance. Larger datasets will take longer to serialize, especially in environments with limited resources. Fourth, how you set up your serialization task will impact how your serializer performs. For example, if you include metadata or apply compression during the serialization process, your serializer may not be able to perform efficiently. When you need compression or to process metadata, you have to balance optimizing your serialization process with your application's goals. Finally, network latency is a factor when data is transmitted over the network. Serialization doesn't just happen on your machine. It often involves sending data across networks. If the network is slow or unreliable, it can dramatically impact performance. Sending a large serialized file over a slow Wi-Fi connection will take much longer than sending it over a fast, stable connection. With that overview of the factors that affect serialization performance, let's explore techniques to optimize it. To start, make sure to choose the right format for your data. Based on your application's needs, select a serialization format that balances performance and readability. For instance, compressing a file into a format that only the computer can understand is a good choice if you need fast serialization. Compression makes the file smaller and easy to transmit. But an uncompressed text format like JSON might be the better option if you require a format that's easier to debug, human readable, or works well with web APIs. Another technique is to simplify the structure of the file you're serializing. Avoid unnecessary complexity in your data. For example, you may have deeply nested data that contains a full customer profile with addresses, payment history, and preferences. Instead of serializing all this data, you can simplify it by including only key information, like the customer's name and recent purchases. This reduces both the size of the serialized data and the time it takes to serialize and deserialize. Making use of efficient code libraries can also help to optimize serialization performance. In .NET Core, system.text.json is a highly efficient code library for serializing JSON files. It offers better performance than older libraries like Newtonsoft.json. Finally, minimize the serialization scope. Only serialize the parts of the data that are necessary. For example, if you have a user data with many properties but only need the name and email fields, create a new data item with just those fields and serialize that. This reduces overhead and speeds up the serialization process. In this video, you learned about ways to optimize serialization performance in .NET. Optimizing serialization isn't just about performance, it's about making your application efficient and scalable. Serialization allows data to be stored and transferred between systems, making it essential in modern software. This allows different systems to communicate or store data efficiently. However, while serialization helps systems work together, it can also make data vulnerable to attacks if not managed carefully. In this video, we will identify security risks in serialization. One common security risk in serialization is deserialization attacks. Deserialization is the process of converting data back into a usable format. If this data isn't properly checked, attackers can manipulate it or send unexpected data types to the application. Attackers can also send malicious data, causing unintended behavior like remote code execution. For example, imagine an online form where you upload your resume. If the application doesn't check the data before uploading it, an attacker could upload something harmful instead of a resume, causing the system to run malicious code. Another security risk is data tampering. Attackers can alter serialized data during transmission, leading to corrupted data or security vulnerabilities. When data is transmitted between systems over a network, like when you send an email or a bank transfer, it can be intercepted by attackers. If an attacker modifies this data, they could cause serious issues like changing the amount of money in a bank transfer. And the last security risk we're going to discuss is the exposure of sensitive information. Sensitive data like passwords or personal details can be exposed if included in serialized objects and logged or transmitted insecurely. For example, if an application serializes user passwords and logs them for debugging, an attacker could access those logs and steal the passwords. These risks have caused major issues in real-world systems. Let's explore a notable example where poor serialization management led to a widespread vulnerability. In 2015, a major security flaw in a widely used Java library allowed attackers to execute code on servers through deserialization attacks. Since many applications depended on this library, the vulnerability had the potential to impact thousands of systems worldwide, leading to an urgent need for fixes. In this video, you learned about the main security risks of serialization, deserialization attacks, data tampering, and exposing sensitive information. By knowing these risks, you can avoid serious security issues in your projects and protect your applications and users from potential attacks. Security is constantly changing, and if you don't follow best practices, you risk harmful breaches, whether from malicious attacks or simple mistakes. Using secure processes like serialization and deserialization ensures our sensitive information doesn't get exposed. In this video, we will explain security best practices for serialization and deserialization. Before we address the solutions, let's first understand the key security risks that come with improper serialization and deserialization. Deserialization attacks happen when attackers send harmful data that exploits the deserialization process, potentially letting them run unauthorized code and compromise your application. In addition, data tampering occurs when serialized data is altered by an unauthorized party, compromising its integrity. This could lead to incorrect data being processed or security vulnerabilities. Finally, sensitive data exposure can occur if data is improperly serialized, leading to information leaks and data breaches in which attackers access personal or confidential information. Now that we've covered the risks, let's explore the key practices that help protect against these vulnerabilities. First, validate and sanitize inputs by checking and cleaning serialized data before deserializing it. Validation ensures that the data follows the expected format, like valid JSON or XML, and sanitization removes harmful elements. This prevents deserialization attacks. After ensuring the data is valid, it's important to use secure serialization libraries with built-in protection and keep them updated to reduce the risk of exploited vulnerabilities. In addition to using secure libraries, it's essential to avoid deserializing data from untrusted sources, like external services or user input. Untrusted data refers to information from unknown or unauthenticated sources, which may contain malicious code. Deserializing such data can expose your system to significant security risks. Another way to protect serialized data is by controlling who can access it. Use role-based access control, or RBAC, to limit who can access or modify serialized data. You should also consider encrypting sensitive data, which adds another layer of security. Encrypting data before serialization ensures that even if someone intercepts the data, they won't be able to read it without the correct decryption key. This protects confidential information from exposure. Lastly, it's important to verify that the data hasn't been altered during transmission by using integrity checks like hashing or digital signatures. Hashing generates a unique string representing the data, and digital signatures verifies its authenticity. Using all of these practices together will ensure your data is secure from malicious attacks or simple mistakes. In this video, you learned about security best practices for serialization and deserialization, including input validation, secure libraries, avoiding insecure deserialization, access controls, encryption, and data integrity checks. Following these steps helps secure your applications against common threats. this lab, we're going to set up a console application where we can practice protecting serialization operations using the .NET framework. So in the first step, step 1, we're going to set up the project by just creating a new .NET console application, calling it serialization security app. And we'll set up a basic template so that we can modify this template to practice some of these security skills. Sub-step 3 of step 1, we're going to modify our program.cs file by creating a user class. And just focus on the first 3 lines of this user class for now. So within the program class, we have a public class called user, and it has 3 properties: name, email, and password. And for now, that's all we're going to do in step 1, is to create that user object with those properties. You'll notice that this object does have a password included, and so down the road we may want to protect that in order to keep the password safe. In step 2, we're going to start to add some operations so that we can use this object that we've created. So we'll create a method called serializeUserData. It will return a string value, and it will accept a user object into the method. So for this method, just to start out for step 2, we're going to do something very simple. The serializeUser method will just return a JSON string. So focus on the last line of this method, return JSON serializer.serializer, and passing in the user object. So what this method will do is take that user object, that C# object, and serialize it out to a JSON file. So when this method is called, it simply returns a JSON file to the calling method. Also in step 2, we're going to change our main method to make a call to that JSON serializer method. So now within main, we can make a call to that serializeUserData method. Focus on the line string serializeData equals serializeUserData user. Ignore the other lines for now. We'll get back to that in a minute. But the first thing we do is we create a user object, and we define the properties. Alice is the name, email is alice@example.com, and then we have our password. Notice that when we pass that user object into serializeUserData, the serializeUserData method, we're getting JSON back, which is just plain text. So if we were to transport that over the internet, the data in that JSON file would be not secured. So the password would just be in plain text. And if that were used to access an important system, that data would be exposed to anyone who could read the JSON file. And then we're going to write out to the console what that serialized data is. Here we're showing generated hash, but in the step 2, you're going to just return serialized data in that option. Now in step 3, we're going to improve our serializeUserData method by adding some validation. In this block of code, we're adding an if statement. The if statement is validating whether username, user email, and user.password are null or have white space in them. If they do, if they're null, if they have no value, or they have white space, then we're not going to serialize the data. That could indicate a hack. It could indicate a problem. So we're just adding some simple validation to check that each of the values in our user object have data and don't have white space. If they do, we write out to the console that the data is invalid, and we return an empty string. Otherwise, we return our serialized JSON. In step 4, we're going to use secure serialization libraries to improve the approach that we're taking in securing this data. So we're going to create another method called deserializeUserData. This has a user object type. We're going to take in JSON data, and we're just going to pass in a Boolean value, indicating whether or not the data is trusted or not. So then we have an if statement. If the data is not trusted, then we're going to block deserialization, and we're not going to unpack this data. And that is just the value of the isTrustedSource Boolean value that we pass in. We return a null value in that case. Otherwise, we deserialize the data to a JSON object, and we pass in that JSON data to the method, and that returns a user object of deserialized JSON data. In step 5, we're going to add some encryption to our application. We're going to encrypt the password to make sure that if someone does snag the JSON data when it's in transit, they can't read the password. In order to use encryption, we have to add a library, a system security cryptography library that allows us to use specialized functions within the .NET framework to encrypt data. So in order to do that, we're going to create another method. This is step 3 of step 6, substep 3 of step 6. We're going to create another method inside the user object called encrypt data. And you'll notice inside this object, when we call this method, it's going to convert the password to a base 64 string and encode it using the getBytes method. And this will change the password into an unreadable string, essentially, that if it's intercepted, people cannot read it. Notice that it's inside the user object so that we can call it, once we've defined what password is, we can call it using user.encryptData right from the user object. In step 7, we're going to implement some data integrity checks. So again, we're going to use the system security cryptography library in order to do this. And we're going to add a generate hash method to our user class again. So what we're going to do inside of our user class is create a generate hash method that returns a string value. And what this method will do is use the SHA-256.create method, which is a part of the cryptography library, and it will create a list of bytes. You can see there under the using statement, we're going to place it in the hash bytes variable, and it will create a hash of the data that's in the user object, and then it will return it as a base 64 string. So it's going to return it as a string, but it creates this hash so that when it's calculated on the opposite side, if someone wants to calculate the hash on the opposite side, the hash should match. And this method allows us to create that hash so that people can verify that the data hasn't been modified in transit. By implementing these simple security measures, we've protected our user class, we've protected our password, and we've done some validation. In a real-world app, you can expand on these features to make your application even more secure. Congratulations on completing serialization and deserialization. This module introduced you to the critical processes of converting objects for storage and transmission in .NET and restoring them to their original state. We began by explaining serialization and its essential role in .NET, focusing on its role in enabling data storage and communication. Next, we examined the process of serializing objects in .NET, outlining clear steps to transform objects into formats that can be easily stored or transferred. Then we explored deserialization, focusing on reverting serialized objects to their original state within .NET applications. After that, we analyzed performance considerations, identifying key factors that affect the efficiency of serialization and deserialization processes. Finally, we reviewed security best practices to ensure your serialization processes are secure and protected from potential vulnerabilities. Now you have the skills to efficiently handle serialization and deserialization in .NET, ensuring both optimal performance and strong security. Welcome to Middleware and OpenAPI in ASP.NET Core. This module introduces you to the essential role of middleware in managing requests and responses, and how to integrate OpenAPI for seamless API documentation. You'll learn to design efficient middleware components and leverage OpenAPI tools to enhance your APIs in modern backend development. We will begin by defining middleware and understanding its critical role in managing the flow of requests and responses within ASP.NET Core applications. Next, we will explore common middleware components, used in ASP.NET Core and learn how they contribute to handling various tasks, such as authentication, logging, and error handling. Then we will focus on integrating OpenAPI Swagger with ASP.NET Core, allowing you to automatically generate comprehensive API documentation. After that, we will examine the process of generating API clients using Swagger, making communication and testing your APIs easier. Finally, we will cover best practices for designing middleware in ASP.NET Core, ensuring your applications are efficient, scalable, and maintainable. By the end of this module, you'll have the knowledge and tools to design effective middleware and integrate OpenAPI for seamless API documentation in ASP.NET Core. Let's get started with middleware and OpenAPI to enhance your back-end development skills. Imagine you're running an online store. Whenever someone places an order, multiple tasks need to happen, like checking stock, calculating shipping, and processing payments. But how does your system manage all these steps? The solution is found in something we call middleware. In this video, we will define middleware and its role in ASP.NET Core applications. Recall that middleware is software that works between the front end and the back end, acting as a bridge that facilitates communication and data management between different services, applications, or components. Before we proceed, let's examine HTTP requests, a key component for understanding middleware. An HTTP request is a message that a client, like a web browser, sends to a server to request data or perform an action. It's part of the HTTP protocol, which is the foundation of how web browsers and servers communicate on the internet. Middleware in ASP.NET Core controls how HTTP requests are managed. It allows developers to set up a pipeline, a series of middleware steps, that process each request. Think of a pipeline as a conveyor belt in a factory. Each piece of middleware along the conveyor performs a task like checking authentication or logging activity before passing the request to the next stage. For example, when you log into a website, middleware checks your credentials before allowing you to access the secure parts of the site. Now that we understand middleware, let's explore how middleware components work together in an application. Middleware components work in a sequence, like runners in a relay race. Each component does its task and then passes the request to the next piece of middleware. For instance, when you visit a web page, the first middleware logs your visit, otherwise known as logging. Logging is important because it tracks who accessed the page and when. Another middleware then checks if you're signed in, otherwise known as authentication. Finally, another middleware retrieves the data, page content for example, and sends it back to you as a response, a process known as data retrieval. Let's now explore some built-in ASP.NET Core middleware components that handle common application tasks. The ASP.NET Core Web Framework comes with several built-in middleware components that simplify handling specific tasks. One of these components is called Use Authentication. Use Authentication verifies whether a user is logged in before allowing access to certain parts of the website. This is critical for protecting sensitive user data, for instance in a banking app, allowing you to view your account information only once you're logged in securely. Another middleware component is Use Routing. This maps incoming requests to the correct parts of the application based on the URL. It also helps direct the user to the right controller and action method, like a GPS, guiding a driver to the correct destination based on their input. Middleware is essential to handling requests and responses in ASP.NET Core. It ensures that each step, like logging, authentication, and data retrieval, is managed correctly, keeping your application secure and efficient. In this video, you learned about middleware and discussed its role in ASP.NET Core applications. By utilizing middleware, you can build modular, flexible, and maintainable ASP.NET Core applications. Every time you visit a website, a lot of work happens in the background to handle your request. These steps make sure everything runs smoothly, like keeping your information safe. Behind it all, there's something called a middleware pipeline that helps manage this. By learning how this pipeline works, you'll be able to build apps that are secure and run efficiently. In this video, we'll describe the middleware pipeline in ASP.NET Core. Let's start by exploring the concept of a middleware pipeline. A middleware pipeline is a series of steps or pieces of middleware that handle each request made by a client like a web browser or mobile app to the server. Each step has a job like logging requests, checking security, or handling errors. Once one step finishes, the request moves to the next step until it's fully managed and a response is returned to the user. Now that you understand the concept of a middleware pipeline, let's break down how requests flow through it. First, the user makes an incoming request, like loading a web page. This request enters the pipeline at the first middleware. Second, the request is passed to the logging middleware, which records details like user activity and the resource being accessed. Once it finishes logging, the request moves to the third step, authentication. Authentication middleware checks if the user is logged into the application. If not, it stops the request and redirects the user to the login page. Otherwise, it moves to the next step. This helps protect important parts of your website from unauthorized users. If authorized, the request moves to the fourth step, application logic middleware, where data is retrieved or processed. Finally, in the fifth step, the request generates a response, which is returned to the user. For example, when static file middleware processes a request for a file, like an image or a CSS file, it retrieves the file from the server and sends it back to the user. If the file doesn't exist, the pipeline moves on to other middleware, such as error handling, to generate an appropriate response, like a 404 not found page. It's important to note that the order in which you invoke middleware matters. For example, if authentication happens after sensitive data is retrieved, unauthorized users could access that data. Let's illustrate how this works with an example, using a pretend company named Groove Echo, an eco-friendly startup that sells sustainable living products online. Here's how a request to load the product page for reusable bags flows through the middleware pipeline. When you click to view reusable bags on Groove Eco's website, your browser sends a request to the server. This incoming request is the first step in the process. The request then passes through logging middleware, which records details like the page you're visiting, your activity on the site, and any relevant data for tracking purposes. Next, the server uses authentication middleware to check if you are logged in. If you're not authenticated, the system will prompt you to log in before you can access certain features like adding products to your cart. Once authenticated, the server uses the application logic middleware to process the request by retrieving the necessary product information from Groove Eco's database. This includes product details, prices, and availability for reusable bags. Finally, the server generates a response that contains the product data and sends it back to your browser. The reusable bags page is then displayed to browse and interact with. In this video, you learned how middleware pipeline in ASP.NET Core operates, including the essential role middleware plays in managing client requests, from the initial logging of activities to securing applications with authentication. This pipeline is crucial for creating secure, efficient, and well-structured web applications that ensure each request is properly managed. Behind every seamless app experience, APIs handle crucial communication between systems. However, understanding how they work and making them easy to use is where OpenAPI and Swagger step in, transforming complexity into clarity. In this video, we will explain the purpose and benefits of OpenAPI and Swagger. Now let's explore OpenAPI and its role in API development. OpenAPI is a standardized framework that provides a blueprint for how APIs function. OpenAPI acts as a detailed map outlining all the capabilities of your API, including various endpoints, which are the different parts of the API, the data they require, and the responses they return. Imagine your API lets users access a list of books. OpenAPI would describe how to request that list and what kind of response to expect, like the titles and the authors of the books. With this map, developers know exactly what the API can do. Now let's explore a tool that can help take the OpenAPI standard and turn it into a functional interface. We will be using the toolset called Swagger. Swagger is a powerful toolset built around the OpenAPI specification that transforms the API's blueprint into an interactive experience. It takes the API map defined by OpenAPI and turns it into a user-friendly interface where developers can explore, test, and interact with the API directly from their browsers. For instance, if a developer wants to understand how the API returns a list of books, they can enter some details into Swagger and get the API's response right in their browser. This saves time because they don't need to build a separate testing setup. Now that you understand the basics of OpenAPI and Swagger, let's review their key benefits to developing APIs. First, OpenAPI provides a clear and consistent way to describe APIs by standardizing API documentation. This improves your ability to work together by allowing everyone who works with the API to have a similar understanding of the process. Swagger turns this documentation into something interactive so developers can easily test and explore the API. Think about how confusing it would be if multiple developers described the same API differently. OpenAPI prevents that by keeping everything consistent and clear so everyone using the API knows exactly how it works. Next, Swagger makes it simple to test APIs directly from the browser. Developers can send requests which ask for specific information from the API and get responses, the API's answer, immediately. This speeds up development and troubleshooting. Let's say you're testing how your API handles a request for a list of books. Using Swagger, you can quickly send the request and immediately get the result, all from your browser. This makes the whole process faster and easier. Another benefit is that OpenAPI and Swagger make it easy for different development team members to understand and use the API, which improves team collaboration. Frontend and backend developers, testers, and others can all rely on the same clear, interactive documentation. A front-end developer might build features that must connect to the API even if the backend is still in progress. Swagger makes this possible, allowing teams to collaborate smoothly and avoid delays. Finally, maintaining your API is easier with Swagger. When you update your API, Swagger automatically updates the documentation to reflect any changes. This ensures developers always have the latest version of the API guide, reducing confusion and mistakes. Swagger will instantly update the documentation if you add a new feature to your API, like showing authors alongside books. This way, developers can immediately understand how to use the new feature without manually adjusting the documentation. In this video, you learned that OpenAPI provides a standardized framework for defining APIs, serving as a blueprint for an API's functionality and endpoints. Swagger builds on this by turning the blueprint into an interactive tool, enabling developers to test and explore APIs directly from their browsers. You also explored how OpenAPI and Swagger streamline documentation, simplify testing, improve team collaboration, and simplify API maintenance.
Documenting your API so people can use it is one of the most important and time-consuming parts of being a backend developer. Ensuring your documentation stays in sync with the underlying functionality is critical, because incorrect documentation is often worse than having no documentation at all. One of the greatest benefits of working with Swagger is the ability to automatically have your documentation reflect the underlying code. So let's implement this into our CRUD application. So in this video, we will explain how to integrate Swagger with our ASP.NET Core code. First, I want to clarify some naming conventions. We have OpenAPI, Swagger, and Swashbuckle. OpenAPI is a standard for documenting APIs. You can think of it as a special syntax. Swagger is tooling that was built to work with and produce APIs that meet that standard. OpenAPI merged with Swagger a few years back, so you'll often hear them used interchangeably, but there technically is a difference. And then Swashbuckle is a namespace that contains Swagger in the .NET world. You see it up here. It houses some essential packages that enable Swagger. Now that you understand those, let's get started adding Swagger to our API. The first thing we need to do is install the necessary dependencies, and I went ahead and did that before this video here. One of them is Microsoft.ASP.NET Core.OpenAPI, and one of them is Swashbuckle.ASP.NET Core. And I went ahead and added using statements at the top to reflect both of those dependencies. Remember, you can use the command palette and NuGet to install those. Once the packages are installed, we basically need to do 4 things. The first thing we're going to do is grab our builder and add in a service. So let's say builder.services dot add endpoint explorer. Yes, that's correct. So we'll say add endpoint explorer. And so what this is going to do is add in a service that will be used to sort of look at all of our different routes and then document them. Then the other thing we are going to add is builder.services.add swaggergen. And swaggergen is going to then take what Endpoints API Explorer does and convert that to meet the OpenAPI standard. So it will produce a JSON document that documents everything that our API does. Then we want to add some middleware. And so the way we'll do that is first we want to create an if statement. And the reason we want to do this is we want to check to see if our environment is development. And so this means we only want to run this code if we are running it on our development server here on our machine and not in production. And now the reason this is important is because you are going to be giving out a lot of information about your API through Swagger, and you probably don't want to just blindly expose that to anyone who can access your API. So I recommend gating it through this unless you have a really important reason not to. You can just use it internally for your own development. So we'll say app.useSwagger here is the first middleware, and this will provide us with some functionality, as will app.useSwagger API, or Swagger UI, sorry. And so use Swagger will create a route that exposes our generated Swagger document at a particular URL. And then use Swagger UI will take that exposed JSON and it will actually create an entire user interface around it to make it really lovely to work with. So now we can come in here, we can go ahead and save this. I will start up my terminal, so .NET watch run, and this will pop open our browser as soon as it's done building. Awesome, so now I have this and I can go to /swagger/v1/ I believe it's swagger.json. Let's give that a try. Excellent. And so this is our OpenAPI standard Swagger document. And if you look through this, one, it looks a bit obtuse. There's a lot of information here. But if you poke through, you can actually see like, hey, there's our root path. And there's our blogs path. Oh, and that's the get. And that's the post. Oh, and we can do blogs.id. That's a get. That's a delete. That's a put. And here's the different parameters they take. And here's what the body is going to return. And here's what the response is going to be. So that is all the information that you need to understand the entire functionality of our API. Technically, if you understand this, you get it all, but it's not very readable, which is where Swagger UI comes in. So if we go back to our path and I delete part of this out and go to /swagger, now it looks like this. This is the same information, but presented in a much more readable way. Let's get started by going to our blogs get. And you can see here that here's my blogs route. It doesn't take in any parameters. Here's what it can respond. Here's what the return might look like, and it knows that because down here you can see the schema for our blog object, what that looks like. It's a nullable string, it's a nullable string. And then you come up here and we can say try it out and execute. And that just makes a call to our blog. We mentioned curl earlier, so this is a command line tool. If you copied and pasted this into the command line, it would actually make a request directly from your command line. Here's what the URL was. You can see the headers. So there's all kinds of useful information from here. So instead of using that requests.http file like we've been using, which still definitely has some uses, you can create something like this that just automatically generates all this documentation for you. It's really, really handy. We can also come down and go to our post route, and you'll see here that it knows that it expects this data. So again, we can say try it out. And here it gives us a prompt, and we can type this is my title, and we can type this is my body. And then we can execute that, typo and all. And you can see here that we got a response 201, and we go back to our blogs. We can go ahead and get blogs. And you'll see here that there's all of our blogs. It works like a charm. It looks like I accidentally executed that twice, but we can see that it absolutely works. Now I want to take a step back and just point out that I added 4 lines of code to get that beautiful user interface that is documenting our application. This is the kind of thing that entire development teams used to be dedicated to, and there still are for good reason. But for many cases, this gets you a long ways toward awesome documentation. And just taking it this far is all you often need to do. But we can take it a step further. So one of the things I want to do is we can return to our application, and we can actually come down here and we can do some things to these routes to make it even more interesting. So this one, let's chain on another method call to this, and we'll say with open API, and this will take in an operation. And then at the end, we will return that operation. But before we do that, we're going to do some things to the operation. Like we can take the operation and we can take its parameters, and we can take the first one, which is the ID up here, and we can say that has a description. So earlier, it didn't actually say what the ID is, and we can say that is the ID of the blog to retrieve. Nice and explicit there. Oops, period on the inside. And then we need to add that semicolon, and we can also say operation.summary equals get single blog, so we can let someone know what we're doing with this particular route. And then we can say operation.description, and we can give a little more detailed information here. We say returns a single blog. Now, if I save this, we can go back to our generated information, and let's see if that needed a reset or not on our server. But if I go to get blogs, except I want get blog ID, that's what we're looking for. So it does look like I need to reset here. Go ahead and Control R. We'll give that a second to reset. And now we've got our information here. So get single blog. So as I'm going down, I can see what these different routes mean. I can click in, then we can have a longer description here. This one's a little bit short. Then I can see here that the ID is the ID of the blog to retrieve. So we can provide all kinds of useful information by using this single with open API call. And you can sort of look up through a Bing search what you're going to be able to do with this. There's a lot of other properties that you can change. Another thing to point out here is that right now, if we look at our documentation, it says that the only thing it can return is a 200 OK, but it can actually return not found as well. So this technically isn't correct. And the way we can handle that, the first way, and this is the way I actually don't recommend, but I'll show you anyway, we can say produces a blog, and this is going to return a status codes.status 200 OK. Yes, that's the one I want. And then I can chain on another with down here, and we'll say produces, and it can also do a status codes dot status 404. There's my 404 not found. And now again, if I save and then reload, if we go back to our UI, we should be able to reload. And now that is our ID route. We should be able to come down here and see now we can get a 200 or we can get a 404 not found. Now we have a problem. We had to explicitly say that these are the two things it returns. If I come up here and I change my code and I add in a third option and it's not reflected down here, this documentation is now lying. It's actually saying something other than the reality of what our code does. So if I get rid of those and instead I can swap our results out for something more useful. So what I'm going to do is take my results and I'm going to replace them with typed results. And this is considered best practice for working with APIs like this. It's almost always better to use typed results than it is to use results. They just take a little bit more code to produce. And so what we need to do here is we need to define what is going to be returned. So we'll say this is a results. And I know it's a little bit confusing that this is a results, but it's typed results, but that's just kind of the way this is set up. And this will be an OK of type blog, and we also have a not found. And I am getting an error here, and that is because I need to bring in HTTP results, and that now resolves itself. And so I can go ahead and save that. And yes, I want to restart. Then once again, if I go back to my documentation here, I can see that I still have that 200 and 404. But now if I change this and use another type results answer there, my code matches perfectly with my documentation. They will no longer be out of sync. So this is the way I absolutely recommend you correctly put the types that can be returned from your API. This is one of those things that the first time I learned it, it's kind of magic. It really does make your documentation so much easier and so much more robust. It's really hard to screw this up if you just always use typed results. Then the last thing I want to show is sometimes you have a route that maybe you don't want to show. So right now we're showing our route route. Maybe I don't want that. And so I can say exclude from description. I can call this method on there. And now this will not show up in our Swagger documentation. By following this process, you will have integrated Swagger into your ASP.NET Core project, providing clear, dynamic, and interactive documentation for your API. And it makes it so much easier to use and understand for yourself and any developers who might use it after you. Documenting your API so people can use it is one of the most important and time-consuming parts of being a backend developer. Ensuring your documentation stays in sync with the underlying functionality is critical, because incorrect documentation is often worse than having no documentation at all. One of the greatest benefits of working with Swagger is the ability to automatically have your documentation reflect the underlying code. So let's implement this into our CRUD application. So in this video, we will explain how to integrate Swagger with our ASP.NET Core code. First, I want to clarify some naming conventions. We have OpenAPI, Swagger, and Swashbuckle. OpenAPI is a standard for documenting APIs. You can think of it as a special syntax. Swagger is tooling that was built to work with and produce APIs that meet that standard. OpenAPI merged with Swagger a few years back, so you'll often hear them used interchangeably, but there technically is a difference. And then Swashbuckle is a namespace that contains Swagger in the .NET world. You see it up here. It houses some essential packages that enable Swagger. Now that you understand those, let's get started adding Swagger to our API. The first thing we need to do is install the necessary dependencies, and I went ahead and did that before this video here. One of them is Microsoft.ASP.NET Core.OpenAPI, and one of them is Swashbuckle.ASP.NET Core, and I went ahead and added using statements at the top to reflect both of those dependencies. Remember, you can use the command palette and NuGet to install those. Once the packages are installed, we basically need to do four things. The first thing we're going to do is grab our builder and add in a service. So let's say builder.services add endpoint explorer. Yes, that's correct. So we'll say add endpoint explorer. And so what this is going to do is add in a service that will be used to sort of look at all of our different routes and then document them. Then the other thing we are going to add is builder.services.add swaggergen. And swaggergen is going to then take what Endpoints API Explorer does and convert that to meet the OpenAPI standard. So it will produce a JSON document that documents everything that our API does. Then we want to add some middleware. And so the way we'll do that is first we want to create an if statement. And the reason we want to do this is we want to check to see if our environment is development. And so this means we only want to run this code if we are running it on our development server here on our machine and not in production. And now the reason this is important is because you are going to be giving out a lot of information about your API through Swagger, and you probably don't want to just blindly expose that to anyone who can access your API. So I recommend gating it through this unless you have a really important reason not to. You can just use it internally for your own development. So we'll say app.use Swagger here is the first middleware, and this will provide us with some functionality, as will app.use Swagger API, or Swagger UI, sorry. And so use Swagger will create a route that exposes our generated Swagger document at a particular URL. And then use Swagger UI will take that exposed JSON and it will actually create an entire user interface around it to make it really lovely to work with. So now we can come in here, we can go ahead and save this. I will start up my terminal, so .NET watch run, and this will pop open our browser as soon as it's done building. Awesome, so now I have this and I can go to /swagger /v1 / I believe it's swagger.json. Let's give that a try. Excellent. And so this is our OpenAPI standard Swagger document. And if you look through this, one, it looks a bit obtuse. There's a lot of information here. But if you poke through, you can actually see like, hey, there's our root path. And there's our blogs path. Oh, and that's the get. And that's the post. Oh, and we can do blogs.id. That's a get. That's a delete. That's a put. And here's the different parameters they take. And here's what the body is going to return. And here's what the response is going to be. So that is all the information that you need to understand the entire functionality of our API. Technically, if you understand this, you get it all, but it's not very readable, which is where Swagger UI comes in. So if we go back to our path and I delete part of this out and go to /swagger, now it looks like this. This is the same information, but presented in a much more readable way. Let's get started by going to our blogs get. And you can see here that here's my blogs route. It doesn't take in any parameters. Here's what it can respond. Here's what the return might look like, and it knows that because down here you can see the schema for our blog object, what that looks like. It's a nullable string, it's a nullable string. And then you come up here and we can say try it out and execute. And that just makes a call to our blog. We mentioned curl earlier, so this is a command line tool. If you copied and pasted this into the command line, it would actually make a request directly from your command line. Here's what the URL was. You can see the headers. So there's all kinds of useful information from here. So instead of using that requests.http file like we've been using, which still definitely has some uses, you can create something like this that just automatically generates all this documentation for you. It's really, really handy. We can also come down and go to our post route, and you'll see here that it knows that it expects this data. So again, we can say try it out, and here it gives us a prompt, and we can type this is my title, and we can type this is my body, and then we can execute that, typo and all, and you can see here that we got a response to a 1, and we go back to our blogs. We can go ahead and get blogs. And you'll see here that there's all of our blogs. It works like a charm. It looks like I accidentally executed that twice, but we can see that it absolutely works. Now I want to take a step back and just point out that I added 4 lines of code to get that beautiful user interface that is documenting our application. This is the kind of thing that entire development teams used to be dedicated to, and there still are for good reason. But for many cases, this gets you a long ways toward awesome documentation. And just taking it this far is all you often need to do. But we can take it a step further. So one of the things I want to do is we can return to our application and we can actually come down here and we can do some things to these routes to make it even more interesting. So this one, let's chain on another method call to this and we'll say with open API, and this will take in an operation. And then at the end, we will return that operation. But before we do that, we're going to do some things to the operation. Like we can take the operation and we can take its parameters and we can take the first one, which is the ID up here, and we can say that has a description. So earlier, it didn't actually say what the ID is, and we can say that is the ID of the blog to retrieve. Nice and explicit there. Oops, period on the inside. And then we need to add that semicolon. And we can also say operation.summary equals get single blog. So we can let someone know what we're doing with this particular route. And then we can say operation.description, and we can give a little more detailed information here. We say returns a single blog. Now, if I save this, we can go back to our generated information and let's see if that needed a reset or not on our server. But if I go to get blogs, except I want get blog ID, that's what we're looking for. So it does look like I need to reset here. Go ahead and Control R. We'll give that a second to reset. And now we've got our information here. So get single blog. So as I'm going down, I can see what these different routes mean. I can click in, then we can have a longer description here. This one's a little bit short. Then I can see here that the ID is the ID of the blog to retrieve. So we can provide all kinds of useful information by using this single with open API call. And you can sort of look up through a Bing search what you're gonna be able to do with this. There's a lot of other properties that you can change. Another thing to point out here is that right now, if we look at our documentation, it says that the only thing it can return is a 200 OK, but it can actually return not found as well. So this technically isn't correct. And the way we can handle that, the first way, and this is the way I actually don't recommend, but I'll show you anyway, we can say produces a blog, and this is going to return a status codes.status 200 OK. Yes, that's the one I want. And then I can chain on another with down here, and we'll say produces, and it can also do a status codes dot status 404. There's my 404 not found. And now again, if I save and then reload, if we go back to our UI, we should be able to reload. And now that is our ID route. We should be able to come down here and see now we can get a 200 or we can get a 404 not found. Now we have a problem. We had to explicitly say that these are the two things it returns. If I come up here and I change my code and I add in a third option and it's not reflected down here, this documentation is now lying. It's actually saying something other than the reality of what our code does. So if I get rid of those and instead I can swap our results out for something more useful. So what I'm going to do is take my results and I'm going to replace them with typed results. And this is considered best practice for working with APIs like this. It's almost always better to use typed results than it is to use results. They just take a little bit more code to produce. And so what we need to do here is we need to define what is going to be returned. So we'll say this is a results. And I know it's a little bit confusing that this is a results, but it's typed results, but that's just kind of the way this is set up. And this will be an OK of type blog, and we also have a not found. And I am getting an error here, and that is because I need to bring in HTTP results, and that now resolves itself. And so I can go ahead and save that. And yes, I want to restart. Then once again, if I go back to my documentation here, I can see that I still have that 200 and 404, but now if I change this and use another type results answer there, my code matches perfectly with my documentation. They will no longer be out of sync. So this is the way I absolutely recommend you correctly put the types that can be returned from your API. This is one of those things that the first time I learned it, it's kind of magic. It really does make your documentation so much easier and so much more robust. It's really hard to screw this up if you just always use typed results. Then the last thing I want to show is sometimes you have a route that maybe you don't want to show. So right now we're showing our root route. Maybe I don't want that. And so I can say exclude from description. I can call this method on there. And now this will not show up in our Swagger documentation. By following this process, you will have integrated Swagger into your ASP.NET Core project, providing clear, dynamic, and interactive documentation for your API. And it makes it so much easier to use and understand for yourself and any developers who might use it after you.
Up to this point, we've been learning how to build code that will run on our API server. But the whole goal of this backend code is to provide a useful utility for a client. And for that to happen, the client has to send requests to our server and work with the responses. Manually writing the code to handle these operations is time-consuming and incredibly error-prone. But it doesn't have to be that way. In this video, we will describe the process of generating API clients using Swagger. Let's begin by introducing what Swagger is. Using Swagger, we can automatically generate client code that contains functions to handle the front-end communications with our server and all the types of data it will transact. This code is often referred to as a software developer kit or SDK. It's like a set of building blocks that a front-end developer can use to build client applications that communicates with our backend. This allows them to focus on building the front end's core functionality while ensuring consistent and reliable API interactions across the projects. Swagger is a tool set that turns the API blueprint into an interactive, user-friendly experience. It helps developers design, build, document, and consume REST APIs. It also automates tasks that developers would otherwise have to do manually. Swagger is useful because it automates the generation of client code using OpenAPI specification or OAS, which outlines the API's endpoints and data formats. This saves developers time, ensures consistency, and reduces errors when interacting with APIs. Before we generate client code, let's review the key part of this process, creating the API specification with OpenAPI. The first step is to create the API specification using the OpenAPI format. This specification describes your API's endpoints, parameters, and responses. It acts as a blueprint for how your API works and ensures consistent communication between it and other systems. For instance, you might document a get/user/ID endpoint that retrieves user details, including the user ID as a parameter and the expected response in JSON format. In the second step, you can utilize Swagger middleware to serve that API specification as JSON on a specific route. This exposes your API specification so your code, other software, and even other developers can utilize it. The third step is to use nswag to generate client code that handles API requests and responses. This saves you from manually writing the logic to interact with the API, since everything is already set up to send and receive data exactly the way your API expects. In the final step, you will integrate the generated client code into your C# project like any external library. Once added, you can easily call methods to retrieve data from the API without worrying about low-level communication. Let's bring everything together with a practical example. Imagine you're building a web app that manages user information from an external API. First, you define the API routes that perform operations like getting all users, deleting a user, and changing user permissions. Next, you use the Swagger middleware to serve this data at a specific path. Typically, this will be something like /swagger, /v1, /swagger.json. Then you can use nswag to generate client functions like get users, delete users, and update user permissions. You can generate this client through the nswag CLI, the nswag desktop application, or the nswag C# libraries. Finally, you integrate the client code into your app. All client code methods will know exactly what data the routes expect and what they should return. The code has appropriate types, so you can use IntelliSense to quickly understand exactly how to interact with your API without needing to understand the server code. Anytime you change your API, you can regenerate the client code and add it. In this video, you learned how to generate API clients using Swagger. We covered how Swagger uses the Open API specification to document API endpoints and how NSwag automates client code generation. You also explored how the generated code integrates into a project, making API requests easier and more reliable, saving time and reducing errors.
One of the best things about working in the .NET ecosystem is the Swagger tooling. We've already explored how to add Swagger documentation, but what happens when you want to consume your Swagger API in client code? That's another place where Swagger really shines. In this video, we'll explain how to automatically generate API client code using Swagger. Let's take a moment to add a little more context here. This is a back-end course, and we haven't focused much on the front end. But a front end is simply a client that makes requests to our back end. Perhaps the easiest way to make a client is with a simple command line app, so let's go ahead and do that. So I have created an application here, and it is just the standard console app. So we went .NET new console. You can do this from the command palette as well. So this is just a really simple way to build a simple app. I also want to note that I have my server running here. That is running at this URL right now, and that is serving that blog CRUD API with our Swagger integration built into that. So we will be able to consume it here for our client generation. So I'm going to start by walking through the process of manually making a request to our server from the client. So the first thing we're going to do is we're going to make an HTTP client, and this will be a new HTTP client. I'm also going to make a note here of our API base URL, and that was that value I saved up here. So I would have that for later. So this is our base URL. Then I am going to go ahead and make a GET request. So I will save the results of that as HTTP results, and I will await HTTP client dot get async, which, like it sounds like, will asynchronously make a GET request. And then the string I want to do that is going to be our API base URL and then /blogs. So this will go ahead and make a GET request to our blogs path. So the first thing I'm going to do is I'm going to check to see if the status code of those results was not okay. So I need the HTTP results, and I need the status code, and I will check to see if that does not equal system.net.statuscode.ok. If it does not, I will go ahead and console.writeLine, and I will say failed to fetch blogs. And this will go ahead and return, so it will exit out of our function. If that was okay, we will keep going on. So the first thing I'm going to do is I'm going to create a stream to read that blog into. So I will say await, and then I need HTTP results dot content. So we'll look at the content of those results, and then we will read as stream async. Then the next thing I'm going to do here is I'm going to create a stream to hold those blogs, and then I will go ahead and await HTTP results dot content dot read as stream async. We'll call that method, and so that will now give us a stream to read that into, and then we're going to need to deserialize this. So we want some deserializer options, and we'll say new system.text.json serializer options. There we are. And then we'll come down a line and we'll open up some curly brackets, and we want to set a couple things like property, name, case, and sensitivity, and we'll set that to true to make sure that we are handling case and sensitivity when we do this. Then the next thing we're going to do is deserialize those using those new settings. So we'll say var blogs equals await system dot text dot JSON dot JSON serializer dot deserialize, I believe async. Yep, that's what I want. And it will take in a list of blog. It doesn't know what this is yet, so let's go ahead and create our blog class. So we'll say class blog public required string title, and that will have a get and a set, and then we'll say public required string body, and again a get and a set. So now we have a blog, so now we can go there and say a list of blogs. Then this is a method, so we want to call that method, and it will take in two things. It needs that stream we set up earlier, and it needs the options. The last thing I'm going to do here is it looked like I spelled blog wrong, so we'll go ahead and do blog. And so now we finally have blogs, so now we can actually do something with them. So let's do for each var blog in blogs. Then let's go ahead and console dot write line, and let's just do something like title, add a colon, and then the body, and I need the blog.body and the blog.title. And now you're going to notice here that we have this possible null reference, so I also need to come down because we might not have actually gotten blogs back. And so I'll say if blogs does not equal null, then do this, otherwise don't. Go ahead and indent that in 1. And so now, in theory, this code will actually run. So let's go ahead and go to our terminal and let's say .NET run. And here we get my first post, my second post, and I still have that hello world in there that I do not need. So this is the way that you would manually make a request to our blog. You would need the base URL, and you're going to go ahead and make a GET request to that, and then you're going to check the status code to make sure it came back okay. Then you're going to deserialize it, and to do that, you need to make some options. You need to make a stream to load that into, and then you need to check to make sure it's not null, and then finally you can do something with it. It's a whole bunch of steps, but we can do that way easier and way more safely using a generated client. And so to do that, I am going to create a new file in this project. So I am going to call this file client generator. And then we will add another package here, and this one will be NuGet add package. We want nswag again, but this time we're going to want to grab the code generation C# nswag code generation C#. Excellent. Now I'm going to copy paste in a bunch of using statements that will pull in everything we need, so you don't have to watch me type them out. We've got system, system.io, system.net.http, system.threading.tasks, nswag, and nswag code generation C#. So now this is going to feel like a lot of code, but the important thing to remember here is we will run this once. So the first thing we're going to do is we're going to make a public class. We will call this Swagger Client Generator. Then we will do public async task and generate client. Then we will want to do var http client equals new http client, just like we did before. And then what do we want to do with that? We want to say var swagger JSON equals await http client dot get string async. Then this will be, first off, the base URL for our server, which in this case is http://localhost, And then let's see what port we were running on. It should be up here, 5230, or set it to whatever your port is. And then we want swagger /v1/swagger.json. Now remember, this is the raw JSON document for our API. So this is what the generator is going to consume. It's sort of a programmatic way that it can read, hey, here's everything that your API can do. Now let me create code based on that. Next thing I'm going to do is I'm going to say document equals await, and we'll open API document dot from JSON async. So that will take in that Swagger JSON we just created and actually create the document from it. Then I'm going to want to make some settings for our generator. New C# client generator settings. And then let's say the class name, we'll go ahead and call this blog API client. And we're going to want to remember these because we will need them later. And then let's say C# generator settings equals. And then we'll give this a namespace and it will equal blog API. So these are the namespace and then what we will access the class as when we actually go to use our client from the generated code. You can change these to whatever you like. In this case, I think these make sense. And so finally, we will create a generator. This will be a new C# client generator, and we will pass in that document that we created a second ago and the settings. So now this is the thing that will actually generate the code from the documentation that we pulled down and the settings we just specified. Finally, we can say var code equals generator dot generate file. And so this is actually generating a bunch of text that is actually C# code. And then finally, we can go ahead and write that to a file by doing file.write all lines async. Write all text async is actually what I want. And then let's give this a name. So I will call it blog API client. And then finally, what do we want to save there? And I forgot the extension, so that'll be blog API client.cs. And then I will save my code there. And so now this is the entirety of everything we need to do to generate our API client code. We run this anytime we want to make a client, which is anytime we make changes to our API. So if we add new routes or we add new behaviors, we probably want to go ahead and regenerate this so that when we use it in our client or we hand it off to whoever's making that client, that it accurately reflects our underlying code. Now all we need to do is use it. So let's go ahead and comment out all this code that we made before because we just don't need it anymore. All right, now that that's commented out, we can go ahead and go back up to the top and we will say await new Swagger client generator, and then we will generate client. So that is the generator that we built over here, Swagger client generator, and we're calling the generate client method. And now you'll see some magic here. So if I do .NET run after saving, and now you see this appearing. We have this blog API client.cs. Now this is a huge file. Probably just hundreds and hundreds and hundreds of lines of code that explain how to work with our API. So I'm going to go back to our program, and I'm going to go ahead and comment this out because we don't need to run this again. We only need to run this code when we generate our API. And in this case, I'm just doing it this once and shouldn't need to do it again because I'm not making changes to my API. Now, normally I would split this out into two different projects, but for ease of demonstration, I just wanted to show this here integrated, sort of using the same project. But so now, instead of writing all this code, let's show how we can use that client. So the first thing I want to do is I want to import our blog client, blog API, I guess I called it. So there is our blog API. So the first thing I'm going to do is I'm going to import blog API. And remember, that is what we used in our generator over here. It's blog API, and then we want a blog API client. So let's go down here and let's say var blogs or var client equals new blog API dot blog API client. And now this needs a base URL, so we'll go ahead and steal this from here, and it will also need a client. So we can uncomment those 2 lines, and then we will pass in the API base URL, and we will go ahead and pass in the HTTP client. And so now we have our new client, and I actually don't need that blog API there. We just need the blog API client. So this is now an object that understands how to work with our API. So now let's say I want to get my blogs. And so now I can use my client and I can do dot. And then you can see I have IntelliSense here for methods like blogs get all async. That's probably what I want, to get all of my blogs. Rather than blogs get, I want get all. And so let's go ahead and check what that needs. And it doesn't look like it needs anything. So I can put in a semicolon there. And now we have some blogs. And so what can we do with those? Well, we can do exactly what we were doing before. Let's steal this for loop from down here, come back up, pop that in there. Bada bing, bada boom. So now we've got some blogs. Well, we almost have some blogs, so I need to await this because it is async. Otherwise, we're just getting back that task. So now I can go ahead and loop over all those. So I'm going to steal my for loop from here. And let's go ahead and pop that down there and uncomment it. And now we can just run this code. And I do not believe we need this if check anymore because it handles that elegantly without us needing to worry about it. So let's save that and let's try .NET run. And there we go. We have 2 blogs. So these lines of code right here just replaced all of this code. And now it feels like we had to go through a lot of steps to get here. But I want to reiterate that we had to make this code once. We never have to change this. We can just run this over and over again every time we want our API. And now if I was just making this one call to our API, it's probably not worth going to the time to make an API client. But let's say I also want to delete a blog. I can say client.blogs delete async, and I want to delete the first one, let's say, and I can do that. I can say, let's create a new blog for posting. So let's say var blog equals new blog. And let's open that up, and then go ahead and put a semicolon there, and let's say the title equals my title. Let's go ahead and say the body equals a new body, and then save that, and we can come down and let's say client dot blogs. Let's post async. And what does post async want? It wants a blog, so we can pass in our blog, and now that runs there. And I also forgot here, these are async, so I want to go ahead and await them. And so now deleting a blog and posting a blog would have been a whole new chunk of code, sort of like these. But instead of needing to do that, we can just use these methods that elegantly handle all of the error cases and make sure the right types are being sent in and being received without us having to worry about that. The other thing here is if we make major changes to our blog, and so we generate a new API client and then we send that to whoever's making the client, and all of a sudden they see a bunch of errors, they know that the API has changed in a breaking way so they can update their code responsibly before you just have users hitting these problems. So we didn't have to worry about any of the null checks, any of the status code checks. It just does that all behind the scenes for us. It's shorter, safer, and easier to maintain than the manually written code we started with. Plus, it has better type safety and it's self-documenting thanks to IntelliSense. We could add new objects to our API, change the existing API, and add new endpoints. To keep our code communicating effectively, we just have to generate a new API client using the methods we defined earlier. We'd even create a client for another language like TypeScript if we wanted to, just by changing a couple of lines of code. We were using the C# generator over here. There's also a TypeScript generator, which is the type-safe version of JavaScript. So there you have it. Now you know how to generate a client for your API using Swagger automatically. This approach saves you a lot of time and effort and ensures that your client code is always up to date and stays in sync with your API.
We're going to be setting up a console application, and we're going to be using Swagger API to generate some API documentation and the ability to see how the API works without having to do a lot of manual work ourselves. So we're going to use Swagger to accomplish some of those goals. So in step one, we set up our console application. Then we add all of our packages to the application. We add our Swashbuckle ASP.NET Core, which is part of the Swagger installation. And then we use this tool called nswag. So we add a package called nswag core, nswag code generation.c#, and then nswag API description.client. And all of these packages allow us to use Swagger to generate API documentation and descriptions within our application. In step two, we're configuring the Swagger in the application. So at the top, we add our ASP.NET Core Builder, which is a part of our ASP.NET Core ASP application builder. And then we also are using dependency injection here. So we add an extension library that allows us to use dependency injection, which allows us to insert the Swagger documentation into our app. The first line is the web application create builder, which allows us to build out all the services that we need for our app. So we set a variable called builder to the output of that method. And then we're just adding our controllers and our endpoints in the next two lines. These are just general parts of the API that we're going to need to install and include. So we do that in those two lines. And then we add our Swagger tools. So you'll see builder.services.add Swagger gen. This generates all the Swagger code that we need to build out our app. Then we're going to use the app variable to build out all those components. So we set the app variable to builder.build method, and that gets us all the services that we're going to need for our app. And then as a part of that, we're going to tell our app to use Swagger in the next line. That's what that method does. The app.use Swagger, it tells the application to use all the Swagger services. And then the app.use Swagger UI is how the code is generated. The documentation is generated so that when you hit the URL at /swagger/v1/swagger.json, you'll get all of the API generated documentation for your specific app. And this is how Swagger helps save a lot of time, because you don't have to generate the documentation yourself. Swagger will do the work for you. And then finally, we map all of our controllers. This is another ASP.NET method that maps all the controllers that we need for the app. Finally, at the bottom, we'll just run the application using app.run. I'm going to come back to this code in a little bit. That takes care of step two. In step three, we define the ASP specification, and for that we're using a file in the controllers folder called user controllers. This just sets up our route. So when we use these keywords, API controller and the route keyword, this tells the application when the user hits ASP/ and then a controller name, then they will get a specific output. They'll get a result back. And that's what we're defining here. So now we're saying the route is a get route. So remember our CRUD operations, this retrieves information. This is what the output will be. So it produces a JSON file. And the result of this action is that we're going to create a user object. We're going to get the user by the ID. This is what we're passing in to our function. And what this does is retrieves that user by the ID. We return a OK. In other words, we return the result that it actually was successful. Now that user object is defined here above. So in this file, we're essentially creating a class called user, and it has an int ID and a string name. And this is the whole of the user object. So when we call this controller at this route and we retrieve the user, we're going to place it in this object and we're going to output it as JSON. This is actually the body of our current application because the application has to do work. So we have to define that somewhere, and we've defined it in usercontroller.cs. That's step 3. Step 4, we're going to use now nswag to generate some API client information. So we're going to go to client generator. This file is a utility file, and by that I mean this is a file that we use to do work. It's not going to be a core part of our application, and you'll see how that works in a moment. So you can see in this file, we're using the nswag libraries. We use nswag as a general library, and then the code generation.c#, which is a specific library that's used to generate code for .NET C# applications. We declare a class called client generator, and in there we have an async method called generate client, which does all the work. In the first few lines, we're defining the HTTP client, which means that this is a function that's going to use the HTTP protocol to do its work. We set a variable called swagger.json, which is going to be retrieved at that URL, http localhost 5000/swagger/v1/swagger. So the user can browse to that location and it will generate the documentation at that location. Then we set another variable called document to generate the OpenAPI documentation using a JSON format. And then the next setting of our settings is the variable that we're going to use to set the namespace and generate the documentation that we need using that namespace. The last 3 lines are where the work gets done. So we use the new C# client generator, which is a part of the nswag library. We pass in the document that we created above and any settings that we wanted to set, which we did in that variable. So we're essentially in this method, we're calling the library using the settings where we set the class name and the C# generator settings. There's other settings we can set, but we're just going to pass in those 2 settings for this one. And then in the next line, we set the code variable to the generate file method, which is also a part of the nswag library. And then we write it all out to generated API client.cs file. What this code will do is when it's run, it will actually generate a new C# file that then our application can use to show the documentation that the user needs for the API that we have set in our application. So Swagger does all that work for you. And every time you change your API or update your API, you can call this method, and this method will regenerate all your documentation for you using Swagger. So that's what this does. We haven't called it yet, you'll notice. We've just written the file so that we can call it from our main application. Now in step 5, we're just going to set our class names. So you'll see here I've got October API client and my client namespace, and we can update those to whatever we want. So again, this is in the generate client method. We can set these namespaces in the class name to whatever we want for our application. And this is just an opportunity to make those modifications to match our app. Okay, now let's look at step 6, integrate the generated client. So when we go back to our program.cs file, you can see here we're declaring a HTTP client variable, and we're going to set that to a internal method, HTTP client, which allows us to make HTTP calls. And then we're setting the client to our custom API client namespace at the domain localhost with a port number of 5000. And we're passing in our HTTP client. This allows us to make HTTP calls using the custom client that we generated using Swagger. Now notice here I have commented out a asynchronous task, and what this task does is actually calls that client generator code that we created in the previous step. I've commented that out because we only want to run that when we update or create a new API, because what it does is it takes the API that we're creating and generates the documentation. So I've already run this, and you can see that we have a generated API client.cs file that Swagger produced for us. I'm not going to get into that file because it's very complicated and not relevant for our current purposes. But what we do is we run that client generator.generate client method. It generates our generated API client.cs file, and then we can use that file to generate our API documentation. So because I've already created that file, I've commented out that block of code, and now I'm creating this next block of code with HTTP client to make calls to our custom client generated file that we created earlier. Now notice also at the top I have to use the namespace that I set. My client namespace is the one that I set in my client generator.cs file, and that has to be consistent. So whatever namespace I used in that file, I also want to make sure that I use here in my application. That's step 6. And that's it for this program. That's how we use Swagger to generate API documentation. In ASP.NET Core, middleware performs a critical role in managing every request. Poorly designed middleware can slow down your entire app. So how do you ensure your middleware is both efficient and lightweight, preventing unnecessary delays in performance? In this video, we will identify best practices for designing middleware for performance in ASP.NET Core. Since all requests go through the middleware pipeline, poorly designed middleware can delay everything. Optimizing it keeps requests moving fast, leading to a more responsive app. Let's explore the best practices for designing middleware for performance. First, ensure that the middleware is lightweight and capable of managing tasks quickly and efficiently. Middleware should be responsible for simple operations like logging, routing, or minor validation. For more complex or resource-intensive operations, it's better to delegate those tasks to a background service. This approach allows the middleware to swiftly process incoming requests without becoming a bottleneck, thus ensuring that your server remains responsive and performs optimally. For example, if the middleware needs to check user permissions from a large database, it would be better to delegate this task to a background service, allowing the middleware to process requests without delay. Next, short-circuit the pipeline. Not every request needs to go through the entire pipeline. For instance, if a request fails an authentication check, you can stop further processing and return a response immediately. This prevents unnecessary steps like logging or caching from running, saving time and resources. You can also minimize exception handling and overhead. Handling exceptions in every middleware component can slow down your app. Instead, centralize error handling in one place. This reduces overhead by avoiding repetitive error handling and keeps performance high. Imagine having one global error handling middleware that catches exceptions across the entire pipeline rather than wrapping each component individually. This is a much more efficient process that reduces duplicate work. Also, try to use asynchronous operations as much as possible. Middleware often waits for tasks to finish, like calls to databases or APIs. By using asynchronous operations, middleware can continue handling other requests while waiting for tasks to finish. This is useful under heavy traffic, as asynchronous calls keep the server busy without waiting for a single task to complete. If your middleware is waiting for data from an external service, asynchronous calls let it manage other requests while waiting for that data. Along with handling tasks efficiently, be sure to reuse middleware where possible. Instead of creating custom middleware for everything, use built-in components from ASP.NET Core like compression or logging. These components are already optimized for performance, saving development time and assuring efficiency. For example, you can use the response compression middleware built into ASP.NET Core rather than building a custom solution for compressing responses. This would save development time and ensure better performance. After reusing built-in middleware, control its order. The order in which middleware operates affects performance. For example, placing authentication early in the pipeline ensures that invalid requests are stopped before reaching more resource-intensive middleware like logging. Handling critical tasks first reduces unnecessary processing and improves efficiency. This way, non-authorized users don't trigger additional middleware that isn't needed. Finally, avoid excessive middleware. Using too many middleware components can slow things down, so combine tasks where possible and only include what's necessary. A single middleware that manages both requests and response logging is more efficient than having two separate components. This reduces the number of steps in the pipeline and keeps your application running smoothly. In this video, you learned about how to design middleware in ASP.NET Core for better performance. We explored key practices like keeping middleware lightweight, using asynchronous operations, and optimizing the order of middleware for faster request handling. With these strategies, you can ensure your app runs efficiently and responds quickly to user requests. Every app gets countless requests daily, but malicious attempts to exploit vulnerabilities could be hidden among them. Without strong security measures, even a single breach can compromise your entire system. Security is not just about preventing attacks, it's about safeguarding your app, users, and data from those seeking harm. In this video, we will identify best practices for securing middleware in ASP.NET Core. Middleware controls the flow of requests in your app. If it's not secure, attackers can exploit vulnerabilities to steal data or damage your system. Securing middleware ensures only trusted requests get through, protecting your app from risks. Now that we understand why middleware security is essential, let's review some practical best practices for keeping your middleware safe and secure. The first thing you should do is validate and sanitize inputs. Attackers often try to inject harmful data into requests like malicious scripts or commands. Validating ensures the data is properly formatted, and sanitizing removes anything dangerous. For instance, when you're handling user input, cleaning it ensures malicious scripts won't harm your app. Next, it's important to enforce HTTPS for secure communications. HTTPS encrypts data sent between your app and the user, making it harder for attackers to intercept sensitive information. So when users log in, HTTPS ensures their passwords and personal details stay protected. Once you're sure you have enforced HTTPS, cookies and session data also need to be secured. By setting cookies with attributes like HTTP only, you ensure that scripts running in the browser can't access them. This reduces the risk of cross-site scripting attacks where malicious scripts attempt to steal session cookies and impersonate users. Then, handling authentication and authorization checks early in the middleware pipeline is important. This way, unauthorized users are stopped before they can access restricted areas of your app. If someone tries to access a dashboard without proper credentials, the request is blocked right at the start, keeping your app secure and efficient. Since you've handled authentication early on, logging security events is essential for tracking suspicious activity. However, it's important not to log sensitive details like passwords. If a user fails to log in multiple times, you might want to track the time and IP address of the attempts without storing their password. This helps you detect potential threats while protecting private data. Finally, errors should be handled in a way that doesn't expose too much information to users. Instead of showing technical error details which could give attackers insight into your app, log those details for your team and present users with a simple generic message like something went wrong. This keeps your system safe while your team can troubleshoot the issue behind the scenes. In this video, you learned key practices for securing middleware in ASP.NET Core. We covered input validation, enforcing HTTPS, and securing cookies and session data. You also saw how to handle authentication early, log security events carefully, and manage errors without exposing sensitive information. Following these best practices helps protect your app and its users from potential threats. In this lab, we're going to be securing our ASP.NET application using middleware. This is all going to be kind of simulated, but it'll give us an idea of how we can secure an ASP.NET application using various middleware components. In step 1, we set up our application. In step 2, we're going to do some configuration options. We're going to set up the application to use HTTP only. In a real application, we'd want to use HTTPS, but this just shows us how we can configure our web server with a variety of options. You'll see once we set our builder variable to the result of the create builder method for our web application, we'll get the ability to build out a bunch of different features. And the first thing we're going to add here is our web server configuration. So you'll see builder.webhost.configure Kestrel. Kestrel is the underlying ASP.NET lightweight web server that we're going to use. So we're just going to set some options here. So you'll see the options variable, and we're going to tell the application to just listen on the local host at the port 5294. That's an HTTP port. So we're just telling the web server to listen on that port only. And then once we've set that option for our web server, then we create an app variable and we set it to the results of the build method for our web builder. And now we're kind of ready to go. We've got our application at the bottom of this file. We'll talk about this code later. At the bottom of this file, we just set app.run, and this allows us to run the application and all the middleware that we're going to build out here in a moment. So that's just the basic fundamentals of our app that we're setting at the top of the file. Now in step 3, we set up our first middleware security component. The app.use async context next is the middleware piece that we're going to be adding, and then the middleware itself is anything that runs between that app.use block. The context next is what tells the application once this middleware has run, move on to the next one and attempt to run that one. So we'll see a number of these strung together, and each one is a security check, and it will look for something very specific in our request that we're making to the API. So the first line, if context.requestQuery, is checking for the query string. It's looking at that URL that you type into your web browser's address bar, and it's looking for some very specific things. So in this case, it's looking for the word secure in the query string, and it's checking if the value is set to true or not. We're telling it here if it's not true, we're going to respond with a status code of 400, and we're going to write the response out to the web browser that says simulated HTTPS required, which means this is not a secure connection. That's what the exclamation point equals means, not true, so it's not secure. So we're going to tell the user this is not a secure connection. Again, this is simulated in a real world example. We would want to do something a little bit more substantial, like not allow the user to continue on and use the application. Then we're setting an await next, which just means we're going to wait for a while before we run the next block of code. In step 2, we have another app use, which is another piece of middleware. We're doing the same thing here again. In this block, we're going to set the input variable to a request, and the request is input. And we're checking using a method called isValidInput, and we're going to check whatever is passed into that input variable in the query string. So we're actually going to put in the query string a set of code or something that's not valid, and we're going to check it using this method. In this method, down here at the bottom, static bool isValidInput, we're just checking to see if the input, you can see in this line input.all, is the character that we passed in, a letter or a digit, and does it not contain the script tag. So you can see in a real world example, we would want to prevent people from passing in code in the query string, which could be malicious or be malware. It could be a virus. So we want to filter that out. So what this middleware is doing is using this method call to check to see that that input that we're passing in the query string in the browser address bar is actually valid. Again, in a real world example, we would want to make this very robust and check for a number of things. But in this simple example, we're just checking to see, is the input null or empty? Does it contain a letter or a digit? And does it not contain script? If all those are true, then we'll return true. If not, then we'll return false. And in this middleware, we're checking for true or false. If it's not true, the exclamation point means that the valid input is false. Then we're going to write out, send a status code of 400, which means that the user can't proceed, and we're telling the user in the context.response.writeAsync that it's invalid input. That's our second piece of middleware. In step 3, we're writing another middleware that's going to check for authorization, and here we're looking for the path unauthorized, and that's in the query string again. So in the browser URL, it might be localhost:500/unauthorized. If we get that in our query string, we're going to just respond back to the user with await context response.writeAsync unauthorized access, and then return. Our await.next gives us a slight pause, and then we move on to the next using statement. Similarly to the other middleware that we just wrote, we're in this block, we're looking for authentication. So the block above that was authorization. This is now authentication. We're looking for the keyword authenticated and whether that's set to true. This is again manipulated, so we'll just set it to true or false in our query string. If it's set to true, then we'll move on and the user can continue on with the code. If it's set to false, so this is if not is authenticated, that means if is authenticated is false, then we're going to respond with a 403, which is a security response status code. And we're going to tell the user that their access is denied and just move on. We're not going to allow them to proceed there. If it is true, we're going to send a cookie. That's a secure cookie. It has the data secure data, and the options are HTTP only equals true and secure equals true, and then we'll allow the user to go on. This is in middleware that isn't doing a whole lot of real world work, but in the real world we would make this more robust, and you can see that there's options here to allow the user to do certain things once they have a secure connection to the web server. The final middleware that we're going to be using in step 5 is asynchronous processing. So here we have await task.delay 100. So we're going to just delay the task for just a millisecond. And then we're going to write out, we processed the response asynchronously, which we've done using that task.delay. It just simulates an asynchronous test. So the middleware process is it starts here at the top and just goes from middleware to middleware, looking for all of these conditions. If the conditions are true, it allows the user to continue to proceed. If not, then it stops and checks for the next security feature. And you can see how we can use all of these middleware options to build a really secure ASP.NET site by checking for various aspects of the query string to make sure that nothing is going wrong and that the user is a valid user and is able to use the website. Imagine you're sitting down to write a complex API. There are multiple endpoints, middleware to manage, and edge cases to consider. Now imagine you have an AI-powered assistant right beside you, offering real-time suggestions, code snippets, and debugging tips. That's the power of Microsoft Copilot. Microsoft Copilot is an AI-powered tool designed to assist developers by generating code, suggesting improvements, and even helping debug in real time. It can be used as a standalone app, or it can be seamlessly integrated into Visual Studio and GitHub. It supports languages and frameworks that backend developers like you work with daily, such as .NET, JavaScript, and more. The beauty of Copilot lies in its ability to take on repetitive tasks, allowing you to focus on solving more complex problems. It generates relevant code snippets based on your input, offers context-aware suggestions to improve efficiency, and helps catch bugs early in the process. Let's start with code generation. Say you're developing a new API route. Copilot can automatically generate the scaffolding for this route, saving you time and reducing the chance of errors. You can describe your project to Copilot and it will create the routes you need for your project. If you have Copilot integrated into your development tools, you can start typing a route for user authentication and Copilot will complete the rest based on best practices. This means you spend less time on boilerplate code and more time focusing on the unique logic that makes your API special. Next, let's talk about code suggestions. As you write code, you can paste code blocks as a part of your prompt and ask Copilot to help you find ways to improve your code. When Copilot is integrated into your IDE, it doesn't just passively watch. It actively suggests ways to make your code better. In either case, it might recommend a more efficient way to handle HTTP requests or suggest a library to streamline database interactions. Finally, debugging becomes much smoother with Copilot's assistance. When you make Copilot aware of your code and the bugs you find during testing, Copilot identifies potential issues, offering solutions or highlighting the exact lines of code that need attention. No more searching through endless documentation or stack traces. Copilot's influence spans the entire API development process. From the moment you start coding to when you're testing and refining, Copilot is there, making sure every piece of your API is efficient, clean, and reliable. Ultimately, Microsoft Copilot removes much of the frustration from coding, allowing you to work faster and more efficiently. Whether you're a seasoned developer or just starting your career, it's like having an expert coding assistant by your side, ensuring that your APIs are well written and fully optimized. In the upcoming lessons, we'll dive deeper into how Copilot can assist with writing API code, debugging, and managing middleware. But for now, remember, Copilot is here to help you create better APIs with less effort. It gives you more time to focus on what really matters, solving problems and delivering value. Imagine integrating AI into your development environment, helping you code faster with fewer mistakes. This is what Microsoft Copilot offers. In this video, we will list the advantages of using Copilot in development. Copilot boosts productivity by suggesting code snippets and automating repetitive tasks. For example, when creating a function in C#, Copilot can suggest the function structure, parameters, and return types, saving you time and letting you focus on more complex work. While Copilot helps you work faster, it also improves the quality of your code by helping you reduce coding errors. Copilot helps reduce coding errors by suggesting best practices and reliable coding patterns. If you're handling user input or API requests, you can use Copilot to recommend proper error handling patterns, preventing common mistakes in your code. In addition to reducing errors, Copilot enhances your learning by introducing new coding techniques. If you're unfamiliar with a feature or library, Copilot can suggest relevant code snippets and explanations. So if you're new to a specific .NET feature, ask Copilot for code suggestions and instructions on how to use it. Another benefit is that Copilot can assist in making code more readable and maintainable, enhancing team collaboration. Furthermore, Copilot can help write comments and documentation, ensuring the code is well documented and easier for team members to understand. Now that we've explored the main benefits, let's examine specific scenarios where Copilot can be particularly helpful. Copilot is helpful when working on repetitive tasks like writing test cases or integrating external APIs. One common use case could be setting up test cases. Test cases are specific scenarios designed to check if a piece of code works correctly, and Copilot can be used to generate the structure of test cases for you. For example, it might create a basic test to verify if a function returns the expected result, allowing you to focus on the specifics of the test logic. Another use case for Copilot would be integrating with an external API like Azure. Copilot can suggest the required configurations and API calls, saving time and effort. For example, when setting up an Azure storage account, Copilot can help generate the necessary API calls to upload files, configure authentication using Azure Active Directory, and manage access permissions. This way you can quickly implement key features like secure file storage without manually writing all the boilerplate code. In this video, you learned how Microsoft Copilot boosts productivity by automating tasks, reducing errors, and suggesting best practices. We covered how it helps generate code, handle errors, and improve readability, making development faster and more efficient. Whether you're working on test cases, API integrations, or learning new techniques, Copilot streamlines your workflow and enhances team collaboration.
There are lots of ways to work with Copilot. You can use Copilot in your favorite apps like Excel and Word, and there's even a Visual Studio Code extension that puts Copilot right in your code editor. For the purpose of this course, however, we're going to focus on how to use chat-based versions of Copilot from your desktop or laptop. In this video, we use Microsoft Copilot to generate API code snippets. There are 3 ways you can use these interfaces. The first is directly from your desktop. So you can use the Copilot app here, and you'll see it bring up this nifty chat interface. Now I can create a new chat here by clicking that little clock icon and then clicking new here, or I could access one of my old conversations. Let's go ahead and start a new conversation, and I can ask it something like, what is the difference between minimal APIs and controller-based APIs in .NET? And it will proceed to give us an answer. You can see here, structure, flexibility, use case, performance, simplicity. So it's addressing all of these different issues. So you can use this interface that is the built-in desktop interface. You can also go to copilot.microsoft.com, which can also be accessed right here if you're using Windows 11. This will take me right to copilot.microsoft.com. This is going to look really familiar because it's the exact same interface. You can see here is that conversation we were just having. So this can be really handy. But my absolute favorite way to use Copilot is to use the sidebar here. So you can click Copilot right up there in the top right corner, and you can see it doesn't have anything to do with the page we were just on. We can use it on any page we want to go to, which is really handy because we can actually ask it things about that page. Now, you're going to see quite a few differences here. First off, you can ask it to make your responses more creative or precise or balanced. You can use the compose functionality up here that will actually allow you to write things like blurbs for emails, ideas, blog posts, paragraphs. So you can use this to quickly generate content for scaffolding out instead of using a tool like Lorem Ipsum. If we go back to the chat, you can also see that we have a history of our chats here. Currently, I have an empty history, but you have a really robust history feature here, unlike in the other version. You can delete old chats, for example. And if we wanted to start a new chat, we would just click down here. They call them a new topic. You can also work with extensions. So you can come here, you can do things like Instacart, Kayak, Klarna, Shop, Suno. Nothing terribly useful there for what we're going to be doing with code, but this search option is really useful. So it will essentially do web searches to try to pull in additional information when it is chatting with you. Sometimes this is useful, sometimes it's not. If you find it is pulling information you don't want, sometimes you want to turn this off, but know that you have to turn this off before you've started your chat. All right, let's go ahead and try to use the chat interface to build a new CRUD API using .NET to work with users. So we will just ask it to give me code for a CRUD API. And you can see here it's thinking and generating our response, saying what a CRUD API is, and now it says it's going to use Node.js, Express, and MongoDB. Now the problem here is those are all JavaScript. So unless you know JavaScript, this is probably going to make no sense to you, and it is not at all what we wanted. This is a great time to talk about context. Now, context is the information that the artificial intelligence has access to. Now, it has access to a bunch of general context about the world, but what it does not have direct context about is what is in your head. So just like working with a person, you need to make sure to communicate what you need from the artificial intelligence. You want to think about things like, what are you trying to build? What are the specific requirements? Is there surrounding information? Do you have design parameters in mind? Do you already know how to solve part of the problem or how you would approach it? Sometimes it's useful to even ask Copilot to ask clarifying questions to get the information it needs. So I'm going to say that's not quite what I was looking for. What else do you need to know about the API to get me what I want? So the programming language, that's probably a good one. So we will say we are using C#, ASP.NET Core, minimal APIs, no controllers. The database, we won't use a database. We are using a list. Endpoints. The endpoints should be built around user objects. Users have a username and a user age. Authentication, no need for auth, and no additional features. I think that will get it all the information it needs. It knows what program we're using. It knows what framework we're using. It knows that we are trying to use minimal APIs instead of the older controller-based structures, and we won't be using a database. We're using a list. The endpoint should be built around the user object, and users have a username and user age. So we've defined our class there. No auth, no additional features. So now let's see if it can give us what we want. And this is already looking much better. So there's a command for creating an application. It's telling us here's all of the dependencies we need to pull in. Then you can see here it's using minimal APIs. It's using a builder. It's using the app. It's got a list of users in it, pre-populated it. I love that. It's returning users. It's getting a user by username. It's using link down here, this first or default. Maybe you've never seen that before. So this is a great time you could ask Copilot, hey, what does this piece of code mean? I can also see there's a ternary statement here where they're sort of using this compact format for writing an if statement. Maybe you don't understand that. So you could copy that line of code and say, hey, Copilot, please explain to me how this works. We can scroll down here and you'll see here's our user, here's all of our information. And I think that's actually all we need. So let's go ahead and copy this, and I will come down and I will open Visual Studio. And now you can see here that I had previously created a project for us. This is just an empty web project. Once again, I can replace all of this code with our new code. Now, before I run any of this, I am going to read through it because you should never run code that you don't understand. It can be really dangerous. In a case like this, it's not terribly risky. It shouldn't be doing anything that out there. You can see here it's returning results. It's looking at this list using the first or default here. It's all pretty much the same. It doesn't look like it's accessing our file system or anything weird. This seems pretty safe. And it looks in general like it's doing what we want. I see one minor thing down here. We get a warning for username where it looks like it probably wants us to add required. And that is correct. So you can see there that Copilot may not have known about some of the more modern ways to work with those required in a username. So scrolling down here, looking at the code, you can see that it's using some link statements to do this first or default, to check for the username equals username. So this is how it's finding a specific user. And then it checks to make sure that the user's not null, that returns a user. And if not, it returns not found. You can see we have a post here where we add a new user. This all looks right. We have a put where it's going to update a new user if the user's not null when it looks for it, just sort of like it did before. Yeah, I think this all looks pretty good. We also have the delete there. The one thing I see down here is we have a warning, and it looks like it wants us to add required to this, which I can absolutely do. And that's a spot where maybe Copilot just didn't quite see that it should add required there to be technically correct. So we'll go ahead and save that, and we can start our server. So let's go ahead and run down here and say .NET. I want watch run. And now we're starting our server. Now, while that is happening, we can actually go back over because I would like to be able to test this. And so let's say, please make me an HTTP file that I can use to test all of these API routes. And again, it's thinking, and you should see it start to kick out some routes. And so we're getting all users. We're getting a user by username. You can see here that it's creating a user. It's updating user to user 3. And then we have deleting a user here. So let's go ahead and copy that code. That looks like exactly what I wanted. And I can create a new file here. Let's call this requests.http. And I can put that. Oops, I didn't actually copy it. So let's go back and we can copy that and then try that one more time. There we go. And that looks like it's working. So our server should be running. The one thing to check here is this is port 5000. It didn't know what port we were going to be running on. So I can do a multiple select here using Control D, and we'll replace all those 5000s with 5183. Go ahead and save that again. And now we should be able to run a request. And we'll see here, hey, there's a couple of users. Let's get a user by user ID. That looks like it works. We can create a new user. So let's create user 23, or user 3, sorry. User 3 works with an age of 28. We can update them. So we want to say user 3 is 29. We'll send that request. We can go back and check our get all to make sure that's actually correct. And that did make that change. Looks like we have a delete down here, so we can delete user 3. Let's send that request, and that looks like it worked. And finally, let's go get our users one more time, and it looks like all of that works. So now we have created an API that we set out to create, and we barely had to write any code. I think I wrote required was the only actual piece of code I wrote. I just copied and pasted this from Copilot. Now, small, well-defined projects like this are where Copilot really shines. As you start working with larger projects, especially those that span multiple files, it can become much more difficult. And that's where I do recommend using a tool like GitHub Copilot directly in Visual Studio Code. The key thing to remember is always to give Copilot the context it needs to solve your problem. Let's explore how to enhance our code using AI tools like Copilot. By leveraging its suggestions, we can handle common challenges, improve our API, and streamline our workflow. Whether you're familiar with AI-assisted coding or just getting started, this session will demonstrate practical ways to make your development process more efficient. So in this video, we will improve API code using Copilot suggestions. For a starting point, we're going to use our blog CRUD API. As a reminder, it's just a simple CRUD API that works with blogs, which have a title and a body. It stores the blogs in a simple list, and because of this, we have to do all of this error checking and encounter weird behaviors, like the blog's IDs being determined by the order in which the blogs are added to the list, which isn't really ideal. It would be much more useful if we stored this in a different way. So that's the first thing I want to try to use Copilot for here. So let's go ahead and open up Copilot in Edge. Again, you come over here to Copilot, and if it's not already open, you can just pop it open there. And so what I'm going to say here is I don't like the way that I am currently storing the blogs in this code. Storing them in a list causes me to continually worry about out of bounds errors, and having the IDs tied to the location in the list seems too restrictive. What other options could I explore? And yes, I absolutely know there are some typos in there, but I promise you that typos don't seem to make much of a difference at all. The last thing I will do is I will copy this code, then go back and paste that in. I do seem to find better results when you put in your request and then your code rather than vice versa. That may be the way the model was trained, might just be sort of anecdotal, but it does seem to be my experience that this is more effective. So we will go ahead and submit this and see what we get from the LLM. All right, and this is actually what I was hoping for. It has recommended that we use a dictionary. So a dictionary is another data type where you pass in a key and then the blog. In this case, the int key will be the ID that we will assign them. So you can see here we have 1 with our blog, 2 with our other blog. So this way we can arbitrarily add a blog at, say, ID 199. We don't have to have 199 other blogs in there. If we scroll down, it might have recommended other methods. So you can see here, yes, database was another thing it recommended. And you could absolutely implement a database here. It's just a little bit beyond what we're going to cover in this particular part of the curriculum. So we will just keep scrolling and see if there's anything else. Oh, and in-memory cache. So this is another option we could use here. So this is another way in memory to store the data, which does give us some advantages. It acts a little bit more like a database, but we still have the limitations of it being in memory. If you find that it is generating more than you need, you can ask it to be a little more terse. That is something you can totally do in a request like this. You can say, please answer me briefly, or please answer me in 500 words or less, or some other stipulation of exactly how you want it to answer you. So let's go ahead and take this code here. I think this is pretty good. Now, we have two options here. The first option would be to just try to cut out the parts of the code that we want to replace in our original code. But the problem here is it's made changes in a lot of places. It changed the way we're storing the data. It changed the way we're accessing the data. So we'd have to probably make, I don't know, 5, 6, 7, 8 changes here. So I find it is safer to just copy all of this. Then we can see here that it did not include our class definition. So we're going to need to make sure not to replace that. And we're also going to need to make sure not to replace our using statements. So let's come in here, and we actually don't have using statements. We have this starting with the blogs, but it looks like I don't think it included builder and app, and we also wanted to have our blog. Make sure it didn't lose the app.run too, and it looks like it did. So let's make sure to add that back in, and that should be okay. So it's always important to check the output. That is a mild form of what is known as a hallucination. So that is when the AI sort of gives you something that is confident that it looks like is correct, but it's actually not quite. It had actually pulled parts of our code out, and that's something you really need to be careful of when you're copying over whole bits of code like that. If you're using version control, that would have been a fabulous time to go ahead and save a version of your code before you make a big code change like that. And I would definitely recommend that anytime you're making a change like this. All right, so let's go ahead and look at this response here. We can see here that we have this dictionary. If you're not familiar with dictionaries, this would be a great time to go to Copilot and say, hey, explain to me this particular dictionary. But essentially, a dictionary is just another data structure that allows you to map a key and a value together. So you can access the value 1 will return this blog, and the value 2 will access this blog. It's sort of like we map paths to functions. Same sort of idea. Dictionaries are also known as hash maps. So you can see here, blogs is the same. It looks like we've got blogs.id. It's taking an ID again. And then we try to get the value. And then if it is there, we return the blog. And if not, we don't return anything. Then you can see here, we add in a new ID for blogs.keys.max. And so this is interesting. It actually did not let the user pass in an ID. And that's something we might want to go back to the Copilot for and say, hey, can you also make it so that they pass in an ID as well as a blog so that we are assigning it as a particular ID? Then you'd need to think about the logic of what happens if there's already an ID that has a blog that matches. So you might be overwriting something and then it's sort of acting more like a put. So there's some different logic there. And so it looks like this is actually a pretty good way to handle this for now. We can go ahead and see here that they are taking the blogs at this new ID and then adding that blog. And if we keep going down, you can see we have a delete method here, then a blogs.removes at the ID. That looks like what we want. And then blogs. If it contains that ID, then go ahead and set the blog at that ID to the blog, otherwise return results, and else return not found. That looks correct at a surface level. And so we can actually go through. And now the nice thing about the way it made changes to our code is it didn't change the API. And so the API, again, is that sort of interface that the client would use to access our blog. So had we added an ID in here and made it so that the client could set that ID, all of a sudden that interface has changed. So our request would not work. But in theory, all of our requests should work here. So let's go ahead and open up a terminal and say .NET watch run, watch fun, even better. Okay, and so now the other thing we'll need to do is change our port to whatever this new port is. We'll see that when it comes around. And it looks like the new port is 5099. And now there's one last thing. I don't know if you noticed when it flashed there real quick. So you can see can't locate. We got a 404 on our root route, and it looks like we lost our root route. So I am going to go ahead and add that back in because I want it to maintain there. And so we will say that was function that returned I am root. So now our root route is back. So we should be able to come over here and send a request to our root route. And we got a 404 not found, and that's because we haven't reset our server. So let's try that again, and there's a 200 OK. All right, so now let's see if we can get our blogs. And again, we should have 2 blogs here. So let's get those. That works. Looks just like it did before. Let's get the first blog. Now we're getting blogs not found. And again, before this always worked because our first blog was ID 0. Now our blogs are starting at ID 1 and 2. So let's go ahead and get 1. And then we can send that request, and there's that blog, and we can try 2 and send that request, and that also works. But if I try 3, I should get back a 404. Perfect. That's exactly what we wanted. I can post a blog. Let's try that. Post seems to have worked. I will come down here and get all my blogs again. Totally looks like it worked. And I can come here and then I will put, and we will try the blog at 1. Let's go ahead and send that request. So I changed that to my third blog, so we should see 2 third blogs. And so that also works. So this looks like we were able to successfully have GPT make a significant modification to the way our API was working, and it still was able to do it without breaking our interface. Excellent. You could use a method like this, again, to have it implement a proper database for you. Those are totally within the realm of possibilities. Okay, here's another thing I'd like to do. Let's go ahead and go back to our chat assistant, and we can say, I would like to modify the get blogs route to take in a search query parameter. And now I'm going to try to get it to return me just this piece of code so that I don't have to replace all of the code, because that will prevent me from having to go back and make changes like I did before. It actually quite commonly will remove code or make small changes, and it can be very hard to catch those. It's best to isolate it as much as you can. So in this case, we have a really nice modular part of our code that we're trying to get it to touch. So I wanted to take in a search query parameter. This parameter should be used to filter for blog posts that contain the search term in the title or body. Again, bad typing and all, goes right through. So you can see we have the blogs route here. It's taking in a string for search, but it thinks it's using a memcache, and that's because I didn't tell it which method we were going to use. So let's go ahead and tweak this to say, please use the dictionary method to filter. That is the code that I ended up using. There we go. That looks much better. So now it's going to take in a search string, and then it's going to filter out the blog. So blogs.values.as enumerable. So that is turning the blogs into something that it can iterate over. And then it's going to search for is null or empty in the search. So that is checking to see if it didn't find a blog. So if it's not null or empty, that's what it's saying. So it's a double negative here. So if it found something, it's going to go ahead and filter the blogs where the blog and title and blog and body contained those. And then it's going to go ahead and return OK with the filtered blogs. Now just checking real quick that this logic does work. It's starting out grabbing our filtered blogs and then returning them if this if statement isn't returned. I think this will work, and the best way to figure out is to put it into some code. Doesn't say anything down here that we need to worry about, so let's go ahead and come up here and replace our logs route. Excellent, and I do want to restart, our server. Now, if I come over to our requests, we should see here, I can make a request for my blogs, and I should get back blogs again. That looks great, exactly what I wanted. And then I will try to put in a query string here. So $Q, I believe was the parameter, search. Search equals, and let's look for first. And there we go, that successfully filtered. So let's try second here, just to make sure it wasn't a fluke. And second totally works. And now let's look for post, because I believe they both had post, and post works. So it looks like our filter function is correctly working here. This is excellent. Thanks to Copilot, we've been able to modify the way our API stores blog data into something more manageable. We've been able to add search functionality to our get blogs route. This has saved us time writing code and even introduced us to new coding concepts and tools like dictionaries and using LINQ to filter lists and dictionaries. Having AI chat tools write code is really useful, but having them fix code can be an absolute lifesaver. The new AI tools are so good at fixing bugs that they are actually causing a huge drop in traffic for traditional question and answer sites that programmers previously used to find fixes for bugs. So in this video, we use Microsoft Copilot to detect and fix bugs in API code. To fix a bug with AI, you need to give it the relevant code. The more context you provide, the better the AI can understand the problem and suggest a fix. It's like describing a problem to a friend. The more details you give, the easier it is for them to help. Let's go through the process of having Copilot help us sort out some bugs. I've got a simple console app here, and I've created code, and it has a bunch of bugs in it. The first thing I want to do here is show you that we have these red squiggles. So this is an indication that there is a bug. So the first thing I'm going to do is, so I have a bug in this switch statement. Let me come up here and copy and paste that, and then go over to our chat, and let's see. I am having issues with my code, and I'm getting this error. What is going on? So this is one of the things you can try, is just letting it know about a bug you're having, and it can probably help you explain the concepts you're seeing. So if we look here, it's falling through from one case to another without an explicit break, return, or go to. So to fix this, you need to ensure that each case block ends with a break, return, or go to statement. Okay, so they had this code here, and this one has a break, and this one doesn't, so they add a break, and that fixes it. So that is my problem in this first one, is we're missing a break. So we can come down here, add that in, and now we have fixed that line of code. No more red squiggles. So let's go ahead and .NET run to see what the code does now. We are getting some index out of range exception. And so if we look at our code, we're not getting any red squiggles. We are getting a yellow squiggle down here, which is typically just a warning telling us that the code is valid, but probably not what we want. So we'll go ahead and handle that one in a minute. The first thing to figure out is this index out of range exception. It looks like that happened on line 24. So it's in our loop here. So I might try to grab this line of code and come over to my Copilot and say, I am getting an error with this line of code. What is wrong? And now you see here that it actually has some guesses. So it says, okay, this is an index out of range problem. And so it looks like it might be a problem with our larger code. So it probably would have been smarter to grab this whole chunk here. Now I wanted to do that to demonstrate that it's always useful to grab all of the relevant code, because in this case, it looks like it's not a problem with this line of code, even though that's the one that was throwing an error. It's a problem with this entire loop. So if we grab this code and pop back over, and I can say, this is my code. Paste that in there. Then let's see what it has to say. So it runs one iteration too many, and here's the fixed code. So we had a less than or equal to instead of a less than sign. You can see here we were using less than or equal to. We want less than. So I can copy this code. I can go back over, and if I paste this in, we should see. Okay, so now the code runs. And we can see here that we still have some issues. We have these yellow squiggles here. So I want to show you here that just by highlighting over here, we'll see assignment is conditional, expression is always constant. Did you mean to use a double equal instead of equal? So in this case, we just want a double equal. Don't always reach straight for Copilot. If you're having an issue, see what kind of information is available in your editor first. You might have some good context clues there that you can use, and if you can't still figure it out, you can go ahead and copy and paste that into Copilot and see if it can then help you solve the problem. So there is one of our issues is now solved. So let's .NET run again and see if we're still getting warnings. And that looks like all the warnings are gone now. And now looking at the rest of our code, so we loop over our numbers, 1, 2, 3, 4, 5. Something up here did 2. That's our switch statement. So it's int number equals 2, switches to 2. That makes sense. This is working. And if I look down here, I have an int a equals 5, int b equals 2. Then I take 5 divided by 2. And so 5 divided by 2 is 2. So that looks like a bug, which means we should probably take this code and pass it back over to Copilot. So let's go ahead and paste this in. And let's say I am getting the incorrect answer for 5 divided by 2 when I run this code. Okay, so when you divide two integers by each other, the result is also an integer. So what's happening here is it looks like it is performing integer division. So instead of 2, we want 2.5. So to get the result, we need to turn one of them to a double or float. Okay, so that makes sense. So what was happening was when you divide two integers, it turns the result into an integer. So an integer can't have a decimal, so it just removes it. That is the typical behavior of integers. So that was a great example of a bug that is actually the expected behavior of the code, but is something that might not actually be what you intended. So if we copy our code back over here, we can paste this in. And now let's see what we get. And now we get 5 divided by 2 is 2.5, which is what we expected. And finally, we have one last warning here. It looks like I had an extra variable that I can go ahead and get rid of. And so that is all the bugs I was looking to fix in this code. Hopefully that showed you a couple different examples of the types of bugs you might run into and how you might communicate those to Copilot. The big thing is make sure to give it the relevant code. When possible, go ahead and give it the error that you got. You can even pass it the whole piece of code. I wanted to demonstrate how to use Copilot to handle each of these bugs in isolation. But in the real world, I actually would have just grabbed all of this code, passed it to Copilot and said, hey, I have a bunch of bugs. Can you fix them for me? And now there is some risk there because sometimes it will make changes that it really shouldn't be. So watch for that. Now let's go ahead and take what we've learned here and we can go ahead and go over and work on some real code. All right, so now that we've looked at those bugs, let's go ahead and look back at our CRUD API because I know there's at least one relatively large bug in there that's actually quite sneaky and hard to catch. So let's go ahead and ask Copilot about our code. There is a bug in this code. What is it? Let's see if it can find it. And it's probably going to give us a bunch of options here. It's typically how Copilot is going to handle a problem like this. It'll say, oh, maybe you want to do this, maybe you want to do that. So let's go ahead and look here. Looks mostly correct. There's a potential bug with a map delete method. When you delete a blog post by its index, it can cause issues with subsequent requests if the index is used directly. For example, if you delete the first blog post, the indices of the remaining blog posts will shift, which can lead to unexpected behaviors. To consider fixing this, you should use a unique identifier for each blog post instead of relying on the index. Now, this is something we actually handled in an earlier video by implementing a dictionary here, which is absolutely a great idea, but that's actually not the bug I was looking for. So let's see if we can prompt it even further. Are there other bugs? And now it has honed on the issue I was looking for. And this is a big one. This is the concurrency issue. So if our application is accessed by multiple users simultaneously, if they add or delete blog posts, it's hard to know which of those requests will actually happen first. And this can cause a problem known as a race condition, essentially where one user thought they did one thing and another user thought they did another, and those changes actually overwrite each other. So maybe one updated a post and the next updated a post and it accidentally created some problem. Lists really aren't great for this. This isn't actually why you would want to use a database. But you can actually get around that to some extent by using a better concurrent data structure. So let's go ahead and see if we can get it to help us with that. How can I fix the concurrency issue? So it recommends using a concurrent dictionary, which is a great idea here. So we had already homed in earlier that we thought a dictionary would probably be better because there's some weird behaviors that aren't necessarily bugs, but just odd for users. But making it a concurrent dictionary means that we will be able to much better handle multiple users trying to do things in very rapid sequence with this dictionary. It's much safer. And so now we could take this code, copy it over into our other code, and have that problem solved. Again, I recommend implementing a database, but if you absolutely didn't want to use a database, this would be a very good way to handle that problem. So that is one bug that we've been able to knock out of this code is the concurrency problem. And now I'm sure there are other issues with the code. We don't have time here to handle all of them. So take this code, run it through Copilot, and see if it can point out any other problems, anything else you might want to implement with this code. Now that we've done some debugging in Copilot, it's worth taking some time to stop and break down how we were debugging code and explore some other common debugging techniques. In this video, we will apply Copilot-assisted debugging techniques. Let's start by remembering that providing the right level of context is key to getting good results with Copilot. Many discussions about Copilot and other AI tools begin with the idea of breaking down tasks into small pieces, which is absolutely a useful technique. However, I find that Copilot can solve my issues simply by providing it with a large chunk of code and asking it to do something more often than not without the need to decompose it into small pieces. It doesn't always work, but it's fast, and the faster you can solve an issue, the quicker you can get to the solution you need. So I have a copy of our CRUD API here, and I went ahead and reintroduced a bug. This bug is not checking to see if the ID is in the proper bounds of the list here in our blogs/ID get route. And I'm going to see if I can get Copilot to help us solve this issue. So the first thing I'm going to do is grab all of the code, copy that, go over to Copilot, and I will say there is a bug in this code. Please fix it. And now you're going to see it hones in on the index out of range issue, which is the bug we were trying to solve. So I'm going to go ahead and stop it here because we now can see that it's solving the problem just by copying our code in. And now if that doesn't work, again, you can decompose the problem. So if you were doing this in the wild, you might have your server running. So let's go ahead and kick that up. And now if we go to our request, we can make a GET request and try to get a blog out of the index. And we will see here that we get an error. And so again, I see it's on line 17. So this gives me an idea that my problem is here. I'd come, I would grab this, and I would put that in. But the thing you want to think about here is it actually isn't going to quite understand this code because it also needs the data structure you're using. So I would grab all of this code. Again, you got to make sure it has all of the context it needs. So let's go ahead and open up a new chat window. Now I'm going to type in, I have an error with this code. Please fix it, and I will paste my code in. Now, I am assuming that it will be able to solve this because it has much tighter information here. It knows exactly what we're looking for. And yep, you can see it honed in on the index out of range. So passing all of the code often works. If it doesn't, go ahead and pass in just a limited context. Then if you're still having trouble, another thing you might want to do, and you could do this in the first place, is actually add in the error you're getting. In this case, it is this must be non-negative and less than the size of the collection. So we're getting this range error. And this whole thing is a really useful piece of context you can add in. This is what's known as a stack trace. This is essentially the lines of code that we're running when your code threw an error. So you can pass all of this in. And again, sometimes you don't even need to pass in the code. You can just pass Copilot this information and it will be able to point you in the right direction. It'll say, hey, here's likely what's causing the problem. You'll look back at your code and you go, duh, that's what I was doing. And if you're really struggling, you can pass in all of your code, then pass in just the part of the code you are looking at, and then add something like, I think this is the part of the code that's causing the problem. Be a little bit careful, because if it's not actually the part of the code that's causing the problem, it will almost certainly cause Copilot to hone in on that code, and it will falsely try to say there is something wrong and agree with you. Then also add in your stack trace. And with those three pieces of information, Copilot can almost always solve your issue. Now, I want to show one last really handy thing here, and this kind of blew my mind the first time I saw it. There are times when it isn't easy to copy and paste an error. Typically, these days in VS Code, you can copy and paste, but there are times with things like type errors where for some reason it doesn't let you copy and paste. So I will go ahead and take a screenshot of what's going on. So I'll pull up the snipping tool. I will make a new snip, and I will go ahead and get the portion of code that is causing me a problem, and I will get that stack trace in there, and then I will go ahead and copy that so it is in my clipboard. Then I will go back to my browser and pull up a new Copilot, and I will just say I am having a bug with my code, and then I will paste that in, and then I can send it. Now, what's amazing here is Copilot is actually parsing the text out of this image so that it understands what is code, what is the stack trace. And you can see here, with just an image, we didn't even copy and paste in our code, and it's honing in on what the problem is. We need to do that check. So this is a final way, and again, this is really an edge case. I only do this when there's something weird and I can't copy and paste a complicated error, and you can just paste in an image, and it totally works. So these are the basic methods that I recommend for solving bugs using Copilot. Again, start with just pasting in all of your code saying I'm having a bug, and then give any specific information you can about that bug. Maybe add in the error you're getting, add in the stack trace, and maybe tell it what you're honing in on. Again, I wouldn't put in too much information the first pass, just because it often doesn't need it, and you're just wasting your time typing out a bunch of stuff that it doesn't actually need. Most of the time, one of these methods will provide a solution to your issue, and if it doesn't, we'll talk about some more advanced techniques in another video. Sometimes, for one reason or another, you just can't get Copilot to solve a bug for you. Maybe you have some really complicated state that generates over time, or it's a visual bug and you just can't communicate all of the context that Copilot needs. So in this video, we will utilize advanced debugging techniques with Copilot. Your first step in debugging should always be to provide progressively more context, but sometimes you run out of context to provide. Maybe a piece of data is causing the issue, or some external code you don't realize you should provide as context. This happens all the time. It turns out that the problem was with something that I didn't even realize could be the issue, and I'm convinced maybe it isn't the issue. In these cases, I find it best to have Copilot walk me through the process of solving the issue. And again, I want to reiterate, this is after I've already tried giving it the code, giving it an explanation of what's happening, and it just can't figure it out. In cases like this, it's like working with a tech support person for a physical problem. You're talking on the phone, and they need to take you through the debugging steps so you can arrive at the solution, but they can't actually do it for you. They can't give you the actual solution you need. One great way to start is by asking Copilot how it might be able to help you solve an issue. So I would go over to Copilot, and here I'm going to type something like, I am having a problem with this code. When I call the endpoint, I get back a 200 status for some reason, but I get an empty object. I am having trouble debugging this issue. What methods can I use to debug my code? And this is where I would go ahead and pass in my code. So this is some code I put together. This is a simple API that works with products and orders, sort of doing order reporting. There's actually no bugs in it. And now what I'm trying to demonstrate here is how to sort of force Copilot to help you think critically about code. And it turns out that it's actually pretty hard to get it to do that unless you have a really, really sticky problem, which does happen every now and then, but it's hard to get it to do it sort of artificially. So a great way to simulate that is asking it about a bug that doesn't exist in code, because that's often what it feels like when you're actually running into an issue like this. So I'm going to go ahead and feed it the code and let's see what it says. So the first thing it says is add logging statements. Usually one of the first places I go, great spot to start. Maybe for whatever reason you're sort of stuck in your head and didn't think of doing that. Using breakpoints, also awesome. So going through and actually using the debugger, writing unit tests, love it. Checking your data. So go ahead and look at your actual data. This is often what causes problems, and maybe that would prompt you to copy your data and actually give a copy of it to Copilot, in which case it would go, oh, there's a problem with your data. You can inspect your responses. That's also great. So maybe you should be making requests to your API, then looking a little bit closer at the responses, not just looking at the payload. See if there's anything else weird in there. Are there any weird headers, anything odd like that? So this is a really handy method for just sort of like breaking out of your funk. You're not quite sure where to even continue. Another technique I really like to use is ask Copilot to decompose the issue. So do something like ask it to explain how the code will run. And so this will sort of force it to walk through how your code behaves. And sometimes you'll see something and go like, oh, doy, like I was having it do this thing and it's obviously not supposed to be doing that thing. Copilot thought that was a normal behavior, but it's not actually what you intended. Sometimes too, it can also help Copilot reinforce its own internal logic, and that will help it actually see the bug you were looking for. This is similar to a process that's often called rubber ducking. And the idea is where you would have a little rubber duck on your desk or something, and you would just sort of explain your problems to this inanimate object. And through the process of explaining what it's supposed to do, what the problem is, you can sometimes come to a solution, except it's sort of like supercharged rubber ducking because it actually has the ability to talk back to you a little bit. So just explaining that problem to it can often help you get unstuck. So I'm going to go up here and I'm going to copy this and make a new request to our Copilot friend. So I will copy this and I'll make a tweak to show that methodology. Go make a new chat, paste in here. And now this time I want to, instead of say, what methods can I use to debug my code? I'm going to say, can you please walk me through the expected behavior of this code? And hit submit, and it will start walking through the behavior of that code. So we set up, we initialize, we make our endpoint maps, we have this order summary calculation. And so this is walking us through this process. And this is often where I would see in here somewhere like, oh, I wasn't supposed to be adding those together or something. It sounds silly, but it really does happen a lot. So that's another method you can use. Another great method is you can try having Copilot refactor your code for you. Now, this one sometimes doesn't feel great because sometimes this will fix your problem and you actually don't know why. It means that there was something wrong with your code and you can always, given enough time, go back and figure it out, but often you just need to move on to the next thing. Often what the AI is going to do is change your code so that it's easier to understand and think through and maybe less prone to having particular types of errors. Often refactoring code also makes your code more modular, which can make it easier to diagnose particular problems. For example, let's put in that same issue again, and we will make a new chat, and I'll go ahead and paste that in. Except this time, I'm going to type in, can you please refactor this code to make it easier to understand and maintain? I think those two things in particular, if you're having a bug, making your code more clear and more maintainable. Typically, more modular is one of the big things it's going to do there. That will often help you get past a problem. Another great thing you can learn from doing this is if the code has been completely refactored and still has the problem, it's a decent signal that either you have something deeply logically wrong or that it's something external that is causing the issue. So let's go ahead and make a new chat to show another thing we can do here along the same idea. Sometimes just adding unit tests can be really useful. Again, if you've had it sort of rewrite your code to be more modular, often this helps you do unit testing. And sometimes it will point out when you ask it to do tests that your code is hard to test, which is another great sign that maybe you need to refactor. So let's go ahead and paste that in again. And this time I'm going to say, can you please produce unit tests for this code? And so now, again, it will go through and walk us through the process of creating unit tests. And maybe we haven't already set up our unit tests, and so it'll sort of help us through that as well if we need it to actually get that structure into our code. Now, something you do want to do here is go through these and make sure that you don't have bad tests, because sort of like comments, having bad tests can cause just as many problems as having no tests. So you want to make sure they're pretty robust. But again, Copilot should be able to help you get there. And sometimes I would just make a second pass and ask it to make me some tests. Be like, what tests are missing? What are edge cases you haven't thought about? And sometimes if it starts to struggle to come up with things that are actually novel, just ignore them. But sometimes it will actually come up with things that are genuinely useful to add to your test suite. Another thing that can be really useful is have Copilot take you through the debugging process. Maybe you're not really familiar with debugging. You have touched it a little bit in this course, but tools like VS Code have amazing functionalities that we've just barely touched on in this course that you can dive into for more advanced debugging. Copilot can help you walk through some of those processes. So one of the first things that I like to do when I'm having Copilot help me debug is I might come in here and again, I would paste that code in and I would say something along the lines of, can you please add logging statements at critical junctures? This is something that normally takes a while to go add logging statements into all the different places where I think might be causing the issue. And so I can quickly have Copilot just add in a bunch of console.write lines so I can run my code and look to see if something isn't running that should be or vice versa. So this looks excellent. It's giving us logs in different places so that we can see where we're getting the generated output. And then the other thing you might want to do is if you need to really step into debugging, again, you can ask Copilot to sort of walk you through that process. I am having trouble debugging. I'm using VS Code. What editor tools can I use to debug my code? And this will start sort of walking you through some of the different functionalities that you have at your disposal. So yeah, you can see here, you can add breakpoints, you can expect variables, we can check responses, we can use the debugger, using the watch window. So you'll start to see these options of things you can use. And if you want to use one of these, you can further ask Copilot to break it down and sort of walk you through the process of using that particular tool. And again, if you ever get stuck, you can have it help you. You can ask it, what line should I put a breakpoint on so that I can appropriately see where it's running, or what variables should you watch, or how should you structure those watches most effectively. And just like with other types of Copilot prompting, you'd want to think here with your debugging tools, what's the context you need? In this case, I said I have VS Code, but maybe you have other extensions installed. Maybe you're using Visual Studio. Maybe you've got profilers or something like that that you have access to do to check for memory leaks. So make sure you include any of those that you're thinking about working with as well. And with that, we have covered all of the techniques that I highly recommend that you use to solve your problems. Above all, start with just passing in a really good context of what your problem is. Give it your code, sort of tell it where to highlight, give it the error, give it a stack trace if you have one. And then if those things all break down and you've given it everything you can and you can't get it to work, start to think about it like that tech support person, have it walk you through that process, and you'll eventually get unstuck. I've never had a problem that I could not get an AI like this to help me solve. Throughout this course, the goal has been to give you the information you need to solve your problems when making APIs. But there will be times when you need to make changes to your applications that go beyond your current knowledge. Even advanced developers run into this. And when that happens, AI tools like Copilot can provide critical assistance, help you learn faster, and even write code you didn't know was possible. So in this video, we will implement middleware components using Microsoft Copilot. So let's start by defining the problem we're going to try to solve here. Let's say I want to build some middleware that provides insights into how many times each of our API endpoints has been accessed. And maybe I think that there's middleware that can access the request through the context, which I think includes the path, but I'm not entirely certain how I would access it. So in a time like that, it would probably take me about half an hour to go learn what I need to do and build something from scratch and figure out what all the different APIs are and then design the data structures, then maybe test and implement the code. But using Copilot, we can significantly speed up that process, and you're about to see us do that. So let's describe the issue to Copilot. I'm not going to add a lot of detail here, and we'll see what it generates. You'll often have specific constraints you want to add, like where to store the count data. So let's start and ask Copilot something along the lines of create middleware using ASP.NET Core minimal APIs that tracks the number of times each API route has been called. That should work. I think that will be interesting. All right, so we can see here that it is creating a class that will have a request delegate. Then it's going to store them in a dictionary, which is awesome because that's kind of what I was imagining. I'm guessing here that each string would be a path, and then the int would be the count of the number of times that's holding them. So you can see here, it takes in a request delegate and then calls that delegate, and then has this task that takes in a context. And then it looks like it'll call, there's this context request path.toString. Perfect. That's the API I was looking for there. Then if request.count contains that key, go ahead and add it. So this is checking the dictionary to see if the key already exists. And if it does, go ahead and increment that by 1. Otherwise, add the new key and set its value to 1 because this is the first time it's been accessed. That makes perfect sense to me. And then context.response.on starting. Now, I didn't know this was a thing. So apparently when this starts up, we can actually have it do this and add it to our headers. Neat. That's a really cool API that is there. We will have to check to make sure that that's also not a hallucination. So then how to register our middleware. So it looks like it says this use middleware with request counter middleware. So this is imagining it's in a separate file. I'm going to be lazy here and I want to put these in a single file. So say, can you please add those both to the same file? So now again, we're seeing it generate the output. The thing to watch for here is to see if it changes anything. Again, every now and then it will actually change something between its generations, and it can cause you problems. But that looks like it made everything we want. So we can pop over to VS Code. And let's go ahead and put this code in our application and put it down here in the bottom. So let's go ahead and make a requests.http file. And so let's see what our routes look like. We have API route 1 and API route 2. Now let me see xresponse.headers.xRequestCount. So it looks like it will put the count in the header to let me know how many counts have been made. So we should be able to see that information. So let's see if I understood that correctly. Localhost 5170, the root. Then let's add a get here for the other two. See what we get. So /API/route1 and /API/route2. Send a request here. And you can see here that we got a request count 2, which might seem weird here because we've only accessed this once, but we didn't, because when it first opened up, it would have accessed that route when it opened our browser. So we should send another, and we can see request count 3. We can get here, there's 1, there's 2, there's 3. I come back to 5170, and I'm guessing 4. And then over here, I should see 1 when I go to route 2. All right, so excellent. Now it looks like this is doing what we want. It is sending back the data in the headers, but let's say maybe I don't want to send the header data back, the counts, to everyone who requests this API. Maybe these are actually the routes I'm going to have available publicly, and maybe I want to create a custom route that will show me which routes have been accessed. So now I want to be able to have data that is in this middleware available to an external route. And so in this case, I think the best way to do that might be with a service, because then we will have this thing that will hold on to all of those request counts. Then we can use it in the route, we can use it in the middleware. And when we make it as a service, if we ever wanted to change the implementation, maybe we move it to a database or something, it should give us a really nice interface for doing that. So I'm going to come down here and let me ask it to say, add a service that manages the dictionary. Awesome, and you can see here it's creating that dictionary, again with a string of the int, and then it's giving us some methods here to increment the count. That looks like it copied the logic from before, and then we can get the count for a particular path. Can you also add a method to return all of the counts, because maybe it makes more sense as a list or something. And again, it's looking like it's consistent. We're watching for any problems. We added this new method, get all counts, that will return that dictionary. Awesome. So we can copy here and then go back over and let's add this service. Okay, and now we have this service in here. Now I did not look to see, did it show us how to implement that into our middleware? And of course it did, because it's awesome like that. So we should be able to take all of this and replace the top of our file with it. Down and replace those. So we still got our classes. And so now just checking this, got the builder. We add the singleton for the service, take the builder, use the request middleware, and our middleware now needs to expect that service. Let's again see if it gave us the code to do that. Can you show me how to use this service in the middleware? So you can see we need to modify the middleware to use this service. Excellent. So now this should expect a service, and then we use it in our application. So it looks like that's all handled in the middleware itself. I'll grab that. I will come over here and I will replace our middleware. Make sure that actually copied correctly. That looks correct. I will save that. Yes, restart my application. Oops, got to click it on my terminal. I will just paste that back in there, save it again, and hit yes. Now it should be rebuilding. And now the first thing I'm going to do is go to /API/counts. And let's see if that works. Excellent. So now I have been to one route one time. Now let's go to localhost and API route 1 and send a request. And now you see that we have these additional counts. And I got another instance when I went to counts again. I can keep sending this, counts, going up. I can go to route 2, and that should add route 2 in. So perfect. That is now working. There we have it. We have successfully used Copilot to create middleware that adds a service, creates a route, and then tests that middleware using the code we've generated here. And it absolutely works. And we did this all in 5 or 10 minutes. We've demonstrated how to use Copilot to create middleware based on a specification we already have in mind. But what if all we have is a problem and we need Copilot to help us find a solution all the way to implementation? Well, fortunately, Copilot can do just that. In this video, we will manage the middleware pipeline in ASP.NET Core using Copilot. Let's start with the issue I'm having. I'll go ahead and type into Copilot, I have a website that is getting hit with spikes of traffic. What do I want to say here? And that's causing performance issues. How can I solve my issue? So let's see what it looks at. So handling traffic spikes can be challenging. Several strategies: rate limiting, caching, message queues. Okay, so let's sort of look at these first two options here. Rate limiting to control the number of requests a user can make within a certain period of time. That might be what we want. ASP.NET Core provides built-in middleware. Love to hear that. The other option that we have here is caching. So use caching to store frequently accessed data in memory, reducing the load on your database. Well, we're not going to be using a database. Caching can enhance scalability and performance by allowing you to handle increased traffic more efficiently. So looking through here, message queues, load balancing, performance testing, these are all a little more technical than I want. Loving the idea that we have rate limiting here, and that might be an option. If I can limit the rate at which users are coming to my website, that sounds promising. So let's see if we can get a little more detail there. Say, when would it be appropriate to use rate limiting? And so a question like this can help us sort of ferret out how Copilot is thinking about this problem. Maybe it has some faulty logic. This will give us a little bit of how it's thinking through. So it could be abuse. So maybe those spikes aren't just people loving our website. Maybe it's someone doing something malicious and trying to actually stop others from getting to our site. We can ensure fair usage. Love that. We can limit and manage the control and consumption of resources. Again, we don't need to worry about databases, memory, and CPU usage. Cost control, love that. So maybe we don't need servers that are as big. Okay. And then compliance, to adhere to the service level agreement or regulatory requirements that mandate limits on the number of requests processed. So we're not going to have a service level agreement for this application. But it sounds like maybe rate limiting is what we're looking for. There was an implementation in ASP.NET. Okay, I buy this. I want to find out more about rate limiting, and it looks like it's already provided us with a link. Excellent, love this. So if we scroll down here, look a little bit what we have. So the first thing I see is we have rate limiter algorithms. So it looks like there's maybe different types of rate limiting. Fixed window, I could read through all of this, but I'm just going to have Copilot tell me a little bit more. When would I want to use each of these types of rate limiting? And then go ahead and pass in that fixed window, sliding window, token bucket, and concurrency. So fixed window, limit the number of requests within a fixed time. 100 requests per minute. The counter resets at the start of each minute, regardless of when the requests were made. So that sounds a little bit blunt, but simple. When you need a smoother rate limiting approach that avoids spikes at the boundary of fixed windows, algorithm divides the time window into smaller segments and slides the window over time. Well, that sounds a bit more complicated. Token bucket, when you need to handle burst traffic while maintaining a steady rate of requests over time. Token buckets are added at a fixed rate. Each request consumes a token, and if the bucket is empty, the request is denied. Allows for short bursts of traffic up to the bucket's limits. Interesting. So we have one that sort of tries to smooth out, and then one that allows sort of spikier usage when you want to limit the number of concurrent requests being processed at any given time. So I don't think that's what I'm looking for. These are both interesting, but they sound a little more complicated, and they both sort of meet different scenarios. I often find it's best to implement the sort of most blunt option first. So it's not very targeted. It's just broadly limiting the number of requests per unit time. But let's try that before we go too far down any other route. So let's ask Copilot to generate something for us. So let's say it seems like the simplicity of fixed window fits my use case. Can you show me how to implement this in ASP.NET Core using a minimal API with the built-in middleware? So let's try and make sure that it doesn't try to sort of custom roll us its own middleware. And so it's generating some output here. We can go ahead and look over on this side and look to see, does it look like it's sort of following the docs to make sure it's not hallucinating here. So we've got builder, services, add rate limiter, takes in some options. Now this looks a little bit different, but we'll see if it still works. This might just be a different syntax for doing the same thing that the code is over here. But if we run into any problems, we might want to use something more like this. Well, all right, this looks like it has managed to generate some code for us. So this is a great example of how you can use Copilot to go from having a sort of rough problem that you don't really know how you're going to solve, all the way to having it help you actually build a practical implementation that you can then take, copy into your code, and test. All right, let's bring this all together. We've made some of our own middleware, and we've learned about custom middleware. Now let's combine it all into a single project and have Copilot help us ensure everything is incorporated correctly. So here I have our standard CRUD API that we've been working with. Again, it's just a blogs API, has these blog objects, and we have standard CRUD operations for getting those. And then the middleware that I want to implement here, the first one I'm going to grab is from a previous video where we created the path counting middleware. This is a middleware that will count each time that we go to a path in our application. So the first thing I have here is I have my request count middleware. This uses our service, so I need to make sure I grab where it adds in the service. And I also need to make sure to grab this service. So let me get all of this code. Let's go ahead and copy that, and we will paste that into our other code. Okay, so now down here at the bottom for all of my top level statements, and let's see here if I get any warnings or errors. Looks like I didn't need any using statements there. Awesome. So let's go ahead and test this to see if this implemented correctly. Except I need to grab one more thing. I want to grab my service. Surprised that didn't give me an error, and that comes here on the builder. Excellent. And then I also want to grab the route that will return my counts. Okay, so let's go ahead and open up a terminal and say .NET watch run. And then we will see this open in just a moment. While that is working, I'm going to come over here and create one more request for get localhost here again. And this is using a new port now, 5238. So I will replace that port. To open this back up, we will replace this 5238, and now we have the correct port. And the last thing I want to do here was change this to counts. Okay, and then I need to add those up there. So now I should, in theory, be able to hit this counts route. I'm getting a 404 not found. So if I come back over here, it looks like that needed to be API. And now I can send that. And now I'm getting an empty object. So something is wrong. It's a 200, so the server is up, the server is running, but something is wrong in the way I implemented this. So I am going to go ahead and copy this, and let's go over and see if we can't get Copilot to give us a hand. I'm going to open a new window. When I try to access my counts route, I always get an empty object. All right, so it looks like I might be missing my middleware. So let's go back and look at our code. And it is indeed, I added the service, I added the definitions, but I did not add my middleware. So let's see how we were doing that in our previous code. And that's totally the type of error that it could have taken me ages to figure out what was going on there. But instead, I can just simply pass it into Copilot, and Copilot helps me out. So we added a new middleware, so I need to make sure I reload my app. Looks like it's now running. Let's try this one more time. Hey, and there are my counts. And it looks like I never removed this header, so I also want to go ahead and do that now from my middleware. Somewhere in here it's setting the headers. And now let's say I wasn't sure what I could remove in here. So let's go ahead and grab a copy of this, and let's go back to Copilot. Let's see if it can help me remove the right part of the code. I don't want to return the count in the headers. How can I remove this from my middleware? So we'll go ahead and ask it to stop responding because we got what we needed out of that previous conversation. And this is a point where if it doesn't give me a good answer, I'm going to go ahead and start a new conversation because this is a bit different. I stopped the previous conversation, it might get a little bit confused. So here we can see you can simply remove the context.response.on starting part from the middleware, copy that, pop back over, make sure we get the right code, and let's just replace our middleware. I'm going to test this one more time, make sure I restart my server again so that I'm seeing the reflected changes. And I'm hoping to see this header go away. Excellent, so now it's just giving me that without always returning that count. So only this route is returning my counts. And I can see here, I can try to go to a couple different routes. And there we go, I'm getting counts for all of those. That's exactly what we are expecting. All right, so next up I want to grab my rate limiting middleware. Now this middleware we haven't tested yet, but we produced this at the end of a previous video using Copilot to generate this code for us. And so I want to use this add rate limiter service. Looks like we've got the builder here, we've got use rate limiter, and then we've got this require rate limiting fixed here in our code. Now I'm afraid I have enough code now that if I copied it in and asked Copilot to add this in, that I might end up with some artifacts where it's accidentally added things, removed things, or changed my code somehow. So I am going to sort of manually pull these steps out. So let's go ahead and grab this service. So we will add our service here. Now we've got add fixed window limiter. Does not contain a definition for add fixed window limiter. Let's go ahead and add the rest of the code first to see if any errors go away, and then come back and see what we need to fix there. So now we will grab our rate limiter. Not a problem, so it's saved and it tried to run the code, so that is normal. We expect that. And then we have this method here at the end, this require rate limiting. I think those are the only pieces of code we need to add. It looks like we might want to grab these statements up here to see if those make a difference. Okay, that goes at the end of, looks like all of our methods. So we don't have to rate limit everything, I would guess, by doing this, but let's go ahead and add this at the end of all of our methods. Now, if we save, we still get that error. Grab the using statements here and see what we get. And we will give our type checker a second to make sure that that is actually correct. So if we grab this, let's go back to our Copilot code and see what it says. All right, so it looks like that's still not working. So let's go look at learn.microsoft.com. And we were looking for learn.microsoft.com, and I had this up earlier, the rate limiting middleware. So let's see what we are looking like, because maybe it didn't quite produce correctly. So it looks like this is different. So policy name fixed and options. And then this second argument, it's using permit limit, window, process, policy, queue limit. Okay, so it looked like it got close, but didn't quite get us there. So let's see if we can fix this. I'm going to grab these arguments here and then copy and paste those there. And now these aren't policy anymore. These should be options. And now it looks like we're successfully building. Okay, so that seems to have worked. And now the first thing I want to do, create some kind of a limit that I can actually test on. So let's say I only have a permit limit of 2 and a time span. I will copy this line and comment it out so I can come back to it. But we probably want to make this something much more restrictive. There's a time span from minutes. How about from seconds? So let's say that is 5 seconds. All right, so let's go ahead and restart our server in case that service changing did not hot reload. Okay, now we should see some kind of a rejection. We haven't actually tested this yet. When we make more than 2 requests per second. Now you can queue 2 additionally, so we might need to make more than 4. Let's go ahead and test out how this behavior looks. So I'll put in 1 request there. That one's fine. That one's fine. That one's fine. Service unavailable. Excellent. So if I make too many too fast, I get this service unavailable, which is exactly what I was hoping for. All right, perfect. So that looks like our rate limiter middleware is working. All right, so let's go ahead and just test a little bit further here. We should be able to come and see, let's shoot a couple more requests out. Let's come over here and let's try our counts route again. We can get that a couple of times. Now let's see if we can actually get our, yes, we can get that 503 service unavailable by hitting another route. Excellent. We can hit all kinds of routes and we can sort of juggle back and forth between them. And you're seeing that we are limiting the rate at which users can come. And finally, the last thing we'd want to do is come back here and maybe set something more reasonable. We'll say that you can make 100 requests. And this was that from minutes 1 minute. So 100 per minute seems pretty reasonable for this application. We're not going to be using it very heavily. And if we do start bumping into issues, we can go ahead and bump these rate limits up, and we could do something like use our counts to make sure that we're actually seeing how many times people are trying to access different routes. And with that, we now have our working CRUD API with 2 excellent middleware that perform some real utility for us. And you can go and explore some other options, use Copilot, see what else you might be able to do with this. Maybe you want to implement the ability to have images attached to your blogs. You could use something like a static file middleware for doing that. Or you could just have it tell you what other kind of middleware you might want to implement. There's all kinds of options you have, and Copilot can help you at every step of the way as you build an application like this.
Congratulations on completing the Backend Development with .NET course. Throughout this journey, you've gained a strong understanding of the .NET platform, set up a development environment, and mastered C# syntax. You've also developed skills in building web APIs with ASP.NET Core, handled routing, dependency injection, error management, and logging. We began this course by exploring the .NET platform, focusing on its main features and comparing .NET Framework with .NET Core. You also learned how to set up your development environment, understand C# syntax, and work with essential libraries and packages. Next, we move on to building web APIs with ASP.NET Core. This included creating a simple web API, setting up routing and attribute routing, and incorporating dependency injection. We also discussed error handling and logging practices to ensure your APIs are both reliable and maintainable. Then we explored the concept of serialization and deserialization in .NET, focusing on managing these processes effectively while keeping performance and security in mind to protect your applications. Afterward, we examined middleware and OpenAPI integration in ASP.NET Core, focusing on how middleware manages requests and responses. We also explored using Swagger to generate API clients and covered best practices for designing efficient middleware. Finally, we looked at how Microsoft Copilot supported API development, helping with tasks such as writing and debugging API code, implementing middleware, and utilizing Copilot in a complete API development project. You're equipped with the skills to build back-end systems, create web APIs, and enhance your workflow with Microsoft Copilot. Use this knowledge to tackle new challenges and drive innovation in your projects. Congratulations on completing the back-end development with .NET.